Perfect. Thank you.
Good here. Good. Basically, they'll be starting soon. Can you help us? So there'll be pitch competition projects right now, and maybe because I mean this the whole point of it is we have this 16,000 express pool. Maybe you can just like a short message of what each project is doing and who's the winner.
Yeah. And we announced
Today. Yeah. No, today in like 3 hours. Yeah, just right now. They do.
what is the next stage?
Here it is. This one. Here are the panels. Each room is here.
Okay. Yeah.
This one's the tech room. So you dig up here.
Okay.
Cool.
Are you Arsene's friend?
Yeah, we work together.
Hey, hi. I'm Amy. I'm from the zkDay Med Network. And yeah, it was nice. I remember you wanted to be the note taker and also using the thread for today, right? Do you add each other's programs that like your posts on one Telegram or your routine and also you can share content? because I'm also like I'm working on the social media. Is this game? So I just go straight and see the conversation.
Yeah, I will send you the link to the thread. So the publishing that's how to do that. Then you just follow
Okay, so make sure that you tag ZK.
Yeah.
Okay,
All right. Hi there, everyone. Welcome to the first chapter of zkDay, which starts with the startup pitches. And so today we're going to hear from 9 different startups. Each of them will have 5 minutes to pitch and 2 minutes of Q&A from our judges. And from there, we have 3 top winners who will be going home with prizes from the judge pool. So we will begin in just a minute. Thank you very much. And hope you guys all learned something.
our first. I have a check on the website. If you don't have any changes in it,
there is a change. It won't be lambda concept.
okay. Could you please send it the updated version?
The update I didn't,
Okay,
but
just
I'll just make sure
I will
that
keep in mind that.
yeah. Okay, I'll text you.
I don't think I'm gonna make it through all the pitches. Do you know how far away the event, like ECC, is from here? It's about to get close. So I figure like 15 minutes. Yes. So like up and stuff. I don't know. It's pretty tight. It's pretty tight. Even. I think I should leave now. Oh wait, hold on. Oh no, 1:30. Oh yeah, it's like you're not gonna leave right now. Oh, okay.
All right, sorry, some technical difficulties. Please don't scan this QR code. I need to scan this QR code. That's easy. Hello? Am I good to begin? Yes. All right. Hello, everyone. My name is Jose. I'm the founder of Entropy. I'd like to thank Kenny and Manta for the opportunity today, and I'm very excited to introduce what we've been working on for several months now. So this is virtual rollups, and I could spend a bit of time telling you, I guess, how it works, what it does, why we do it, but I thought a demo was the most risky and the best way to show you how it works. So this is a Web3 game. Now, when you think Web3 game, autonomous worlds, fully on-chain gaming, these are hot topics. And no game, in my opinion, is actually on-chain. The UX is bad. You're spending a lot of time opening MetaMask, approving gas, spending transaction fees, no matter how composable the L2 beneath it is. And it's also very blatant. You are wasting time. You are, the experience is just overall not super solid. Now, if many of you are familiar with state channel technology, this is basically the idea that we can put escrow collateral on chain, and rather than put a transaction on blockchain, so say that I need to send $10 to Kenny and then send another $10 to Kenny and then another $10, why not basically put that collateral on chain first? Then I can use my same private public key pair and send that directly peer-to-peer to him. And taking this idea, he can bundle those transactions using my signatures and send it all at once for the price of one transaction as opposed to 10 or 100 or however many. Not only is this good for gas costs, but it is absolutely great for latency and user experience. And if we are to bring on the next billion users to Web3, we need something that the three of us can figure out to set up, a minute before this starts. And we were able to do that because it is that simple. And so this is a game of Connect 4. And if you want to go check out the round proof verification, I don't know if you can get to that here button. Basically, what this is simple Connect 4 game, but it is peer-to-peer. So me and Kenny are communicating directly to one another. There's no server involved. There is no centralized entity or third party. And every move is signed using our ephemeral keys. And this means that whenever another player gets a new move, they're going to re-aggregate this using a BLS signature. And so that you don't actually need to store all of the signatures or all of the moves.
you have re-aggregated the last state. So you're storing just this position. Maybe we can get to the round proof verification that will show basically that at any point, either party can unilaterally prove this on chain and bring up the results so that you can show, oh, look, Kenny won or I won, and you can use this for example, social networks. If I want to like, follow, comment on something, I can do that all in one transaction and never interact with the blockchain. I can use it for real money gaming and a trustless system for creating and bundling all of this very cost effectively. And this is effectively what we do. So virtual rollups, gas-free instant transactions. It's a scaling solution built on the state channel technology, while also allowing unlimited players and dynamic entering in zkDay. So this is important for example, game lobbies where you want to have people join and enter very easily. I guess I'll take a step back, talk about the team a little bit. So my name is Jose. I'm the founder of Entropy. I dropped out of Yale last year, much to the chagrin of my parents, to build this. Our CTO is Dr. Alexander Atamanov. He is a PhD in cryptography. We went through Binance's Season 5 incubator and just raised 1.2 million from a round led by OP Crypto, and are currently doing our closed beta with 7 of the largest games and iGaming platforms that are using this technology to increase their user bases, appeal to Web2 audiences, and overall lower their gas fees and costs. And yeah, we're pretty excited to kick this off and get it going. I guess I can also talk about the market. So we are focusing on SaaS strategy directly on the gaming side. We're also looking at ecosystem and how we can be a, I guess, addition to even layer 1s and layer 2s, while lowering their costs still and basically increasing compute and transparency and reducing latency, improving UX on the gaming and the social side, as well as we're also working with loyalty point providers and other cool stuff like that. So I will stop there for questions.
Yeah, thank you, Jose. If anyone from the audience had questions, I'll just move the mic. Yeah, go ahead.
Are the judges allowed to ask questions?
Yeah, sure.
Okay, cool. Yeah, very cool project. So like in games in general, how do you prevent people from, like, let's say during Connect 4, I know that I'm losing pretty badly, just like not submitting signatures, and just a little bit of follow-up. So for signaling, are you guys using like WebRTC or something like that? Do you have any plans for decentralizing? Like you have to have, just to like punch through now, like you have to have some kind of like server that you talk to just to like get the connection started, right? So.
Yeah, absolutely. So we use a server for point of contact. We can use the blockchain for that as well. We use a peer-to-peer mesh network for the actual ongoing communication. And your first question was if someone's up with the dropout problem, because peer-to-peer communication is rage quit, exactly. It's really easy to actually do peer-to-peer communication. This is not difficult. What's difficult is what happens if I do stop sending signatures. So at every single move here, so all of my little Connect 4 icons, signature was sent alongside that and it's stored on the local device. So this is why it's fault tolerant. It's unilaterally proven. However, of course, what if Kenny has not won yet? What if he has 3 in a row and I have my pieces? Well, he can prove what the game state is. And so what he's going to do is put an interaction on blockchain, saying this is the current state. It's too difficult for most games. For example, say a first-person shooter, you can't evaluate who's winning in that position. Connect 4, you probably could, just based on he's 1 move left. But what we do is he puts a post on chain saying I'm live. This is the current state. My opponent is not replying. If my network has failed, I can stop replying. I never do that. I never interact on blockchain. He knows then that I wasn't live, and the contract knows it. However, if I do, and I'm saying that I am interacting, I am live, what's going to happen is there are other people in the virtual rollup that this becomes a minimum trust assumption. So say that me and you are playing, we're going to propagate it out to everyone else here, and they become basically a relay. We only need 1 honest participant here. And so it's not like a social consensus. It's 1 person receives both our communications and we communicate through that person. And if no one receives any communications today from my side, we know that, well, no party can prove that they had my signatures and therefore they won't appear on the contract. We can talk about it.
I think we have just one maximum 1 question left. If you want to follow up or.
Yeah. So is there like, you can always do that, like have some kind of like timer or something where it's like if you don't submit a signature, then whoever submitted and whoever didn't. Of course, there's the issue of someone just like DDoSing the other person, but you can't really get around that. Is there a simpler way to do this? And like also, I'm just curious, like other than, do you see your guys' platform primarily serving gaming? Are there any other use cases that you guys have in mind?
Starting with the second question again, yes, we're looking at social as well. So we're actually working with some email providers, social platforms. That's even easier because you don't need to do the collateral on-chain first. So it becomes one on-chain transaction rather than one buy-in, cash out. And we're also working with loyalty point providers, eventually DeFi as well. So if you think of like Alice to a DEX, Bob to a DEX, Alice and Bob can't communicate, but through the DEX, you can have a channel through a zkDay recursive memory device. We're working on that. Answering your first question, yes. So there is a simpler way to do it with poker, which is where we actually began. You can just finish the interaction on chain. So I do my buy, I fold, do this, we just finish it on chain, right? And that's in the case of a dispute, which rarely happens because it's provable and you could just slash that person. So it's never in someone's interest to do that. But in most games, like non-turn-based games, like RPGs and stuff like that, you need to do something like the relay.
Okay, makes a lot of sense.
Thank you, everyone. And
Thank you.
Stan, if you want to play your connect for yourself.
Okay, so we'll be welcoming Zero Gravity for our next speech.
Okay. Could you get the presentation up too? Just make sure the clicker works. And it does not work. Oh. All right. Good. Well, hello, everyone. I am Michael. I'm the co-founder of Zero Gravity. And my story actually starts in East Berlin. When I was very young, I saw the Berlin Wall fall. And the energy was palpable. People were running towards the wall. My parents were celebrating. And in a flash, in a blink of an eye, my life totally changed. My dad eventually got a job at SAP, a Western German company, and with that, we got to move to Silicon Valley. Unity meant prosperity and freedom. But there was one area where I was not feeling free, and that was my relationship with my dad. See, I never was good enough for him. Whatever I did, I never felt good enough. And so what I tried to do is I tried to prove to him that I'm good enough, try to get the most prestigious jobs, the most prestigious schooling, or for Bain, for Microsoft, for Bridgewater Associates. But no matter what I did, I never felt good enough. And I got so angry with myself, I eventually had to leave Bridgewater and go on a search for meaning. I got into transcendental meditation, landmark education, and I had an aha moment. See, my dad was my Berlin Wall. And when I realized that, I called him up and I said, "Hey, Dad, first of all, I love you. I've been running a story about you my entire life, and it's time for me to take 100% responsibility." And that changed my entire relationship with him. And that's how I got into entrepreneurship, which brings me to Zero Gravity, because I want to break down walls. I want to break down walls in Web3. See, in Web3, okay, this clicker's not working. Sorry, could you go to the next slide, please? This clicker is not working. Wouldn't be a good pitch without technical difficulties, right? Okay, go back. Back. Second slide, please. Yeah, so in Web 2, we've got TCP/IP. It's creating a thin waste. Everything's built on it. In Web 3, we've got walled gardens. And it's time to break down those walls. Next slide, please. And what's even worse, in every Web3 cycle, we get new chains, more fragmentation, more liquidity that's spread all around, and really hard to access. Next slide, please. And so that's what we're building. We're building the common Web3 protocol stack. We have a bridge layer, a consensus layer, on top of that, an app chain layer as well. And we're designing it in such a way that we enable maximum user freedom and maximum modularity so that we can mimic the success of TCP/IP. And so at every stage, there's lots of technical innovation that needs to happen in order for this to work. At the bridge layer, we need zk and optimistic rollups so that we essentially can do second transfers instead of hours to build true cross-chain applications. On the mainnet, in order to produce 200,000 transactions per second and 1 second finality, we have to get rid of state management bottlenecks and do things like vector commits, for example. And we also have subspaces on the main chain that run multiple virtual machines in parallel so that you can do atomic cross operations really, really seamlessly between, for example, Move and the EVM virtual machine. And then on top of that, you can easily scale your applications by being fully connected to the rest of the ecosystem and having complete access to all liquidity. And of course, there's a lot more, but what we're designing for is maximum ease of use, maximum security, and maximum extensibility with zero gravity. And this enables total freedom and lots of new use cases. So use your favorite wallet for all of Web3. If you want to use Solana on Aave as your collateral, you can do that. If you're a developer and you want to run, for example, Python smart contract together with a Move smart contract, you can easily do that and access all liquidity. And of course, this requires a really strong team. We've built unicorn companies before. We've raised hundreds of millions of dollars. We've driven hundreds of millions of revenue. We have 10 different Olympic gold medals. We've got 10 different computer science PhDs. And so it's really important to have a strong team in this space. And of course, we deepen our technical moat with lots of academic research that's produced by our team. And we will bootstrap our ecosystem through the Conflux ecosystem by taking over Shuttleflow Bridge, getting the top team, bringing on board the Asian developer community, and having top partnerships. And of course, we built a successful ecosystem before. Every quarter, we'll release something new. And so join us in breaking down walls and making Web3 life effortless. Thank you very much.
All right, question time.
Are they still doing Conflux?
So they will
all
move.
the people on the list.
Yes, they're doing Conflux, but they're moving into an advisor state and then focusing on zero gravity.
Okay, cool.
Yeah. Just like I was doing Garten and then moved to a chairman role. So similar idea. Other questions?
Is there any other questions? We can have one more. Any questions? Okay.
All questions answered.
Round of applause for zero gravity. All right, next up, Squirrel Labs. Squirrel Labs. Is Squirrel Labs here today? Okay.
Hey everyone, my name is Trevor from Squirrel Pay, maybe rebranding to Squirrel Labs, but for now it's Squirrel Pay, and we're building privacy-preserving payroll. So crypto payroll, of course, crypto payroll is highly in demand among crypto companies. It reduces a huge amount of bureaucracy in terms of paying from crypto funds for the companies, and individuals are crypto native, so it reduces their fees in getting their payment into crypto. And right now, around 90% of crypto companies make at least some payments in crypto. But of those companies, in general, only 30% of employees are actually paid in crypto. Only 30% opt to be paid in crypto, and that's largely because of the transparency issue around it. So transparency hurts the employer. They're unable to freely set the pay of different employees, knowing that everyone can see everyone else's pay. So if they know that their engineers can go on and see their top engineer's salary, they know that's going to create social issues within the company. So they're incentivized to keep everyone's pay the same. And on top of that, they know that other competitors can also see what everyone's getting paid. And so that creates a huge poaching risk as well. On the individual employee side, there's social risks in terms of, social dynamic within the company. If I know that my coworkers can see what I'm getting paid, they could think more or less of me because of that. It also creates physical security risks. If someone is looking for someone with a lot of crypto and they know what a specific person is getting paid, that creates a big physical security risk for that individual, just like a lot of physical security risks in the crypto space. And right now, the solutions are very messy. Essentially, they involve using public mixed pools by either the company or the employee. But both of these have a huge number of issues, as you can see here. Big ones include like the bureaucracy of linking the mixed pool payments with existing payroll solutions, and just huge risk of user error, right? Copying and pasting addresses around, copying and pasting zk proofs around. It's just not a good solution right now to separate the privacy preserving layer from the payroll solution itself. So what SquirrelPay does is it adds layers of anonymity using mixed pool. So initially the transactions are completely obscure, right? The employer puts funds into the mixed pool, the employees remove funds from the mixed pool. But of course, with the regulatory landscape, that's not always ideal. So we use attestations to generate these layers. And as an employee taking funds out, I can prove only the layer that I need to prove. So I can keep it completely anonymous at the top, or I can prove what employer I was paid by, or if I want to get more granular, I can prove the specific payment tranche, like the payroll for July 2023, for example. And moving forward, we aim to integrate upstream invoicing solutions and downstream peer-to-peer payments to help bring more of the ecosystem into privacy-preserving payments. So starting with the employer and employees is a great way to bring privacy both to payments by customers as well as these peer-to-peer payments. So this is how SquirrelPay works. Essentially, it's a big mixed pool, attestations and funds going in, funds coming out along with optional attestations to prove where they came from. And so quick slides demo here. This is SquirrelPay. We're demoing putting in funds to the mixed pool. So this is putting in funds for the purpose of July 2023 payroll. This will create an on-chain attestation and then deposit the funds on-chain. You can see the event here. So we get a batch ID 4 that represents this batch of payroll. Then we can transfer the beneficial ownership. That would be the employee payments. And you can see this is a completely private transaction. No on-chain transfers happening. It's all zkP. And then the last step is an employee removing those funds. In this case, they're withdrawing with the attestation proving that the funds came from that specific organization. But they could optionally, you can see here, we have attested withdrawal and private withdrawal. Private withdrawal doesn't reveal that attestation when they take the funds out. So that would be if they want to remain fully anonymous. This is me, Waterloo Computer Science, MIT MBA. My background is in building crypto options exchanges, Web 2 fintech, including a neobank, cybersecurity, DApps, all over the crypto and fintech landscape for the past 10 years. And I'm SquirrelPay. Open to any questions.
Yeah, so my question is that is the mixed pool a smart contract or so? Yeah, my question is that is the mixed pool is a smart contract or a server?
It's a smart contract. We're aiming to build that. So we're aiming to build a mixed pool to be compatible with any EVM layer 2 and hopefully expand beyond that as well. So most payrolls happening on EVM.
Yeah. Okay, that sounds cool. And yeah, this product is gonna be really useful, right? But like, the one question for me is like, what's the difference between Squirrel Play and Tornado Cash?
Yeah, great question. So that kind of comes back to, sorry, slides. This, right? This is companies, employers using mixed pools or employees. They can happen on either side of the Tornado Cash, right? This is what's happening today. But it's just not easy enough. So employers make this trade-off of ease of use and privacy, and usually they lean towards transparent and easy over the bureaucracy of dealing with Tornado Cash, because they have a crypto payroll system, but it's not integrated with Tornado Cash. And then beyond that, you don't have the layers of attestation in Tornado Cash. So it's very black and white, either fully transparent or fully opaque. And for a lot of employees receiving funds in certain jurisdictions, that just doesn't work. They need the granularity.
Yeah, got it. Thank you.
Can I follow up? Like, why do we need payroll to be like private? Like, isn't that very dangerous for investors of those projects?
Yeah, so I mean, it really depends on the project itself, right? Like complete DAOs, where it should be fully transparent, we're not targeting them, right? We're targeting this, 90% of crypto companies that make some crypto payments and some fiat payments. You saw it was really only 30% of people being paid in crypto, and most of those 70% fiat, it's because of the privacy issue, right? So it's already private, it's just not crypto. And the idea is shift from private fiat to private crypto. If we could get them to transparent crypto, I mean, arguably maybe better in some cases, but that's not who this is targeting.
All right, perfect. Round of applause for Squirrel Labs. All right, next up is S-Match.
Awesome. Hi, good afternoon, everyone. Thank you for listening to me present today. My name is Ricky, and I'm co-founder of AsMatch. So I'm going to be presenting something a little bit different today. AsMatch is a Web3 matching app, and even though we've only been 4 months in, so far we've amassed about 8K daily active users and over 20,000 downloads as well, which has been a great achievement thanks to our team. Our colleagues come from Web2 dating apps like Tantan, Soul, and more, which are based in East Asia. And so we've been able to scale and move quite quickly. So first, for some context, I want to just briefly introduce and talk about the online dating market. So it's a big industry. All of you guys have probably used a dating app at some point, right? So nowadays it's probably the most popular way to meet and interact with people online. And so there are big players like Tinder, Hinge, Bumble, and year by year the market is growing annually. And so we want to have a small piece of that pie. So you might be wondering, okay, how do we differentiate ourselves from these Web2 matching apps? So I'd like to explain. Okay, so there are quite a lot of problems with traditional Web2 matching apps that you may have encountered. So for example, fake profiles, right? We hate matching and seeing, bots, fake profiles. You're not sure if you're interacting with a real and verified person. Also, the monetization, well, lack of thereof rather, because with apps like Tinder, Bumble, Hinge, you end up having just to pay a subscription in order to access certain premium features. And also, a lot of matching apps out there, they're quite unimaginative. They rely on the same basic criteria, matching criteria, right? And so what we want to do is we want to leverage Web3, this growing community, and add some fun ways for you to showcase your your Web3 on-chain activities, showcase some other aspects of you, and interact and meet with other like-minded people within this community. So how do we verify our users? Well, because we're powered by Manta Network, we integrate their zk SVTs into our app. So there are several zk SVTs that Manta Network has launched, and which has been great for us because we're able to add these into our app. And a lot of these zk SVTs have different use cases. So for example, the zkBAB and the zk Galaxy are KYC zk SVTs, and they're a great way to verify our users because they have to undergo each respective KYC procedure. And all the other zk SVTs that you can see right here indicate your on-chain activities as well. So it's a great way to not only match with users who have similar interests and on-chain activities, this also actually influences the matching outcomes as well. So 79% of our users have bonded at least one zk SVT to their account, and that actually increases the matching outcome by about 15% with another real user. So some other things to look forward to with AsMatch. We are free to play. We have several other crypto-based matching algorithms as well. So for example, once you create an account, you can actually add your favorite tokens, your favorite NFT projects, and this will influence the matching outcomes as well. And you can see who you match with and if they share similar interests with you as well. We are a Web3 matching app, so if you want to make friends, if you want to network, right, join this global community, we encourage you to use AsMatch, play with it, and talk to some people. We will actually be launching a very big update very soon. I can't reveal too much, but it will allow users to send, well, we call it like red envelopes. So if you're familiar with WeChat, WeChat has a feature where you can send red envelopes, like a small gift, to another user. So we're actually going to implement that feature very soon, which we're really excited about. And we haven't launched a token yet, but we will be doing that very soon. So for now, you can just enjoy being able to, stylize, personalize your account and match with other users. We also have some gamification features as well. So we have a limited match and chat battery. This is so to prevent people from spamming each other with bombarding each other with messages, and to incentivize more thoughtful matches and chats. We are going to add more features soon. We are still new. We're only 4 months in, as I said. So yeah, look forward to more things in the future as well. So thank you very much for listening. If you guys want to try our app, it is available on the Google Play Store. So you can scan that QR code over there. We're also on the app. Well, we're not on the App Store, but you have to download TestFlight as well. If you scan the QR code over there, you can go through the process. It's very straightforward. And you can use this invite code as well to enter because we are still beta. So if you have any questions, please feel free to ask. If not, thank you very much for listening and have a great week.
What's the demographic breakdown of your guys' users? Because that usually tends to be a very significant factor for the success of the data.
Yeah, sure. So I will address the elephant in the room, right? So right now the majority of our users are male. So that's quite
how much of the majority?
So I would say like a significant percentage, put it that way. But with that being said, that's why we are a social matching app. So before we did kind of class ourselves as dating, but we pivoted quite quickly. So it's more, our app is more just to talk to people, potentially make friends, and see what other users are who have also, for example, minted the same zk SVTs, or for example, in our next update, we're going to let users verify their assets, also their NFTs as well through POM.
Quick question. So if you're able to tell the demographic of your users, do you also know the personal data? Would it be better to not store this data somehow?
Yeah, so in terms of data, users can add basic information. Actually, when you register, you can just add a nickname, so whatever you prefer, in case you don't want to add your real name, for example. But in terms of data, the power of the zk SVT is that we can verify, for example, users can verify what assets they have or what NFTs they have, or for example, what zkSPTs they have, without actually having to connect their wallet or disclose their wallet address, which is great in terms of not having to disclose your private information.
I was really more like on their sex, gender, age, preferences.
Right. Yeah. So currently we do have that stored, but that is a good concern. Yeah, as of right now, we just have very just like basic information that you can add to your profile.
All right, I guess that's it.
What is your criteria for matching?
Yeah, sure. So we have several different matching algorithms. So the zkSPTs, that's a big factor. So if you have bonded a zkSPT to your profile, then you'll be more likely to match with another similar zkSPT holder as you.
Okay, so just mainly based on the numbers of zkSPT that you guys share with each other.
Yeah, so the more zkSPTs, the better. Also, if you hold the same zkSPT as another user as well. Okay, awesome. Thank you very much, guys.
All right, a very good presentation from Match. Next up, Photon from Lambda class winning project. Let's go.
Do we have any technical issue?
Yeah, can you have a presentation, please?
I can come.
Don't look.
All right, I'm coming.
Thank you. So hello everyone. Our journey has started 6 days ago. Me and my friend Don was talking about the Hackathon project. Like we were trying to find some ideas, and I've been building on Mina for a year now, and Don as well on Celestia. So we were talking about how we can actually connect the two, and we also had another friend Mohammed with us in the team. So while we were discussing, we realized that actually Celestia can be a real solution to Mina's off-chain data storage problem, because this is actually a huge problem on Mina. Mina is a huge solution for blockchain, but still the off-chain problem maintains. So we'll talk about this more. First of all, I want to say thank you to Lambda class team for having Hackathon. And yeah, let us present our project.
And yeah, blockchains, like when someone asks us what is blockchain, then I generally answer with the tool that allows you to decentralize the trust. It's so cool, but it is facing a real true problem. It is state growth. State growth is limits our decentralization and which hearts our tool to decentralize the trust. So here is where Mina comes. Mina limits the state within only 22 kilobytes within its perfect architecture, within recursive zk snap proofs. It is so cool, but it is also not perfect because you can only store only 8 fields on chain on Mina, which kind of limits the algorithms that you can do on chain in Mina. So for this reason, most of the existing blockchains on Mina and most of the blockchain apps on Mina relies on a centralized servers or like relays for this kind of data storage. But this is a problem because when you lose the data, then your zk becomes unusable, which kind of hurts the liveness guarantees that you should inherit from Minas itself. But right now, you are inheriting the liveness guarantees from another network. So we are proposing to use Celestia, a zkDay layer of Mina, to solve this problem. And here's the proposal. So why Celestia? Because Celestia uses erasure coding for guaranteeing the data availability, and it is so easy to verify the transactions within the user's browser. And so let us present our proposed architecture, and
Yeah, so in the architecture, it has 4 sites. First of all, there is the road user's browser, it's the local machine. So we can start by looking at user browser slash Celestia interaction. So first, browser sends the data to Celestia side, and Celestia sends a commitment saying that, okay, I have your data right now on Celestia side. And it's like, user is like, okay, I trust Celestia, because if you want to send data to Celestia, then you trust Celestia. But like, how can we verify that this data actually exists on Celestia? Like, he wants to use this data on a Mina zk app, so how we can? So at this point, our signer nodes come to the picture. The user sends the commitment to our signer node, saying that, okay, now I have this commitment on Celestia with this profile at this namespace, and you can verify. Signer nodes are Celestia compatible. They're actually like servers, very, very light, small VPS servers working online. And these nodes check that this data indeed exists on Celestia. And they verify the commitments. And once they verify, they sign these commitments using a Mina private key with a Mina Poseidon compatible hash, so that Mina actually can verify these states inside Mina smart contracts. So actually, in a way, the commitment becomes Mina approvable. So Mina can actually approve those in the smart contracts. Then the user browser gets back these signed messages, signed commitments, and send back to the zk app, so that the state inside the zk is updated, and anyone can actually verify that this data exists on Celestia without interacting with Celestia. If they have the data, they can actually prove that this data is correct using Mina Merkle tree root hashes. So why does architecture work so well? Is that first of all, the thing that we do is so very light. It's just converts the SHA-256 hash to Poseidon hash in a way using those signer nodes. And Celestia can be easily compatible with Mina. It just shows that it's not that hard to connect these two blockchains. It's just the mathematical architecture they use are different. But by making some small changes and actually having some trusted parties, you can verify some commitments inside Mina as well. So what are next steps?
The next steps for Photon, right now we are using scalable multi-sig architecture, but we are going to change into this architecture into multi-party computation to generalize this data availability that can be used networks that needs it, especially like the L2s or L3s or any kind of zk apps that needs data availability and liveness guarantees can use this architecture. And yeah, thank you for listening. And so if you have any question, like feel free to DM me, or I can take the questions right now. So I guess there's no question.
All right, round of applause for Photon. All right, next up, Paddle Labs.
Okay, perfect. Hello everyone, my name is Xiang from Paddle Labs and co-founder of Paddle Labs. So today I will introduce you a project, Paddle. So that is building the future of decentralized credit protocol. So existing credit systems encounter several challenges. First of all, they are controlled by centralized institutions, and which pose the risk of privacy breaches. And fragmented credit systems, cannot give a comprehensive view of individuals' credit. So finally, it's not Web3 compatible. So what we're trying to build is a credit system that relies on cryptography for the verifiability of all the data from like Web2, and ensuring our first priority is on real assets, which ensuring the authenticity and of all the data and supporting multiple blockchain systems. So yes, so our method actually ensure the authenticity and the privacy of all the data retrieved from TLS protocol. So TLS is a very standard protocol deployed in Web2. So it is widely used in web services. As you know, everyone knows HTTPS. So SPS stands for TLS. So actually, we designed a new cryptographic protocol that to accomplish our goal. So actually, we use a very new primitive called interactive technology proof to significantly improve the performance. So as a result, our protocol is like more than 10 times faster than previous ones like Deco. So yes, our protocol is so lightweight that we can execute technology proof inside the browsers and the mobiles for very complicated Boolean circuits like SHA-256 and AES. A series of experiments with provers deployed in 18 cities worldwide by to integrate with Coinbase and Twitter APIs to authenticate the balance of token and the accounts. So yes, our performance is remarkably satisfactory for real-world applications. And our core building is what we call interactive technology proof, which is a complement of snarks. So actually, we have pros and cons compared to zkSnarks. For example, we have very fast proving time and very low memory consumption, but the proof size is much longer. So it's very suitable for off-chain applications. But however, we can combine zk with snarks to on-chain applications. For example, in our framework, we're using zk to authenticate the source of data and then convert it into homomorphic commitment schemes, and then using snark to prove the properties of the messages according to the smart contract, which will be verified on-chain. So actually, we're providing a very new way for privacy-preserving applications for on-chain applications, right? So actually, we have a product. So our first product is extension. So you can use our product to access different data sources. For example, you can access different centralized exchanges. For example, we have now supporting 9 exchanges, and you can prove the amount of your assets. You can prove what kind of token you're holding in exchange. You can prove that your identification is verified, and then these credentials will be provided to different chains for different applications. Also, we offer a very lightweight and reusable eKYC systems. So once you get verified, your credential can be used multiple times. Yeah, our scenario, we spot a lot of scenarios like you can prove asset ownership, you can prove your financial status, which we believe that enable exciting applications. For example, credit lending, which is lacking in the Web3 space. So we're actually building 2 templates. The first one is the source templates for developers to access different sources. The other one is what we call consumption templates, which will be integrated to different apps, DeFi. Yeah, the business market size is huge for credit, so it will be like 200 billion in 2027. So our credit protocol will form a sustainable intensive mechanisms for among developers, applications, and users using our templates. So finally, our project is officially run by Eastman Foundation, And and the promise is getting inspiration. So actually, we are inventors of this state-of-the-art ICT protocols. So we are experts in cryptography, in product, and we have multiple partners. So you can try our test product here, and please feel free to contact us if you are interested. Thank you.
All right, question time.
By protocol, you mean that you will build your own network with your validators, nodes, right? Then you, on the next slide. About the business model.
So?
Yeah, no, about the business model.
Business model.
Yeah. I try to understand how you're going to monetize your protocol. So how
So you have this designed an intensive mechanism to incentivize that the users want to test their data, and the developer wants to develop different templates for applications, and applications want to use tested data. So we have to design the whole thing. But now,
So your protocol will be decentralized, right?
Yes.
Yeah.
All right, we still got time for one more question.
So you said you use TLS protocol to bring ocean data on-chain, but TLS protocol use symmetric encryption. So basically the server shares the key with the client. So how do you make sure the data is authenticated by the server in a symmetric encryption scheme?
So basically, the motivation that you can use the authenticity and the privacy of the standard TLS protocol. So TLS is, can authenticate the server, and you can preserve the privacy of all the data. So, but we're using MPC and zkDay protocols to, to separate the session keys to different parties, like Pado and the client. So we can make sure that every ciphertext from the client is actually from the server. So that's using new ideas and using the existing TLS protocol. Yeah, you can check the paper if you're interested.
Thank you.
Thank you.
All right, that's it. Round of applause for Pado Labs. All right, I think we got 3 more left for today. Next up is Icebreaker. Break some ice in this room.
Great. All right. Nice to meet you. I am Dan Stone and Web3PM.eth. And today I came to show you our zero knowledge demo for issuing zero knowledge verifiable credentials that you can use when professional networking. But last night I found out that this is a 5-minute pitch, and it's actually about the company. So welcome to the first ever pitch that we're actually making on Icebreaker. Since we're not actively pitching and we just raised an angel round in January, we haven't updated our deck, but I did one today for you all. So what are we doing? We are 51% attacking the big tech data monopolies, and in doing so, onboarding the world to crypto and self-sovereign identity. And I know a lot of people are talking about this kind of stuff. I actually built part of Google's data monopoly. And I'm sorry, I built their remarketing business. So those ads that followed you around the internet, that was me. I also built a bunch of other features that contributed towards all the signed in user data. And now I want to break that from the other side. I'm the co-founder and CEO. My colleague Jack is over there, also former Googler, big NFT head. And then 2 of our other team are not here, Sina, Eli, actually 3, and Emma. And we can talk about all the logos and stuff, but really I want to show you what we've been building and how we're trying to solve the problem, because a lot of people have tried to solve it before. So again, I'm sure you've seen slides like this before where everybody's talking about how Web 2 measurement is broken. And really, like, my only tweak on that is it's actually not Web 2 measurement, it's actually unconsented measurement. And Web 3 is just gonna have the same issue that I saw when I was in Web 2 with people opting out of cookies. As soon as we just start signing in and seeing targeted ads in dApps based on our wallet identities, like it's one click from MetaMask basically integrating an option to spin up a stealth address every time you sign in. And having spent a lot of time thinking about what the right solution is, I think the only way to solve it over the long term is by re-architecting the way that incentives and privacy and consent works, and actually getting consent from end users if you want to measure. And you don't have to believe me, Vitalik actually just posted this morning about using this exact type of approach to preserve privacy online when we're interacting at events, generating POAPs, interacting with brands, doing stuff in DeFi, etc. So that's what we are doing. We are re-architecting online advertising using a better architecture. And when I spoke to some of my former Google colleagues, they said that Google research looked into this. And the only thing that they think was a threat to their business was decentralized identity. But they decided it wasn't possible. Well, this will be not the first or the second, but the third billion-dollar product that I've built when Google VPs told me I couldn't. So where do we start? Because a lot of people have tried to solve this problem before. We're starting with 51% attacking LinkedIn. Because if you actually think about it from an advertising point of view, LinkedIn has the highest, by far, this is a logarithmic scale, CPM, which is cost per million, which is the main way that you evaluate advertising on the internet. And what we are going to do is build a better, fairer, and more trusted form of LinkedIn that also accommodates a non-linear work trajectory. And actually just yesterday on the right side, I met the real Eric at an event, and I had actually interviewed a candidate posing as this person. I'm not making this up. I have a witness who posed as this same person in a job posting I had a couple months ago. So this is real. Oh, how'd that get in there? Well, anyway, what we're doing is we're building in 3 pieces of the platform, an individualized NFT draw platform that works across all the chains, an IRL connections graph that is on-chain, but supports stealth addressing. And then the layer underneath is the identity, the credentialing, the trust, which is off-chain by default, but verifiable on-chain. And that's where we differ from some of the other folks who have been building in this space. So we're not going to go deep into our go-to-market, but basically we're focusing on mobile, IRL, make it fun, make it experiential, make it AI-driven, make it better than Web 2 UX. And my goal is basically if we can get muggles exchanging NFTs with each other. Revenue is basically taking the LinkedIn playbook. Their main business is advertising and recruiting. And I think we can actually make it better if you actually get a cut of all of the credits that people are spending to reach you. If you want to be reached at all, we can actually make it better and give you those credits so that you can then go hire the best talent. And so this is where some of the zk stuff comes in, which if you actually take a look at the QR code later, you'll be able to see the live demo of this. But basically, we've built a prototype with one of our partners, Jomo, where you can go to us, then generate a ZKP, proving that you have something else in a different wallet without sharing that wallet address with us. And then come back and use it as a verifiable credential so that when you say, hey, I got into crypto in 2013, and you meet somebody at a conference, you can actually prove it. So that's what we're doing. Thank you. Go ahead.
Yeah, so I think a key issue with people porting users from LinkedIn to a Web3 native LinkedIn is that the social graph is much more robust in LinkedIn. So how do you think about establishing a moat and what would really make users switch beyond verifiable true profiles?
Well, let me ask you How have you been connecting at this conference so far? Have you been connecting on LinkedIn? Oh, Telegram. Exactly. How many people use LinkedIn as their main connection source here? Exactly. So we're focusing on in-person events as a means of generating very high signal for building that initial network, and we're focusing on Web3 professionals because LinkedIn doesn't serve Web3 well. And my co-founders and I use Telegram, but it's also not exactly a professional networking system for manifesting who you know. And we love the Web3 social, but those are social graphs, and it's not actually a trust graph of who you know. So that is what we are building, and then we want to build the off-chain trust as well as the who you are and what this Web3 address represents that you wouldn't necessarily want to publish on-chain.
In the same boat, how do you compare to Farcaster and Nostr, a few of whom have unstructured data that they're sort of cleaning to try and parse? But then, is there a reason why you associate with a decentralized LinkedIn as opposed to like a decentralized Facebook, for lack of a better word, or lack of a better brand?
Yeah, so I alluded to it previously. I think the decentralized social is great. I don't want to create another place where you're posting stuff or where you have to claim usernames. I just want to be a different layer where you can then apply that on decentralized social. So imagine being able to see your Farcaster feed, but only of the people that you've connected with professionally in a particular discipline. Right? Think about it, part of the value of Web3 is its composability. And so I don't want to replicate Farcaster or Lens. I actually want to be able to have a feed within Icebreaker of all of your decentralized social and also within those social apps where you can basically see your professional connections.
And this feed, like a widget or whatever, will be ad blocked. Where how does the ad blocking or the privacy of the advertising sort of like the Brave browsers sit in the
Yeah, no ads for a long time. We did a lot of research to figure out how do you do this right. And our conclusion is that there's no shortcut around attracting and retaining high-value users, aside from just building a useful product with no advertising at all.
All right. A very good presentation, Icebreaker. Round of applause for Icebreaker. All right, next up, Noya.ai.
Test. Good. Yeah. Hello everyone, my name is Omar. I'm from Noya, and we're here to disrupt DeFi. Noya stands for Native Omnichain Yield Aggregation. Maybe start with the second slide. Yeah, okay. So the problems of currently with yield farming are it's time-consuming, it's highly technical, there are central points of failure, and retail users cannot quantify risk. So Noya came in to help. What Noya does is that it safely, non-custodially. Can you get the next slide? Yeah. So Noya provides safe, non-custodial, permissionless, high risk-adjusted yield across multiple chains using AI. So our solution is can you go back? I'm sorry. So our solution is AI powered. We use zkML. We are omni-chain and we're composable. So why and how do you want to use Noya? You can use Noya to optimize yield, diversify risk, increase rewards, minimize slippage, or maximize rewards. Protocols can use us, apps can use us, and roll-ups can use us. Our solutions where it gives you liquidity where it's needed the most, with our AI model that predicts yield and liquidity. It's Omni-Chain Plus. We use multiple bridge index aggregators to bridge from one chain to another. Our smart contract architecture is very modular, adding and removing any protocol whenever it's needed. However, in a world where trust is paramount, efficiency alone is not enough. Therefore, it's our honor to present to you our zkML implementation. Our zkML implementation allows our models to be predictive, private, with private weights, trustless, so that the model is fixed and committed, and verifiable. You can even verify our backtesting results. With our backtesting results, we give backtesting data into our model and we commit to them. And with our real-time data, we get real-time data on-chain, do the inference of it, send the proof of the liquidity on-chain, and then that only allows the liquidity to move from one chain to another. And it's not just talk, it's actually live. The first DeFi zkML vault is actually live. We're gonna launch it next week. You can check it out on noya.ai/zkML, and you can verify by yourself our backtesting results. We are currently verifying 1 million parameters on chain. We have verified 20 million parameters. We're aiming to verify 100 million parameters by the end of the year. We have done also a UniV3 automatic LP management using zkML, where the model in and of itself assigns liquidity in a specific range and time. Furthermore, we're looking to integrate more, even building our own one. You can even do a lot of fun stuff with this, because the AI model is living on chain. You can have an AI model that repays itself. You can collateralize an AI model. You can use this AI model and tokenize the returns of an AI model to everyone who contributes to this. So if you can play this video, please. It's not working. Anyways, okay, we can get the hang of it. Okay, so this is my Telegram. If you want to contact me regarding Noya and anything regarding Telegram, and this is our email. Thank you very much for the presentation. If you have any questions? Okay, if we have still 1 minute, we still have 1 minute. Can we play the video? That would be great.
Sorry for the technical issue. Well, if there's any questions,
meanwhile, any questions?
So if I understand you right, you train your model off-chain, then generate a proof that you can use this inference on-chain. So if I understand you correctly, so you train the model off-chain, then you generate the proof, the model, and then use it on-chain, right?
Exactly. And this, so this is 100% true. With the first ever DeFi app that uses zkML for any liquidity allocation. So we send a proof that this output is the same one, even with private weight. It has amazing music. So it's okay. This is it. Thank you very much, guys.
All right, is there any more questions?
Yeah, I'm just curious, what kind of ML model you guys are supporting with the circuit?
So right now it's linear neural networks, so very simple ones. As time passes, and we can use more advanced ones for sure.
And like for that, what skin you guys using?
Okay. I think this is more tailored to our skill.
Hello everyone, I'm Hadi, I'm the tech lead of Noya. You mean proving scheme?
Yeah.
We are using Halo 2 as our proving backend, and we are using zkDay for the implementation of ML models, and we are basically aggregating all of these models into one proof and then prove it on. Yeah, actually.
Understand. Yeah, that's all my questions.
Sure. If there's any other question. Thank you guys.
All right, today's last one. Banana Labs. We always save the best to the last.
Hi everyone, this is Huck from Banana HQ. We are building this account abstraction infrastructure. Let us wait for the slides to come by. So, like our aim here is we want to make Web3 easy to digest, and we are building a secure cross-chain account abstraction infrastructure for applications and wallets. For the same, let me just check the presentation. Sorry.
Sorry guys for this technical issue, but we're gonna have the judging over by the next 20 minutes, so stay tuned for that. I think we're gonna get this solved really soon, less than a minute. Thank you. All right, so today there's gonna be 3 winners, in total of 16K in prize pool. First place, $8,000. Second place, 5,000, and third place will be 3,000. That's the total prize pool for today. All right, please bear with me. Give us a little bit more minute on our last one. Sorry. Hey guys, I think the last one we gotta sit and wait for this. The last one is always the best. So everyone, just give us a little bit more minute. We can handle this. Okay. Thank you. All right, for those who just came in, we ran into some technical issue. So just give us a second. We still have one more pitch to go. And then after this, we're gonna have our judging announcement to be released.
Sorry to keep you waiting, some technical issues, but hopefully we'll have the deck and the demo right now. So yeah, I'm from Banana HQ. We are going through a rebranding. This is a slide that it's a previous slide that I had to use. Yeah, so we are building secure cross-chain account abstraction. And the idea here is that we want to make Web3 very easy to use. So Web3 has a problem of onboarding and retaining users. Apps find it very difficult to onboard and retain users, and That's due to multiple reasons. Firstly, yeah, the onboarding is complex. So for a user, let's say he wants to play a game, they first have to download a wallet, save the seed phrase, uh, write the seed phrase somewhere, and get some funds on the wallet, which requires multiple steps in itself. And even if they do so, these wallets are not safe. Most of our wallets get compromised due to poor management of secret recovery phrases. And the experience across chains is also siloed. So to access applications across different chains, users have to do swap, bridge, and then a swap again maybe, which all in all can be very daunting. And even for a user who knows Web3, it can roughly take 45 minutes to an hour to do all of this before even they can start using an application. So at Banana, we want to solve for these complexities. We are basically building this pluggable cross-chain solution that any application can integrate, and will be able to provide their users with one-click onboarding uh, across multiple chains. We are also very secure and seamless. So we basically store the private keys of the users in something called a secure enclave. So the idea is we basically have the security of a cold wallet and the convenience of a hot wallet together. We also have zero knowledge based two-factor authentication. So when the user is making a transaction of a very high amount, they also have to give like a two-factor authentication. Oh, okay, sorry. I hope you heard the past me for the past 2 minutes. Yeah, and we are also cross-chain native, so users can do one-click cross-chain transaction. All in all, using our infrastructure, an application can reduce their onboarding time to less than 3 minutes. Let's quickly see a demo. I'm not sure if this will work here. Can we move to the video? So we basically integrated our SDK with Lenstra, which is a decentralized social media platform. It built the video. Which is a decentralized social media platform. Now, like imagine a user kind of coming onto a platform and like a social media platform and a gaming platform and not having a wallet or not wanting to connect their primary wallet. What they can simply do is with our infrastructure, they simply have to click on Banana Wallet and we spin up a wallet for their user, a smart contract account, and we also generate a key pair on the user's device, be it mobile phone or laptop. And that's pretty much it. The user gets a wallet in less than 20 seconds, and they can start using the application. We are also cross-chain native, so as in a user can make a cross-chain transaction with a single click. I hope the demo works. Will it? Okay, so the demo won't work. Happy to show you the demo to each of you if required. I have it on my phone. But where are we now with this infrastructure? So, oh wow, it's working. Can work. Nice. So yeah, let's say a user kind of comes, clicks on login, clicks on Banana Wallet. They don't have a wallet or they don't want to connect their primary wallet. They simply have to give their username and get started with it. This is an optional step. They have to provide their touch ID. It can be Face ID in the case of mobile phones or fingerprint in the case of Android phones. And in less than 20 seconds, the user gets a wallet which is completely non-custodial and at the same time very easy to use. Now, this is a demo of how the signing a message would work with this kind of wallet. Whenever the user has to sign a message or a transaction, they again have to provide Touch ID. So now we can see that I have been logged in as Hub. Now, moving to the second part, where let's say a user wants to do a cross-chain transaction. Let's say there was a bit more of the demo. We can go back. Can we go back to the video? Okay, so the second part was basically where, let's say the user wants Lenser Premium and Lenser is on Polygon, but the user has assets on Ethereum or Optimism or any other chain. The user can basically make a transaction, a cross-chain transaction, and in a single click, he can basically pay for that feature. Can we go back? I think we'll have to cross that here. Yeah, so where are we right now? Having said this, this is a old slide that I have to put up, but we had focused in Q1 with integrations, and we have a few partners like Respect and Huddle01, which is one of our recent integrations. We are also live on multiple chains such as Polygon, and recently we have been closely working with Astar and Polygon zkDay, where the idea is we would want to be among the first players in the Web 2.5 space of smart contract wallet. We have more than 15 dApps that have already integrated us. We are cross-chain as of now. We will release a mobile SDK in this week, and the auditing is also in process. So currently, the idea around the GTM is basically we are working with applications, single dApps, and trying to partner with them which are working in the Web 2.5 space or even in the Web 3 space. And in addition to that, we are also working with ecosystems such as Astar and zkEVM, and like trying to be one of the first smart contract wallet infrastructures. In the wallet landscape, there are a few players who are providing this wallet infrastructure, but our solution is at this moment one of the most non-custodial and secure solutions, and at the same time a smart contract wallet, hence it can provide quite a lot of functionalities like gas abstraction, cross-chain, etc. We are backed by Longhash X. We were part of their Longhash Accelerator program, and Gnosis, and also Gnosis Chain, and we are working closely with some of the teams here. The core team consists of 3 folks as of now: me, Rishabh, and Nitanshu. But then we also have 6 more folks who are working with us as interns and as part-time. Yeah, so we are looking for dApp partners who would want to have a very seamless experience on their platform, and investors or folks who would want to learn more about this project. Happy to have an investment conversation. That's it from our end. Thank you so much for it. Yeah, open for questions. Yeah,
only for judges.
I wanted to ask that how will you manage the cross-chain system for like this space? I didn't know about this. Can you give a bit of?
Yeah, so with any smart contract wallet, it's interesting. We were in a account abstraction conversation with Ali was also there, and this was one of the hot topics around how do we manage smart contract wallets on multiple chains. Now there has to be a few things. Like ideally, it should be the same account address, and it should be interoperable in across chains, and that's what we are aiming for. How do we do it? Like when we create a wallet on a particular chain, we also deploy counterfactual addresses on multiple chains, and whenever the user uses those chains, makes the first transactions on those chains, we deploy a contract on those chains. So on a high level, that's how the deployment process works, and the transaction process. We basically leverage XLR at the backend as of now.
All right, round of applause for Banana. All right, that's it for all the pitching from today, and then we're gonna announce the winners and then have the judges introduce themselves. Each judges will get like roughly 5 minutes.
Hi everyone, this is Shu with Polyhedra Network, and I'm gonna introduce what Polyhedra Network is. Polyhedra Network is building the infrastructure for Web3 interoperability with efficient zero-knowledge proof technology. And we design and implement zk Bridge, providing the trustless and efficient cross-chain infrastructures for layer 1, layer 2 interoperability. With zero knowledge proofs, zk Bridge provides both strong security without relaying any external assumptions and a significant reduction in on-chain verification cost. And later on today in the afternoon, we have one keynote coming up soon, and we also have workshop, and we will have a panel discussion. So stay tuned today. Thank you, guys.
Hey everyone, I'm Emerson from Longhedge Ventures. We're a venture fund and accelerator focused on Web3. Of course, we're currently running a zk cohort accelerator as well. So we're supported by zkSync, Linea, Starknet, and a few ecosystem partners. So if you're interested in joining the accelerator, feel free to hit me up.
My name is Alex. I'm working in a new foundation. We are simplifying zk for developers. Particularly, currently we're focused on two things. First of all, it's zk LLVM. So this is a compiler which can transform your code of C++ or Rust into the circle. Then you can generate a proof. But also support the OEM mix, so you can use zkML application. Also, we have a proof market, which is a decentralized marketplace, and the people can sell and buy proofs. So we are next to simplifying zk for all classical developers.
Hey guys, Ian from Foresight Ventures. So Foresight Ventures, we are a crypto fund. So we focus on everything Web3 as long as the project have disruptive innovation. So we actually manage multiple funds, a VC fund, a secondary fund, a multi-strategy FOF, and a private market secondary fund. So our AUM is exceed $400 million. And Foresight Ventures, we are very actively, aggressively expanding our ecosystem. So we have very strong media alliance. We have Foresight News in China. We invest coins in Korea, Block Temple in Taiwan. So we want to, provide our extensive, valuable support to our portfolio company with this great growing ecosystem. So yeah. I mean, we also have a accelerator called Foresight X, and we are building our own more of a developer community, non-commercial public build. So if you guys interested or have any questions, talk to me after that. Yeah. Thanks.
All right, that's all the introductions from the judges. And then now we are going to announce the prizes. It's very exciting. So let my guy Kenny announce it. Okay.
All right, thank you. Yeah, so we're calculating the final scores right now. Just a reminder, so first place is $8,000, and then second place is $5,000, right? Yeah, and then third place is $3,000. So, good luck to all of the participants, and we are going to have a calculation in just a few seconds here. So we have the scores tallied. So hopefully all of the startups that were pitching just now are still in the room. So we're going to start with third place. And so third place with a score of 347 is Entropy. He's back there. He's coming up here. All right. Congratulations. All right. Do you have anything you want to say? I don't even know.
Thank you.
All right. Yeah, actually stand up here so we can take a photo together afterwards. And then in second place, we've got Pato Labs. All right, and then finally in first place, we have Noya.ai. Noya? Okay, all right, well, you know, who else wants it? It's the biggest prize. Okay, well, you know, we'll inform them. You know, it's blockchain. We can remit payment anywhere in the world. That's the beauty of it. All right, cool. Thank you very much, guys. And next up, we will have our first keynote of the day from Polyhedra. And so stay tuned, and we'll just take a quick photo and shift right over to it. All right, so now we'll transition over to the first keynote.
Let's take a photo here.
We're running behind. Thank you, everyone. And so we'll have our first keynote, and then we'll follow up with the layer 2 scaling panel.
Check. Hi, everyone. This is Polyhedra. I'm Tianchen Xie from Polyhedra Network. I'm co-founder and CTO. And today I'm going to talk about the full node proving in Ethereum. So here's our framework. The framework has three major parts: sender chain on the right-hand side, receiver chain, and in the middle is our zkP generation. So this zkP generation has one major task: it's to generate the state proof for the sender chain. So basically, it generates the validity. It's going to establish a validity for a block header in the sender chain, and it will prove it to the receiver chain. The receiver chain will eventually get convinced by the validity of the block header. And with the block header, you can use a Merkle tree or Merkle by user try to prove your transaction is valid. So this main task, proving block header, is very hard. Like if you take example, Ethereum as example, you are going to prove a lot of BLS signatures. And recently, Ethereum upgraded with a light client. It's using a sync committee where you are going to prove like 512 different validator signatures. However, sync committee got some issue. First issue is here, you only got 512 validators, and they are going to control the Ethereum blockchain for a whole day. So they only rotate every 27 hours. And if you look at the stake in each in these validators, only 16,000 Ethereum is staked here. And if you look at the total transaction volume in the bridge field, it will be 20 or 30 times larger than this stake. So if you are going to rely on the sync committee, you're going to get trouble. They totally have incentive to attack our bridge, and they can get 20 or 30 times the reward. And so if you look at the full node, full consensus of the Ethereum, for each block, it will have more than 20,000 validators. And the validator set will rotate frequently. Actually, it's for each block they will rotate once. So this is more than 20 times stronger than the previous one. And we initially deployed the solution for the sync committee, but we are going to move to the full node. As you can see here, the number of validators increased by at least 20 times, and they're going to rotate very frequently. So this task is like 20 times harder than the previous one. Another smaller issue is the sync committee are missing signatures. As you can see here, this is a valid block. However, sync committee only signed 45%. 45% of the sync committee signed, and this is going to be a rejection if you look at the sync lifetime flow. And this is another example. None of the sync committee signed this valid block, and we think it should be a bug in their code. So if you look at our problem, concretely or technically speaking, you are going to verify more than 20,000 BLS signatures for each block. So it is for each block, and if you need a real-time bridging, you need to set up a hard deadline. That's 20 seconds. Why? That's 12 seconds. Why? Because the Ethereum block time is exactly this number. And if you look at old protocols such as Gross, Planck, even Planck, Halo 2, all of these protocols, they are going to exceed this time limit by a lot. For example, if you look at Gross or Planck, they're going to be more than 2,000 seconds. And here's a chart of our protocol. Our protocol can prove 22,000 signatures within 10 seconds. And this included the recursion time. So let me give you a brief introduction of our protocol. It's based on my previous paper. It's called Verbal. This is a GKR-based protocol. I'm not sure whether anyone familiar with that, but you can ignore that. Basically, the thing is, Virgo is already 20 or 30 times faster than previous protocols, and we combine a lot of machines together to get even more computation power. And in our use case, we are going to use like 2 machines. is more than sufficient because it's already the speed is already fast. And these machines will collaboratively generate one proof as is a single prover. And this one proof will get recursively verified using slower protocols such as Splunk or Gross. And this small proof, this recursive proof will be so small that it can be fitted on chain. And the final on-chain verification cost is about 200K. And here's a live demo for a running prover. Yes, sorry. Yeah. Can you start? Yeah, thank you so much. Yeah, start.
I'm Tian Xie from Polytechnic Network.
Can you mute my video?
Show you all.
Thank you. Yeah, it's starting running. So first, let me show you our machine spec. It's LS CPU, and as you can see, it's a AMD 7763 CPU. We have two of them installed on the same machine. It will provide 128 cores for a single machine. This is a very big machine, and for this demo, we are going to run only on this machine. This is start working, and this is proving for layers of the circuit. So GKR protocol running on a layer circuit is going to be different from traditional R1CS. And as you can see, it's finished within 10 seconds. It just finished so fast. The video is 1x speed. It didn't speed up. And thank you so much. This is our Twitter code. And if you want to follow us, please scan it. And now, do you have any questions?
Do we have any questions?
Great, thanks for listening.
All right, thank you very much. And next up, we have our first panel of the day, and this will be moderated by Caldera. And we have guests from Scroll, zkSync, zkMIPS, and Linea. All right, here's the next mic.
Cool. Hello, everyone. Welcome to the first panel of the day. My name's Matt. I'm the co-founder and CEO of Caldera. We're a royalties service company. And I'm really excited to have many thought leaders in the ZK space here today to talk to you all. So to start off with, I think it makes sense for us to do a quick round of intros. Want to go first?
Right, okay. Start? Okay. Yeah, my name is Min Guo. I'm chief scientist at zkM, which is a zkMIPS based Ethereum layer 2 solution. Yes.
Cool. Awesome. Go ahead. Feel free to pass the mic down.
Okay, yeah, super happy to be here. I'm Antonio, developer relations engineer at Matter Labs. Matter Labs is the team behind zkSync. And yeah, for those that you don't know, zkSync is a layer 2 rollup powered by zkVM. We're doing things a little bit different from other teams. We have native account extraction. Yeah, happy to come here and talk about this.
Hi all, I'm Daniel Helm. I lead developer relations for the Scroll team. At Scroll, we are building a ZK-powered rollup, like I can folks here, but focusing really on developer experience and really focusing in on compatibility with the EVM, making sure that it's super easy for
users and developers to take their knowledge and experience from Ethereum and bring that into the layer 2 context.
Hello, I'm Marco, and I'm leading the growth for Linea. Linea is a layer 2 powered by zkDay. It's a technology built in-house from Consensus. I'm part of Consensus. And yeah, we are bootstrapping this layer 2 on top of Ethereum. And we just went live yesterday on mainnet. So yeah, to talk about Linea and layer 2 solution, guys.
Amazing. Big welcome to our 4 panelists. So I wanted to start off with a pretty broad question, and that's, in your guys' view, what are the biggest challenges in layer 2 scalability today?
I guess I'm holding the mic so I can start this off here. When I think about the challenges for L2 scalability, I think one of the big ones is obviously like the thing that we shouldn't under-realize in a place like this, that these are really big engineering tasks on really cutting-edge emerging research problems and engineering problems. And so I think on the engineering side, there's still a lot to be sorted out. There's still a lot of things to happen. I think we're all like either at mainnet or very close to mainnet. But these protocols are far from being finished, right? And getting through some of those problems for, say, decentralized improver networks and sequencer networks. There's just so many challenges still yet to be solved. And that's what I would probably say.
Yeah, from my point of view, basically decentralization is something that none of us has cracked yet. When it comes to decentralization, you also have to think about, okay, everyone needs to be able to run the nodes and sequencers and the provers. And in that front, we've done a big step forward this week. We launched a new prover, which brings the requirements to generate proof super low back to consumer level hardware. So yeah, we're making steps in that direction. But yeah, that's the main thing.
Yes, I think the challenge is, from our point of view, is user acquisition, because seeing that rollup will be the future of Ethereum. We have such a big ecosystem that we want to migrate to the rollup landscape, and we have to accommodate so different types of use cases, and also we want the TVL to be evenly distributed among all the application types, DeFi, GameFi, SocialFi. They all need a onboarding experience that's easier for them, because of course the Ethereum is getting more and more complicated. So as engineering team, we mostly are concerned with running the service, running sequencer pool, all those kind of challenges. But if you don't have users, or users don't have a nice experience, they'll get frustrated. And that's not good. So for that reason, we designed our app from this goal in mind. That's what we think for all the roll kinds, types service. We want a streamlined user experience. We call it hardware rollup, and we develop our in-house universal zk component to be part of the whole solution. So the user onboarding experience and all the data migration will be run smoothly, and hoping the whole ecosystem will grow to everyone's benefit.
Cool. Thanks. Yeah, let's pass it down to Marco.
Thank you very much. So there are many issues, multiple issues on layer 2's infrastructure. Many of them you already talked about. It's the decentralization. I'm not really worried about that, because we all recognize as an ecosystem that these are issues that we need to work on. So we are all working on the decentralization of the sequencer, of the prover, or whatever. to me, I would love to focus more on two other topics. The first one is the lack of client diversity. And when it comes to a optimistic rollup, it's just about client diversity at client level and sequence set level. When it comes to zkDay, it's much more difficult topic because you need client diversity also in the prover. And that's nobody's talking about. We started discussion with Scroll, we started discussion with Polygon zkVM as well, because if you look closely, all this rollup, if we don't have a real diversity, all this rollup will be like the first bug, we need to have the rollup, all of us. So it will be like Solana. So this is an issue that we should start figuring out on how to tackle it, about the diversity of the whole stack, not just about the client. And it's the power of Ethereum. At the end of the day, we have multiple clients. And the other issue that I see is the liquidity fragmentation, because we believe in a world where we are going to have a lot of layer twos, and if they are going to fragment the liquidity, it will be really a pain in the user experience. So the overall user experience will be much worse than the one that we have today. So in this case, I also see some tentative of addressing the issue. There are many cross-chain apps. There are many partners like, I don't know, I can mention Axelar, Zero. There are many of them, that zkLink. There are many of them that are working towards real cross-chain apps that actually avoid fragmentation of liquidity. And this will create the dApps that will really be useful in the layer 2 work.
Amazing. So some of you already touched on some of these aspects, right? Like decentralized sequencers, decentralized clients, user experience improvements. Are there any other infrastructure developments in like the medium term that you guys are really excited about? Yeah, go for it.
Yeah, to me, I will double down on this. This core level infrastructure about messaging protocol and cross-chain liquidity protocol, I'm really excited about. I'm really excited about this because actually it will let us to have the dApps that can really create value in a layer 2 world where we have multiple layer 2. So this is for sure one of the things that I'm most excited about, but it's also all development on the zk bridge side. It's also really, really interesting. And the last thing that is very phenomenal, in my opinion, is the type 1 zkVM that are coming to the market, probably very soon. And yeah, this is very, very amazing because you can envision a fast shift from a layer 1. You can in a very transparent way make it become a layer 2 on top of Ethereum. So we could, for example, we will not see any more layer 1, alternative layer 1 in the future because it makes sense for all of them to tap into a single security system like Ethereum mainnet. So it's very exciting.
Cool. Yeah, also very excited about all those and some of the movements that we've seen towards people voting on Ethereum that haven't in the past. I think my answer to this would probably be leaning in the direction of how we make these, people, all these apps across all these L2s, like how do we make these accessible and easy to navigate for users and developers? So obviously, I think the things that you mentioned are on the developer side, but also thinking about like, reading L1 state, for example, in these L2s is something that like I don't think anyone's really fully cracked yet, and it's something that I think got highlighted by Vitalik last month in a couple of articles thinking about, okay, how do we actually make sure that I don't have like really, I don't know, it's maybe not fragmentation of liquidity, but fragmentation of accounts, right? How do we make sure that account abstraction works across these layers, things like safes work across these layers, in a way that we don't back ourselves into a corner where it's even harder to solve the UX problems of blockchain that we've been accumulating as a technical debt for a long time.
Yeah, for us is touching a little bit on both things, both like the user experience and people building their own, facilitating people to build their own chains. For us, we just announced zkStack recently, and this is our vision for the future. We see that it's not that people just running and deploying applications on zkSync or on Scroll or any other layer 2. We see people moving to L2s because the space on L1 is limited and it's going to be more and more expensive over time. So the way we see it is that we're going to have no layer twos, so we need to facilitate people to build layer twos, and that's how we want to move forward in that direction. That's why zkStack was created, and we just hope that in a few months we have more people building zero knowledge rollups on top of it, which will also have like cell liquidity with thanks to the hyper bridges that we will have. It will be seamless to users to be on one hyperchain and then use applications from another hyperchain. So that's pretty exciting for us.
Yes, so I think a lot of developers are very excited about the future of rollup, and the most exciting thing is that we can have the kind of flexibility of decentralized rollup providers, that you can run a security pool that every app, every ecosystem you own, or some individual can run their own rollup chain, and the flexibility being that all versions, old and new, can just coexist, right? They can just run their own rollup. Everything is just settled on Ethereum. So this is the future we're very excited about. And we all know that the blockchain space used to be very bad for upgrades and compatibility, right? You used to have to do the hard fork, soft fork. It's really hard compared to a Web2 space, where upgrade of your app is just just silently just do some trick on your server and you're done. Very smooth security experience. And I think the rollup, decentralized rollup space, this is going to be the first time that blockchain, Ethereum, be the first to provide this kind of smooth migration capability to app developers. So this is a huge thing. And also, we're also going to be to welcome new kinds of applications onto our world, right? Not just DeFi, GameFi. The next boom, I think, will, as many cycles before, every time we'll introduce new class of users. And this will enable that, right? We won't have the old time that, there's this choke on the network as a harbinger of a new cycle, but then, everyone's getting disappointed and then they leave, right? This time, I truly believe it's going to be different. I'm very excited.
Amazing. So I think this is a really great segue, both Jules and Ming, what you're talking about. And that one of the really cool things about folks working on zk scalability is that things might look somewhat similar right now, but I think every team has at least a slightly different vision for what the end game is. So what's the ultimate vision for scalability, especially as you mentioned, as you onboard more real world users and real world applications?
Yeah, sure. So with this capability, we have, for the first time for Ethereum, that we have unlimited scalability. Because the future is that we also have this new exciting development of sharding, dank sharding, and then we, near future we have proto sharding, proto dank sharding, and also the, I know many new networks rollups are developing their own layer 3. So layer 3 is, it's just an extension of layer 2. I'm seeing you call layer 3, layer 4, or layer 100. Someone's joking with me that, but I would say unlimited, infinite scalability or extensibility that everyone would be able. It's like in the Web2 world, they can run their own server. In the Web3 world, you can run your own chain, right? You can have your own chain, and all the chains can be parallelized. And this is the first time we can have a reverse of the conflict of having decentralization and scalability. So it's kind of the reverse, right? You have more users, it will be helping decentralization instead being restrained by it, which is the kind of story that people complain about Web3 for about a decade. So this is all going to be changed, So that's all for us. So we want this to, that's why we develop what we call hybrid rollup, because hybrid rollup, you don't have to choose. It can naturally cover more use cases. Previously, like, the kind of users that want security, right? They, for example, kind of traditional institutions, for them to onboard, you might be surprised that they don't even trust like zk, right? Because they have mathematicians, they know it's sound, they know mathematically, but then to develop it into software, that's not the same thing, right? SSL is very mature, maybe the most deployed security app in the world, but I don't know, like 20 years into its deployment, they still have like heartbeat, this kind of serious problems. So yeah, naturally they don't trust, not the mathematicians, but software developers. So they want the old battle hardened method, which is to have a lot of checks, a long period. Like, for example, if you do interbanking settlement, it takes multiple days to go through all the settlement banks. So optimistic rollup actually is very fitting the role, but optimistic rollup cannot provide a 30-day challenge period because most users have $100 worth of wallet to pay to someone you want that money available to you immediately. So this is going to be a problem. zk can solve this with instant finality, but then users, who do they know? They didn't want to solve what zk is, what obfuscate, all that. So to provide them a universal kind of, they don't have to choose. That's why we developed a zk solution called zkM as a component, a camera inside a optimistic rollup. We call it hybrid rollup. So it can smoothly support all these new use cases and in a secure way, because if you just bundle different products together, you leave like space for attacks. So anyway, all different chains, rollup chains, Layer 2 chains, they can all coexist in a secure way and high performance and scalable. I'm gonna stop now to really share the excitement to my developers as well.
Yeah, I'll be quick because you touched in some of the things. I think technology should be transparent. That should be our end goal. When you're using Twitter or when you're buying stuff on Amazon or using your email, you don't know, or most of the users, they don't know the technology behind it. They don't know the programming language that people use. They don't know the databases that they use. So that should be our goal. People should be using blockchain without knowing that they're using blockchain. I think that having that should be the goal for everyone. And how we achieve that is just up to us. It can be like that when you have multiple chains, that was the future is going to be, but multi-chains that make that when you're utilizing one chain or another, that everything is seamless, that people don't have to go to a page, go to the level 1 and then reach back to the layer 2. So interoperability between protocols, I think, is a huge thing that we should work on.
I don't remember the initial question, so I'm just going to kind of respond to some things that have been said here. But I think the security question is kind of an interesting one, right? Because it's true, this is an emerging space. I think zk vulnerabilities for anyone is a liability for everyone. And I think a lot of the people on this stage and the folks in this room and sponsors in the other room have like a huge amount of responsibility to the space to take security super seriously. Because the reality is that users are never going to understand the mechanics mostly of these systems. And so what we have to do, aside from just education and try that route, is we have to just have really, really high standards and accountability to one another and make sure that we really take our time to battle harden our own systems. But also I think what users can trust is they can trust processes, right? They can trust people that they trust. But they can also look at the history of software development and look at things like open source development, community-driven initiatives. These are things and processes that get a lot more than just one team trying to ship quickly, to be engaging with code, looking at code, auditing that code. And so, yeah, the little scroll show here being that like we are take this process very seriously, and we, part of our kind of founding story here is that our zk EVM circuits are built in collaboration with people well outside of Scroll, folks from Ethereum Foundation's privacy and scaling explorations, and other teams are all using these kind of same toolkits and using the same circuitry to build their products on. And we think that that means a lot, and that can account for a lot, and that can hopefully really influence users to see, okay, this isn't just one team with one developer that maybe was tired that day writing this line of code, but a whole lot more folks involved.
Yeah, on this part I fully agree. I mean, we take the security as like the North Star. I think all of us do this. I mean, we went live yesterday with mainnet, the Linea mainnet, without a token bridge, a canonical token bridge, because we were told by our auditors that it was better to keep for a second and to continue some review. And so we decided to go live without it, because it's a mantra. We cannot definitely put at risk any user funds. So it's very difficult. When it comes to your question, I believe it's what's our vision for the end goal or the end game of the layer 2. Yeah, I believe that this is, it's too early to say. I mean, we still have a lot of block space among the different rollups that are out there. So we still should focus on trying to make our dApps, our developers successful so that they can onboard the next 100 million of users into the Web3. And then we can talk about if the future will be fractal scalability with layer 3 or multi-prover network with high capacity, so one will take it all, or it could be multiple layer 2 that will work with cross-chain apps. We don't know yet. We are not there yet. So we first need to support dApps to be successful enough so they can be able to onboard the next 100 million users into Web3. That's our primary target now.
Cool, makes a lot of sense. Thank you all for the insight. I wanted to ask a question, kind of going on the other side, maybe more from the perspective of like adoption or business development. I think one of the really cool things about the zk scaling space is just like the design space is so wide. Like it's clear, that's why there are so many different projects. Everyone is making different trade-offs as they design their systems. That being said, I think a lot of people view, what you're all building as, on some level part of like the same category. Do you guys see this space as like a winner-take-all space, or do you think there's room for all the projects that exist today plus more?
Yeah, this is a topic for a lot of discussion internally at Consensus. Personally, from my point of view, I really believe that the cross-chain apps will be the one that will lead this type of market. So we will see cross-chain swaps, liquidation between DEXs, new concept of DeFi project, but also of NFT. I mean, the concept of minting an NFT almost for free on a layer 2 and being able to bridge it on Ethereum mainnet, where we have bigger ecosystem, we have bigger floor prices. That's radically changing the approach. So why focus on a specific market when you can have dApps that can work cross-chain? And in this case, it would be just a generic type of rollup, general purpose where you can hold the dApps. So our approach was not trying to focus on a specific area, but try to be more generic because we believe in the cross-chain work. That's the point.
Yeah, I mean, I think at Scroll, we think that there's definitely room for the trade-offs, room for everyone to be cooperating in this space and learning from one another and be building out things. I think it's going to be better for developers in the end, which is my focus, and because different toolings have different appeals, and you get to learn about those trade-offs and make decisions based on those trade-offs. Yeah, so no, I don't think it's the winner take all, and hopefully there'll be even more innovations in the space that we can all keep learning from and keep building alongside.
Yeah, I also think it's going to be, there's not a single winner here. And yeah, as you said, we are all doing things slightly different. So you have better features on one side that might fit some projects better than others. So I think that's the way it will go. But also we are all working towards decentralization, and open source for us is super important. And for us, zkSync is not going to be run by Matter Labs. So the goal is open source, and everyone will be able to fork it and run it, create his own chain. So if it's not us, someone else will be able to create another layer 2 similar to zkSync with specific features, and it can be something built on zkStack, or it can be just a simple fork. So yeah, that's my answer.
Yeah, this is actually a very good question, because as I see it, winner takes all is the hallmark and of the Web2 era, right? And if that's the case for Web3, I would say Web3 has failed, right? So for it to not fail, we have to go beyond the kind of apps we have today. If we only have the kind of palm and down kind of, then yeah, we'll still, revert back to the Web 2 world, where a couple well-funded projects probably will be like winner take all again, which is that we don't want it to be, right? Decentralization is diversity, and we can't have diversity. We have a system that can support like a diverse range of apps. So for all those apps to be on to the Web3 world, we need to build a system that it can incorporate that, right? And for almost like 10 years, we have like the kind of limitation for that. So for the true like diversification to happen, I think roll-up technology evolution is the right way to go. But we're still being kind of painstakingly await all those like apps to be onboarded. So the tax is upon us. I think all developers we're on the same boat. We need to help them to get on board, not just for TVL sake, which also that's important. It's a measure of your success, but truly it's about user experience.
Amazing, cool. I think that's one of the really inspiring things about this space. Like, despite the fact a lot of people are like ostensibly, competitors working on, competing projects, like, we're able to get you all on stage at the same time, and hasn't broken out into a fight or anything. So, that's really inspiring to hear, and I totally agree. The world is going to be multipolar. That's just how Web3 is. So appreciate the insight there. I think one of the things that's been touched on by a few of you guys in what you've been talking about is like the types of apps that you're targeting. And of course, you all are on some level positioning yourselves as general purpose networks. That being said, I think when I talk to different teams, oftentimes they have different theories as to like what apps will actually drive demand for block space. I'm curious what apps you guys are all targeting in your developer relations, in your business development to onboard onto your platforms.
For us, I don't think we have like a specific vertical or something like that. It's obviously that DeFi is what brings TVL and push the numbers up, and those are the ones that have more visibility. But we just go after every single application that is solving a problem or that has a good use case. It can be DeFi, lending, it could be NFT marketplaces, it could be games. So public goods, there's nothing specific. It's truly general purpose.
Yeah, I think we all probably have the same basic answer at the beginning, and I think what we'll see when we hit mainnet later this year is that the first influx will be the DeFi, right? So much of the foundations and the building blocks are in trading, liquidity, borrowing, all that stuff, right? And the composability of those things are so exciting. So we have put a large amount of effort in trying to make the best developer experience on Scroll, and to making sure that we're like bringing on all the kind of infrastructure primitives that are going to be necessary to support DeFi, chain links, and working with Aave and Uniswap governance to make sure that those things are in place. But that doesn't mean that we're trying to only get the DeFi or the degens or anything else. And so yeah, and the developer relations side, it's been really exciting to then be able to provide these things for developers and provide a good developer experience to then say, okay, now what interesting things are you going to do and apply zk that build off this, or an identity space that build off of these things, with the benefits of the L2, which I don't think have even been explicitly said here, right? Like the faster block times and that responsiveness for user applications, and that finality on L1 and the speed of that. So yeah, general purpose, but if you're interested in building outside of the DeFi that you might see early on, of course, reach out.
Yeah, again, general purpose, as we say, I have to say that we don't see DeFi as a sort of market segment. We see more like as an infrastructure piece. Because even if you talk with games, for example, a gamer wants to pay with USDC, but maybe he needs a DEX to swap the Ether to a USDC and pay the games. So the DeFi is an enabler for many things, for other verticals like art, and it comes with NFTs or games. So we see it as very important pillar, and yeah, that's one of the reasons why we put a lot of focus on it. But we also have another very important relationship with MetaMask, of course. I mean, it's a consensus product. So we put some more attention on all the dApps, not really the market segments, but the real dApps that actually works already with MetaMask curated experience. And we are talking about aggregating indexes, aggregating bridges, on-ramp providers. So all of these things are natively integrated on MetaMask on Linea. It makes a lot of sense for us to put some more effort here. And it makes a lot of sense for us to put more effort on the things that will come for MetaMask, because there are new curated experience coming on the market and new features for MetaMask. And so it makes a lot of sense for us to focus on this to support MetaMask.
Cool. Nick, do you have anything to add?
Yeah, sure. I actually agree that DeFi is still going to be the first space to kind of take advantage of this new generation of technology rollouts. And also there are important reasons why DeFi should be the first. Because DeFi is the engine to power decentralized Web3. Not just for financial apps, but for all the kind of decentralized mechanisms to work for all kinds of like decentralized the apps is decentralized. You need some kind of financial incentive design, mechanism design, and I think the booming DeFi is going to be at the core of this new generation of new kinds of like onboarding new apps. So we used to run into a lot of these problems that they want to design the kind of DeFi app, like derivatives and all that. But just Ethereum like Solidity and all that is just not apt to the challenge. And I think this new generation of rollout technologies, zk especially, is going to be crucial to provide that capability. So yeah, so I think DeFi, yeah, I think we work with DeFi.
Cool, makes sense. So another question I wanted to ask, and I think this is where we might start to get some disagreement here, is how important is strict EVM equivalence for zk rollouts?
For us, it's 100%. I mean, it's the most important thing for us. There's a reason. When we started designing all the infrastructure piece that we wanted to wire from the very beginning on Linea, we had a very long discussion about account abstraction. We are fully supportive of account abstraction, but we started to talk with proposer of the 437 standard to understand which was the best approach. Should we do something at protocol level for the account abstraction, or should we just stick with traditional EVM? So the outcome was, let's not do anything for two reasons. The first reason is that the 437 standard is in a continuous evolution. So it would be a big overhead for our team to keep it up with the evolution of the standard if we embed it in the protocol. But the second reason was that we really want to stick with pure EVM. And if we add some features on top of the EVM, we may create some lock-ins. So if a DApp will deploy on Linea using these extra features, they probably will not be able to go back on Ethereum mainnet or another EVM anymore. So for us, the EVM compatibility is really, really important, and it's another North Star for the team.
Yeah, I think Scroll's view is quite similar in how we want to approach it. It's, again, all about the developer experience, and if you end up deviating from what mainnet's doing, that's not great, right? You're going to either have to break compatibility with your own chain to go back, or you're just going to be forking. And we're a long way from Ethereum mainnet ossification, and maybe once we get closer to that, we can start seeing what like finding specific niches looks like. I think our example of the story, in addition to account abstraction, is looking at precompiles. That's been something that I think all the people in the zk EVM space have considered, just because the ones on Ethereum are very hard in the zk context. It would be nice to have really accessible other ones for people doing applied zk and other applications. But in the end, yeah, we kind of just came back to this core idea that, no, it's important for us to be bytecode compatible. We don't want any surprises for Solidity devs. We want it to just work. And we want to just make sure that every gotcha, every additional piece of mental overhead for a developer is a potential for security issues, is a potential just for a bad developer experience, and we want to avoid that at all costs.
Yeah, I guess we are the only ones doing things slightly different. And yeah, it's not that we think that developer experience and user experience are obviously super important, and that's why we took maybe the middle route. We are not fully EVM equivalent, but we are not the opposite of doing our own thing. So that's why we choose to go with our own compiler. So on the developer side, developers can build on Solidity or Viper. If they are building things that rely on APIs from the node, the API is compatible. So from the developer point of view, we are mostly the same. It's 90%. And then the things that we changed are based on the user experience. That's why we have a native account abstraction. So we know that most of users use externally owned accounts. So if you have account abstraction on EIP437, none of those users can use paymasters, for example. So they cannot benefit from cashless transactions or paying fees with ERC20 tokens. So if you imagine you do a checkout or you just pay with USDC, and you have an externally owned account, you won't be able to allow that user to just pay something with USDC plus the fees with USDC or make it cashless. So that's not great user experience for 90% of the users that have externally owned accounts. So when you have native account abstraction, you can enable that for EOAs as well. So all the things that we've made different are the reason is user experience. So yeah, that's our take on that.
I would say where I can't is the zk Sync approach. We're a bit even more radical that we, of course, from our names, we're zkM, zkMIPS. So we do a more general purpose, like very stable, long-standing, computer instruction set. MIPS is very stable, and by doing this, we're looking at the long game, because the next boom, as I already said, we're onboarding many new apps, right? Those apps, Solidity, of course, but what if they're in C++? What about Rust? What about Move, right? We want them all to come to Ethereum. So I don't think this is a kind of problem that's not going to be a problem, I think. For the next boom. We're all waiting for the next boom. And each boom will be exponentially, having more apps if it's a real boom. So yeah, we take the stance that we want a world that's beyond Solidity, and we want a world with different programming development paradigms. For example, what about functional, right? a good smart contract, right, should not be using language of assembly code. But that being said, we should be supporting all kinds of computation.
Cool. I love that we have like, I mean, no comment on linear versus scroll. We've kind of gotten the spectrum from like EVM equivalence to like EVM compatibility to MIPS, which might be the EVM, but might be something else. So I think that's really cool. I wanted to end this by leaving like a very open-ended question. I think probably many of the people here in the audience are developers. They're thinking about building their applications. They're thinking about where to deploy their applications, how to just generally think about the space and parse, you know, the zk EVM or zk rollup space. What would you say to the developers in the audience to help them get started on the journey and, you know, look into EVMs and eventually deploy on a zk rollup?
I'll go first. So, well, first of all, I would say that they are in the right direction because I think that's the way to go. Yeah, to try to see zk sync a little bit, I would say that yeah, the developer experience on zk sync is mostly the same as what you would do on Ethereum or the layer one, and then you can benefit from these other things like native account abstraction. And we are constantly working on developer tooling. We have released a couple of new updates this week. And then with all the things that we are working on, we are trying to extend the EVM with our native account abstraction, with the ZK stack that we launched recently. So here we're just constantly trying to improve and build new things so to improve the developer experience. So yeah, the first step will be just go to our docs or on our website. We have a quick start tutorial. We have a lot of tutorials out there, and we'll be working on trying to improve our open source efforts to onboard a lot of users, so it will be easier for them to collaborate to all of our projects and all of our tutorials, or just to the code base of the protocol. So yeah.
Yeah, my tiny shovel for my real comment. Check out the scroll docs. Most of the ways to deploy is changing RPC line, right? So it's super easy, super compatible with your existing developer tooling, smart contracts, whatever. But I think one thing I would just say to developers, aside from come meet me, is don't undervalue the importance of the fact that we're not just here to be scaling Ethereum the technology, but scaling Ethereum the social processes, the ethos, the culture. All these things are very important, and I think if in the long term in the L2 space we're going to avoid things like that corporate capture mentioned by Ming, we're going to have to really make sure that as we're, you know, if we deviate from mainnet, like these are things that are community decisions and builder decisions and things that everyone's involved in. So if you're building and interested in the space, come learn about us, check out things like L2Beat to learn more, but then make sure you get your voice involved in the space and join these communities and let us know what you're building and how we can better support you.
Yeah, I would say if you are in this room today, you're already on a good track. So that's a good start. Yeah, the first thing to consider to me is really carefully evaluate the possibility to build cross-chain native dApps. Because yeah, you have many types of ways to scale your dApps or to select a network to build on top. But really the important thing will be to build with an infrastructure that is by default cross-chain, that is not just stuck on a single chain. And there are many ecosystems that let you do this, so check it out because it's really important. It's really important to scale your dApp. Then you have, of course, the power of the default. So you need to select a known network, and then, I mean, it will be matter about your specific approach, your needs, what you want from a network in terms of support. So it's really dependent from your specific case. But please consider to go in a cross-chain direction because it's definitely the most important thing to consider right now. Even most important than to consider to which layer to deploy.
Yes, so for us, it's really simple because the purpose of zk is to help the little guys because all the devices that's computational less capable can now also enjoy the benefits, the fruits of security apps, right? It used to be like very few applications is developed with security in mind. That's really hard, and it's in a Web 2 or traditional world, that's not something people really consider. But for Web 3, security is a foundational aspect of your DApps. So with zkDay technology, you can sort of delegate that task to the we call them roll-up miners, the people who running sequencer tools. They also can run your proof generation and your low-powered devices if you want to do DeFi or a new kind of smart contract enabled DeFi app on your very low-powered maybe IoT device. You can do that because zk is the paradigm to enable you to do that. So I would kind of advise the Web3 DApp developers to think hard about the paradigm that QD apps is going to adopt, which is to have a security first approach. That's really different from the Web 2 kind of world that you're coming from. Even in GameFi, SocialFi, security is first. And with that, yeah, now we have zk. So follow us up on zkm.io. Yeah, that's us.
Amazing. I think we're at time. Time for questions? 2 minutes. Okay, does anyone have a question?
Thank you. Great points overall. I wonder after around 7 years of Alter ones trying out and bootstrapping ecosystems, it seems that that's one of the main thing that is going to happen also with other tools. So even if some project would crack the very hard engineering problems that you guys talked about, how it's going to work out on the ecosystem side. We're seeing some of the biggest L2 ecosystems being developed, but actually the technology behind them is not that sound. So what do you guys think about this, and what's it's a big struggle because we don't have much more time to bring crypto to the masses. So that's a big problem overall. So what are you guys thinking about this? Thanks.
Yeah, I'll be super fast. I think user experience is the first thing that we have to crack. Account abstraction is a good step in that direction. So yeah, I think that's the first thing that we need to fix. If my mom or your parents, they want to use crypto right now, they have to onboard, they have to sign transactions, all that stuff. It's been talked all over the place. So that's the thing that we need to focus on. So, yeah.
No, yeah, I mean, first thing is that when it comes to bootstrap the ecosystem, this is something that I don't see that it will happen a lot in the future. Because with the type 1 that will come out, you will see already bootstrapped ecosystem becoming a layer 2. They are alternative layer 1 today. With the type 1, they can just plug the prover and connect to it in a mainnet. And they will automatically layer 2 with a bootstrapped ecosystem because they are live today. So this bootstrapping of the ecosystem that we see now, that we are going under as Linea and all the other colleagues that are here, it's something that we are just doing now because we are in an intermediate phase. We still don't have a type 1, we are still toward type 2. And so we need to bootstrap an ecosystem, we need to bootstrap a new network. But the next wave will be just about moving the existing ecosystem to a layer 2 to increase their security. So that's the first thing. Now, when it comes to how do we crack and how do we actually attract the next users, to me, this should be more coming from developers. It should be the people in this room to focus on things that will support the next 100 million of users. So we should just be able to support them, their scaling needs, their requirements in terms of throughput and block space. But that's not scare me a lot, because we do have a lot of block space available, and we will have a lot more very soon.
Cool, amazing. I think we're at time. So can everyone please put a big round of applause for our panelists? And a big thank you to Manta for putting this together. Thanks, guys.
All right. Right now, we're gonna have our keynote number 2. It's gonna be foresight.
Hello everyone, very glad to be here to have this presentation. I'm Kitty, I'm partner of Foresight Ventures. Today I'm going to tell you about Foresight Ventures and also like our thoughts in zk and zk application. First is about Foresight Ventures. We have 4 brands right now. The first one is our venture capital, Foresight Venture. The second one is our crypto media, called Foresight News. And third one is called Foresight X. It's an accelerator and an incubation plan. And last one is called Open Build. It's developer community we build. Yeah, so the first is about Foresight Ventures. So we define ourselves as a research-driven and crypto investment and incubation powerhouse. We have 4 funds right now. The VC fund, we invest in private market. The second one is long-short sector fund. And also we have multi-strategy fund. We invest like fund trading, market making strategy, HFD stuff. And the last one is we have a private market sector fund. And this one is most about like OTC stuff. And now we have our AUM exceeding 400 million right now. And during the last 3 years, we have supported 80 projects and 10 funds into like primary fund and secondary fund. And what we believe is we want to have an investment strategy to be unique, independent, aggressive, and keep a long-term mindset. So during the last 3 years, we have building a growing ecosystem and to help and provide comprehensive support for our portfolio. And this is our ecosystem. The first one is Foresight X. It's a Web3 accelerator focusing on 3 core segments. First one is incubation in a very early stage projects. And we also provide like ecosystem support for the layer 1 and layer 2 ecosystem. We provide grants and collaboration with them. The third one is we provide a research grant. This grant is mostly for the students, academic researchers in the university, in the college, and we want them to make the blockchain, to develop the blockchain and improve the blockchain. Foresight X is very new, and we start Foresight X like at the end of last year. Now we have like 2 accelerator camps, and each camp have like more than 1,000 applicants right now. And we select from the camps for 6 projects in the process of incubation. And we also hold like event of hackathon, hack house through US, Europe, and Asia. And now we also have like hold a hack house in Paris. So if you're interested, you can go and see them. Okay, the next one is the crypto media aliens. So we start Foresight News about 1.5 years ago. And in the first 1 year, we have become the largest Chinese-speaking crypto medium in Asia area. And they now have functions like Project Wiki, event calendar, job hiring, and a developer community called OpenView. And now the monthly page view of Foresight News has 2 million right now. And also we invest in Coinbase in Korea market and Block Temple in Taiwan market. So we form these crypto media aliens to provide like market promotion and advertise for our project. It doesn't move. There's a two platform we working close with. The first one is BigGet. Now is their top 4 crypto derivative exchange and top 10 spot trading exchange. They have like 8 million users right now. And BigKeep is, I think it's the largest distributed wallet in Asia right now. And they have like 10 million users. And it's support for 90 blockchain for 90 blockchain networks and 20,000 DFs right now. So so we have like a very large user base in the Asian market. This is our edge. First is because we run a multiple funds, so we can have like primary and secondary market investment successes through the whole cycle, and we provide support like to our portfolio, our project for like the asset management and the risk management services, so we can survive in the bear market and go through the cycle. And second part is because we build this ecosystem, so we can provide a comprehensive support for them through their life cycle, because we have like the Asia largest user base, and we also have medium and developed community, so it can help us to bridging Web 2 and Web 3 developers together. So we can provide support from very beginning of our portfolio, like project design, team hiring, and financial advisory at first place, and then to like operation, like market promotion, media advertise, and then to the listing in centralized exchange and decentralized exchange, and also like market making service for them. Well, this is our portfolio. We cover like infrastructure, DeFi, CeFi, social, NFT, data, and gaming. You can have a look. But most importantly, we invest in zk. Yeah. Now we invest like we have 5 portfolio related to zk stuff, and there is one layer 2 zk rollup, but it hasn't been announced. The first one is HyperOracle. It's a programmable zk Oracle network, and the second one is Polyhedra. Now they're building the zk bridge and zkDay stuff. The third one is OLAVM. It's a privacy preserving and programmable zk rollup. Well, the fourth one is zk hardware acceleration, and now they're using the ASIC chips to accelerate the zk proof. Well, last one, they're not using the zk technology, but they can do the smart contract audit for many zk projects right now. And here is what we see in zk. So we all know zk have 2 features: is a trustless, it is a trustless off-chain computation, and it can have a privacy protection. So everyone here, we know we must invest in zk, and invest in zk is a common theme, but invest in like in the roll-up bridge, like just so what we want to see is like some application beyond roll-up and bridge. So we come up with like 3 direction. The first one is zk machine learning. The zk machine learning can protect data privacy and the model architecture when they do the machine learning in the AI model. So zk machine learning can like it connect AI and Web3 together, and maybe it can operate smart contract and connect smart contract with the real world. And also it can make AI run trustless, transparent, and decentralized. So although there is a main difficulty in zk machine learning, so because it's very hard to turn neural network into zk circuits, and also now they only support like small and simple model. But we believe in the future, zk machine learning will be a great way to connect AI and Web3 and crypto. Second one is zkDay. Well, this is very simple because it can protect personal data, and it provides proof access and to take part in governance of DAO privately. Well, the third one, this is quite, I think it's a very large direction. It's called zk game and zkDeFi, because we can build like fully on-chain game to do the anti-cheating stuff and protect the game users' data. And also they can use zk in DeFi areas. So the trading data can be protected, and the trading strategy of the of trader can be protected. So it may be an easy way for the student trader to launch their trading strategy into the on-chain stuff. So and maybe some in the future it can be MEV free by using the technology. So what I want to say is, so zk rollup and zk bridge is like building a highway, a bridge, but you must need like some vehicle and trains to run on it. So what we are looking for is a zk application that are able to support massive liquidity. It can track a lot of money, and also it can track a lot of people to enable mass adoption. So that's what we see in the zk in the future. So this is my today's presentation. Thank you very much.
All right, great presentation from Foresight Ventures. Round of applause again, please. And then we're going to have our panel number 2, and then that's going to be focusing on the VCs. Can we have Figment Capital, Foresight Ventures, Galaxy Digital, 7X Ventures, and Malwin 11 come up to the stage? Round of applause for that.
Hey everyone, you hear me okay? Yeah. Yeah, so this is the GC panel on their outlook for zk. Yeah, I thought just a good quick place to start would be if we could just like go down the line and have everybody just introduce themselves and their fund, and then we can just get into it.
Sure. Hey there. I'm Will. I lead investments for Galaxy Digital. We're a kind of broader financial firm in the crypto space with a trading arm. We've been investing since 2017 and very involved in the deeper infrastructure as well as things at the financial and application layers.
I'm Tony, a general partner here at Foresight Ventures. I don't think I need to give too much of an intro because Hippie just helped me with that. But yeah, so we look at everything in the crypto space, ZKs, applications, DeFi, infrastructure. We've been investing for about 2 years now, manage about 400 million, and yeah, happy to speak with all of the builders over here.
Okay, I'm Luis. I'm the partner of the 7X Ventures. We started in 2020, currently 3 years, managing 250 million. So we are more like a research-driven VC. We are publishing a lot of the articles and threads about the game modularity, GameFi, and gaming engine part. So we do broad like every sector. So if you are interested to talk to us, feel free to reach out.
Hi everybody, I'm Bim with Maven 11. We're a crypto-only venture fund that's been around since 2015. I think particularly deep in the DeFi domain originally, and then built a bit of a brand, I guess, in the modular domain. So yeah, that's us. You want the mic back? This works.
Awesome. So I thought a good place to start would be to just have some context setting of like why we're talking about zk at all. There's a lot of different problems in Web3 that need to get solved, and so just wondering to hear from each of you guys what some of the current problems in Web3 are that zk can potentially solve, and why it's an interesting solution for each of those problems.
Yeah, to set the stage, I think, and most in the room are going to be aware of these things. There's two that stick out to me, and kind of the two chief problems that zero knowledge proofs kind of at large are solving. The first is scalability, and the second is privacy. I think the application of zero knowledge or starts, whatever, without, whether it's with or without zero knowledge, to these problems have, mostly focused on scalability so far. The reason for that is blockchains are ultimately a extremely resource-constrained computer functionally, but blockchains are a really amazing form of computer that can deal with really interesting forms of information that other computers can't. And zero-knowledge proofs, snarks, give them basic asymmetric ability to have computation and to expand the availability of their compute resources, right? So that's why they, snarks and other forms of zkPs fit so well into our ecosystem, and I think that's what they're mostly used for today and what they're valuable for. But I think that over time may shift into privacy and have greater applications of privacy. Obviously, Tornado Cash and others have been around for a bit, but those are how I see it. I don't know if other folks feel differently.
Yeah, I think I very much agree. I think until now, a lot of the applications have been in scalability. So I'd say most of the chatter and sort of activity has been around rollups and these sorts of applications. I do believe that sort of the off-chain compute and bringing that sort of verified on-chain, I think there's a lot of interesting stuff happening there. Then on the privacy, it is a good point. I hope we see more movement into that domain. I think for now we're sort of stuck with a lot of these, I guess, older, we've got the Zcashes and the Moneros that have sort of product market fit, but I think in general, maybe also from a regulatory perspective, this has been a bit difficult. But certainly hope that there's going to be more movement there. So I think indeed privacy and scalability are, I guess, the obvious two answers of problems that zk is addressing.
Yeah, I think trustlessness is also another kind of core assumption it helps build upon, right? So right now, blockchain obviously is a way for like trustless compute, but I think zk kind of adds another layer to that. And that's where like we've been looking at social applications, DIDs, a lot of that revolving around trustlessness and how that integrates with zk.
Yeah, I think for us, we are more looking at how we can improve the efficiency and reduce the cost to generate zk proof and verify on-chain. So a lot of research on folding scheme, like custom gate, hardware accelerations, and also proof aggregation part, like the recursive proof. So that's a part that's extremely interesting to work with a lot of different data researchers to realize like the checks a new proofing scheme and new technology to save like the proof cost and also to be like to generate proof more efficient.
Cool. So I draw a distinction between infrastructure layer applications of zk and then sort of app level applications of zk. So like the zk bridge might be sort of on the infrastructure layer, zk rollup would also be infrastructure, but there's also potential use cases for zk in DeFi or NFTs for gaming or other things on the app level that we haven't quite seen yet, at least not sort of at scale. And so we'd be curious from each of you guys, like maybe more specifically, what sort of applications are exciting to you guys for zk at the app level, in addition to sort of zk bridges and zk rollups on the info layer?
Yeah, it's a good point. I think in general, we've seen indeed a lot of these infrastructure investments, and I think that's a general trend in the crypto industry. Everybody likes the picks and shovels, but building actually like useful user applications is has proven to be difficult or unpopular in some way. I think in general, a lot of the like boring use cases can definitely be interesting targets, I guess, for zk. So anything that has to do with compliance, for instance. I mean, it's a disgusting topic that probably not everybody wants to chat about, but very obvious sort of surface for zk to be implemented. And in general, any application that can sort of leverage zk as just another technology, I think any user application can benefit from like the privacy benefits that zk can leverage basically. So I think in general, a lot of applications could use these sort of technologies. I don't know if I have a particular application in mind. I guess indeed in sort of gaming and DeFi, all these the foundational elements I guess that zk provides, i.e. privacy, could be very much justified.
I'm thinking of two applications that I think are exciting for us right now. One is actually going to follow up on that topic of compliance. It's unpopular, but it's worth stating, which is we are excited, generally speaking, about the use case of blockchains in financial services more broadly. And what that ultimately means is bringing other financial assets aside from the ones we have, today on blockchains, to these environments. And there's going to be certain types of assets that, various people can't touch, right? And using zero knowledge identity as a certificate or a form of compliance to essentially determine who can touch a specific type of asset and who can't touch a specific type of asset, I think is a powerful use case for zero knowledge. There's been folks who've tried to do this at the protocol or application layer. So people who want to build in a certificate into a DEX or a lending protocol or something else. I think it's actually a more natural use case to build that into the asset. So define what asset certain people or certain users can touch before you define what application they can use, because then you don't break composability. So that's one we're excited about as we sort of onboard, assets that we don't have currently on chain today, whether it's equities in the future or bonds or stable coins or yielding stable coins, whatever. The second that comes to mind that I think we're really excited about and adds to the functionality at the base layer on in DeFi or in Ethereum is an idea that Axiom is, and I don't know what folks would call this, but I guess people call it co-processors or whatever, but the ability to prove historical state, right? That's something that we've used oracles for in the past, whether it's price data from external sources. I think that's an area that's going to just completely unlock new use cases and new types of workflows on chain, taking historical data, proving the validity of that historical state as part of a smart contract. I think Axiom and others are doing really, really interesting work there. And so that's another application that I'm excited about that I think is going to open up the design space for programmers on blockchain.
Yeah, just to kind of add on the compliance point, because like in our ecosystem, we have an exchange, we have a wallet, we have a lot of users. I think like a very interesting application would be zk KYC, right? This is something that everybody has been trying to solve. There hasn't been really one great way to build like an on-chain zk approved identity. If we had that, right, a lot of these CeFi exchanges could have a much better way to conduct KYC or understand their users much better. So yeah, I think there's still a lot of things that we could possibly do, but on the top of my mind, and something that we're kind of searching the most for here at Foresight, it's more related to identity KYC and try to kind of just better understand this on-chain user data.
Besides all the use cases like the you mentioned, and we are also especially excited about Fluent game, and also like how the zk we are using Fluent game because the area gameplay in launch is on-chain. That is why we really need like zk to hide like their information to like increase the different gameplay. So that's kind of like the one area we're specifically very interested in. And also for other area we are interested in the zk machine learning. And even though we all say like the AI and machine learning is like the, even though now zkML is very early stage, like with the proof generation part, the cost is very high, and also the proof size is also very big, and also we verify on-chain very, very difficult right now. But we can see like huge potential like in the trusted like machine learning, especially in the intent-based like the transactions when the solvers are trying to put in the execution layer off chain, and how we can trust our transaction to the solvers, let them to simulate and also run our transaction. And then we really need like the trusted like the computation and machine learning there. So that's the area where we're interested in the machine learning on intent like the transactions.
Cool. So just on the topic of zkML, I think it's a new thing that's popped into the crypto zeitgeist in the past few months, especially after GPT-4. Curious whether you guys think that this new interest that a lot of investors have had or a lot of builders have had in zkML is going to unlock some like really exciting new use cases, like some of the ones that that was hinted at, or whether it's maybe like a overcorrection after people see how amazing GPT-4 is, everyone wants to get into the machine learning space. So is zkML going to be a super new, exciting tool for a lot of applications within Web3, or is it just more of a quick narrative?
Yeah, I'm happy to be the first, I guess, to shit on everybody's parade, maybe. So, it's obviously a lot of hype, right? I think that's apparent from, the hype around ChatGPT and sort of venture capital activity in like Web2 AI. I think in crypto, we've maybe taken it an additional step further. Obviously, there's an interesting like cross section between AI and machine learning, but yeah, we have like way overcorrected already. I do think, particularly maybe also a point that you made, very much there's sort of a restriction in terms of the computational burden that adding zk to these models adds. So you do have to like figure out what sort of applications of this technology do we have where it's like significantly value added, that it's like warranting the additional overhead basically. You're not gonna pay sort of the additional cost of a machine learning model to prove, I don't know, some random thing like a random game. Like it's completely infeasible from an economical perspective. So it's very much about pinpointing, I guess, applications where the additional costs that zkML brings actually warrants the sort of verifiability, etc., that you gain with it.
We have actually recently published an article about like the data machine learning. You can check like in the SemX website in our Medium or Miro. So in article, like we basically mentioned that what we need to trust as the computation, and what areas in DeFi, ID, NFT, and also intent, what we think like we need and trust us like the computation and the trust us AI in the Web3 space. So that article gives a very comprehensive understanding about zkML. And definitely for the fundraising and also the investment perspective, there are a lot of like the investment hypes on zkML, and also the technology is still very early in terms of proof generation and the proof verification, in terms of like the cost of the proof and also the efficiency of the proof. So there are definitely a lot of like the thing we need to focusing on to optimize for the zk machine learning path. We can see the great work from like Daniel from Model Staff, Daniel Kang, Jason Morton, and other data researchers on that. So I think it's like the 5 years like this section. Now it is still like in the very, very early stage. But we really want to see like the researchers and also the project founders trying to build in this space to push the zk machine learning into real like adoption rather than currently in the theoretical stage.
Yeah, I echo most of these points. It's still a very early stage for a lot of zk machine learning application, right? The cost of these proofs and whether they're real like applications for this. There's not that many great open source models anyways. So obviously like once more kind of machine learning models kind of come into commercialization, having zk proofs on top of that will make like monetization much more clearer. But like I think just AI in general at the current stage, monetization of models itself is still quite early, and monetization of this space.
Yeah, I don't have a super strong perspective on zkML in particular. I think the intersection of AI and crypto is interesting. I think the place that most clearly resonates with me is the usage of token incentives to solve a bootstrapping problem. I like in general as a thesis. Some people call it tip-in, token incentivized physical infrastructure networks. I think of it as hardware hive mind is kind of how I think about it in my head, which is an incentive to bring on compute onto a network. I think can be powerful when that incentive functions essentially like a call option, and when those who are early to bring their infrastructure onto the network get a sort of outsized reward in the case of success. I think that has powerful incentives, and I think that creates natural feedback loops that can work in the case of machine learning, with GPUs being, I think, the most crucial piece, and then just the sheer size of compute you have for the large language models. I think that can be a powerful, it's a potentially powerful idea. The hard part is verification, right? So you have to verify that the outputs of the computation are good. I think that's where zero knowledge, at least in the context of training, comes in. So I think we'll see. I don't know if it's a solved problem or not. Our portfolio company, Jensen, is very active in this area, and probably, from my perspective, has the most viable solution to it. I think hardware networks that are incentivized by tokens are a powerful idea and very much can work. I think Bitcoin was the first one, but there will be others, many others that work in the future.
Cool. So most of the applications of zk we've been talking about so far have been solving some problem within Web3. They're solving the scaling problem. They're solving interoperability. They're providing privacy to on-chain applications. When you guys are thinking about investing in zk, or why you might want to invest in zk, are you only thinking about it for its ability to solve problems within Web3, or do you think there are interesting, potentially promising applications of zk outside of Web3, where either trustless computation or the zero knowledge property of the cryptography can solve other problems in the real world?
This is, so it was publicly announced that we made an investment in Risk Zero in the first half of 2023. And this was one of actually the chief things I wanted to diligence as part of our an investment in Risk Zero. Was it applicable just to the Web3 or crypto ecosystem and blockchains? Or could Risk Zero's virtual machine potentially be applicable to other applications outside? And it led me kind of down a rabbit hole, ultimately finding a research paper written by the National Renewable Energy Laboratory in the US, where they're exploring writing some energy grid computations in CIRCOM, introduce them to Risk Zero, and ultimately, I think there could in the future be some uptake, and it's definitely way earlier in spaces outside of this industry, those applications. But I do actually, that work and that conversation, the fact that there's research papers out there in other industries on the use of zero knowledge proofs indicated to us that this is probably not the last application we'll see outside of the blockchain ecosystem. I think blockchains, for the reasons I mentioned when we started the conversation, are uniquely good venues for zero knowledge proofs because of the limited resource, compute resources available with blockchains. I'm excited about things like energy grids, where you have highly distributed computers across across those networks and stuff like that. So I expect to see many more. Blockchains are just a particularly good testing ground and an incentive to do further research and scholarship.
Yeah, I'll keep my answer somewhat short and mostly echo Will's points, I guess. I think blockchains indeed are a very strong sort of coordination tool or mechanism. So adding zk to that has obvious benefits. I think for us, in terms of like investing in like only zk, where there's like no blockchain involved, I think that's particularly difficult just because it's not really our fund's mandate. And I think a lot of crypto funds will probably feel the same way. But yeah, I'm not excluding that this would be something we do, but in general, I think of zk more as just another like technology, and like investment opportunities. I think it's way more important that sort of the value proposition of the investment makes sense. And then if zk is like one of the key factors that enables that value proposition, then that's sensible. But it's not like we're going out there looking for just zk opportunities because it provides one or two properties.
Yeah, I think zk applications will probably first find product market fit in Web3, right? If you think about the entire token incentive mechanism, this only works on crypto, on blockchain networks. I think Web2, definitely we will see zk applications, but at least in my mind right now, I haven't really found a really compelling kind of use case that is kind of like very independent from like blockchain incentive networks.
I think in the Web2, no matter in Web2 or Web3, is a commercial decision. and you need to balance about efficiency and the cost. So there are many like the privacy technology, PE, MPC, zk, FHE. So each like technology have their pros and cons from technology point of view and also from cost point of view. So that reason why no matter in Web2, a lot of people are actually using PE rather than zk, trying to solve their problem because like PE is so much cheaper and but the thing with PE is that you need to trust Intel, you need to trust the hardware like the producer. So I think it's just a different use case, like when you use different technology, it's more like commercial decision. So I will say with the cost of the efficiency of the zk proof generation and verification, it's like the going down. There will be more and more like use case in Web2 about the zk. But at this stage, it's still very early, I can say.
Yeah, I just add that in Web3, I think zk solves like pretty serious fundamental problems. And so even though it's still fairly inefficient, people are willing to use it because the problems that it's solving are just so fundamental. Whereas in Web2, or just sort of like outside of the blockchain, there are some alternatives. It's not clear how much people need trustless computation. But I think as sort of the academic literature improves and sort of the computational overhead that zk introduces comes down, people will be willing to use it more and more. And so exactly how useful it is outside of Web3 is still TBD because it probably depends on just how efficient we can actually make the computation.
I think maybe one point I would like to add there actually. So I think I saw a tweet from the room coming by, and I'm just gonna verbatim quote him. Like technologies like zk and like fully homomorphic encryption and these sorts of things, they are quite difficult to explain to like a layman. So I think that also hinders maybe applications from like enabling this or like utilizing these technologies, just because it's difficult to get like a Web2 developer to like A, understand what this is solving, and then B, maybe also how to like implement these things. So I think the uptake in Web3 will maybe be a lot bigger initially, just because like Web3 or like crypto people in general are a little bit more prone to like dive into these technologies, and there are, I guess, more fundamental problems for us that these technologies solve. But I think inherently it'll be quite difficult to get like people on board with these technologies, just because they are like their value proposition is quite difficult to explain. Like if you have to go through the Where's Waldo example to go through like this is what zk can do, there's like a whole educational burden that you have to deal with before you can get people to actually understand and then build applications leveraging these technologies.
Yeah, for sure. So this whole event is about zk. We've been talking about zk pretty much the entire time, but Louis just quickly brought up FHE and MPC and some of these other cryptographic primitives. Do you think that some of these other cryptographic primitives like FHE and MPC are sort of underrated within the crypto community, where everyone's focusing on zk? zk's the buzzword, it's what everybody's talking about. Is that warranted? Is there some unique value proposition that it has that these other cryptographic primitives don't? Or do you think people are focusing on zk when potentially these other primitives would solve the same problems just as well?
I think a lot of people sort of shovel these into the same bucket anyway, even though they're not the same. I think where zk maybe has a little bit of an edge over something like fully homomorphic encryption is just feasibility, I think. Whether it's fully homomorphic encryption or MPC, I think a lot of academic research has shown that these sort of technologies are difficult to apply at a lot of problems at scale, whereas that's been more feasible for zk. So I think that's sort of where zk sort of started taking a bit of, or had a bit of the edge basically compared to these other technologies that are clearly way farther out from a feasibility perspective.
Yeah, and if MPC is underrated in our industry, then it shouldn't be, because it's securing a huge percentage of the assets that are on chain, right? And so like these technologies all are going to apply, to different things. As Pim said, it's FHE is further away. Zero knowledge is viable but slow. MPC has been in existence and used by non-custodial technology providers for several years now, and is really in production and and active. So it's different levels of maturity, and as I said, if zk is held out above the others as the as the most exciting solution, maybe there's good reasons for that. I think some will say it's the the biggest breakthrough in cryptography since since something like RSA or Diffie-Hellman, or maybe I'm not I'm not in a position to evaluate that, but all of these technologies are going to have their their advantages, disadvantages, and hopefully we'll see breakthroughs as we go forward from each.
Yeah, I totally agree from Will. Like, I think it's basically different use case in different areas. I think the first day, probably I believe the why the zk is so popular is because the zk roll up. Now I think for a lot of people, their impression for zk is still like the zk-L2, and then there are more and more like zk oracles, zk coprocessors, zk mail, and zk bridge, and zk everything right now. So I still think we need to still look at different other use cases. For example, like the MPC, we use in wallet, we use the e-wallet SDK, the TEE, we're also using the cross-chain bridge and Zama and Sunscreen doing research on the phobic encryption. So I think it's just like in this cycle because of zk-L2, and we are putting more attention on zk. But doesn't mean that zk is better than other centralized technology.
Yeah, I don't have too much to add. All three had really great points already.
Yeah, one last thing I'd add is I think one reason zk has so much hype is just because it's had, as of the past few years, a rate of innovation that the other areas haven't, where zk is currently undergoing this flywheel where some new academic paper comes out, which improves the efficiency of all the zkP generation, that unlocks new applications, new startups launch, those startups get funded, it hires more researchers, they come up with even better zk proving, which unlocks even more applications. So you have this flywheel effect where it's just getting better and better and better. And NPC and FHE are also getting better, but they're largely still academic, and so they're a bit slower by contrast. Cool. So just one last question I wanted to ask is more on the investing side. When you guys are going out and talking to zk projects every day, who are looking to raise money like investors from yourselves, what are some of the things you guys are looking at when deciding whether or not to back a new zk project?
I'm sort of struggling to answer this because I don't think we look at anything in particular in like a completely different way when it relates to zk as compared to anything else. Like, if you're building an NFT something project, like I'm going to evaluate that sort of based on the same criteria, I guess, as a zk thing. I think sort of referring back to the previous point, I think if you have a clear application for zk that unlocks some new potential for whatever you're building, whether it's infrastructure or like an application level thing, if you have a sort of value additive use for zk, then that's very beneficial, of course. But I don't think it has like a standalone position from like a due diligence perspective. So I would actually say to a lot of like founders, try to maybe steer away from like buzzwording your way into a pitch with more zk, even though it's not like the fundamental value proposition of an investment or of a project, rather than making that making clear what sort of unique value or like application you're unlocking with the use of this technology. I think that's way more important.
I think for us, it's not about investing zk. zk is just technology to improve the efficiency and also of the product. So that reason why our investment thesis top down is for example, we are thinking about, okay, in this cycle, how the oracle will improve, become more accuracy and also the trustless. And then we think, okay, they probably will be the technology to improve that oracle into the Oracle 2.0 or Oracle 3.0 compared with the previous oracles. Then we have started looking at the zk oracles, how zk, this technology will help the oracle product to be more efficient and more the trustless. So that's kind of our thesis. So we won't invest any kind of zk project rather than thinking about in what areas in Web3 we need to improve and how zk can improve in these areas.
Yeah, so I kind of have a bit of a stronger view on how to look at these founders, right? Obviously, like we look at zk projects just like any other projects. We take quite a bit of time doing due diligence on the founder, understanding their motives, right? Understanding his understanding of the market, his team. But I think something that is very important, right, is the commercial viability, how much thought this founder has given to potential use cases of this zk project that they're fundraising for. I used to do Web2 investing, so I've looked at a lot of fintech, consumer internet, SaaS related companies. And in Web2, right, when we look at any type of company, any type of founder, some of the first questions that the IC asks is, yeah, how much has this founder thought about the commercialization of his product? Yeah, so I was at Sequoia China. We did a lot of deals at all stages of companies. I did early stage up to like later stage growth in public. So, and this is like pretty much the first question that the IC always asks, like how much time have you given this founder and how much has he thought about this entire go-to-market and commercial viability of his idea? So I think like for now, from my perspective now, like even investing in Web3, even though like when we look at all of these projects, we often tell ourselves like, well, it's still very early. There might be a lot of changes on the roadmap, a lot of changes in how this market moves. But still, like as a founder, I think one of the most important things that you could do is to think more about the potential application, the potential monetization down the line, and how how your product really fits in this market.
Yeah, really, I think some good points here. Maybe to put a quick like summary on it. Like I think one of the things that gets lost is technologists, builders, founders of companies. They're in the business of figuring out how to apply new technology to problems. And I think jointly founders and investors in technology, I think uniquely technology investors, VCs or growth stage or whatever, are in the business of figuring out the applications of new technologies to business models, right? And that's our goal. And I don't think zero knowledge changes any of that, right? We're looking for a business model, and I think new technologies will likely, zero knowledge will likely create new business models. And the places that the companies or protocols that will be really successful in the future are the ones that find new business models with the unique technology that they're applying. So I think to sum up a little bit about what these three said, the other thing I'll say with respect to this particular technology that we're looking for is applications that unlock latent demand. I think is something that can be really powerful for zero knowledge in particular. I spend a lot of time talking to some of the hardware accelerator folks, and I'm hearing, there's a belief that we're on a Moore's law for zero knowledge acceleration, basically bringing proof times down, bringing costs down associated with that. And that's kind of borne out. For example, when we looked at RISC-0 VM a couple months ago, like 5 months ago, their virtual machine was doing a 60 kilohertz clock speed. I think just a couple days ago, they were doing 2.4 megahertz clock speed. So that's like not all the way to 2 orders of magnitude, but not that far off either. And so as we bring those costs down, there's going to be new latent demand that's unlocked, new applications that can serve new users uniquely because the costs are lower, the time to compute is lower. So we're looking for founders and applications, or founders and companies and protocols that recognize that those sort of scaling laws unlock new types of use cases and can see ahead a couple of years. So that's something we're really paying attention to, because where we are today is very different from where we're going to be in 3 years with respect to the costs and the proof time of this technology. And there's going to be some really interesting new things that get unlocked by that. And so that's some of the things we're thinking about as well.
Nice. I think we have a few extra minutes. We can do Q&A if anyone in the audience has any questions.
So you guys talk a lot about go-to-market for zkDay technology, right? So in your eyes, what could be the most likely kind of killer application in zkDay in addition to the rollups?
Yeah, so I think the question was, we talked about go-to-market quite a bit. What do each of you think is sort of the killer app for zkDay besides just rollups?
Yeah, mine was KYC, privacy, understand like leveraging zk to build out a potential DID that you could use for KYC, bringing like off-chain data onto on-chain, make it private and secure so that like users that are kind of very vigilant, like that are kind of very against like KYC on exchanges have like a better way, a better route to kind of to get their KYC information to these exchanges and be able to trade on them.
Killer app is a very difficult question. I think there's some merit, as we discussed, like the zkML angle is certainly, I'm sure there'll be a killer application. And as Will mentioned, I think Jensen, also a portfolio company of ours, I don't want to shill too much, but definitely think there's a niche there that's going to be unlocking a lot of the latent demand, I think, as Will formulated it. So, you know, they're doing like verifiable training of machine learning models. I think there's a killer application there. Yeah, and other than that, I think anything that sort of adds privacy or verifiability, whether that is off-chain compute, off-chain data, these sorts of things. I think in general, as I mentioned previously, I think it's more about the general application that these technologies unlock rather than like one specific killer application.
Awesome. Well, I think we can wrap it up there. Thanks to all the panelists.
All right, very good VC panel that we just had. Next up, we're gonna have a keynote number 3. It's gonna be Ola VM. Is Ola VM here?
I think we have some technical difficulties here, but we'll get started as soon as that is fixed.
Yeah, perfect. So, hi everybody. My name is Philip. I am based out of Stockholm, Sweden, and I am the COO of Ola. My previous background is within computer science and finance. Been working with CBDCs as a solution architect and many different crypto tech stacks as well. And I am here today to give you a brief intro to Ola, which is a zkDay. And we actually have a more thoroughly in-depth tech talk in the other room later today. We're going to be deep diving more into the cryptographic primitives and data structures and so on of the actual solution. And this will be more of a high-level introduction to Ola and what we're doing. And we are a team of about, I think, 17 people as of a few weeks ago. And we are mainly computer scientists and engineers, all of us. So, from a high-level perspective, what we're looking to do and solve are some of the fundamental issues that we have with centralized systems. Now, I think all computation does not have to be decentralized, but in a future world, it would be good to have options and have most of our valuable transactions to be interacting on a decentralized tech stack. And some of the existing tech stacks out there today, they're good in their own way, but they aren't decentralized. And that's the goal, right? So achieving a well-functioning Web3 environment, we need to have higher scaling and throughput. We started off with Ethereum and Bitcoin and these decentralized chains, and we got that working. But the transactional throughput wasn't all that great. And then we got Ethereum. We started getting some programmability and the use of smart contracts, but we still didn't have that fast of a chain. After that, we started seeing some iterations on scaling, and we had things like Plasma come along and different flavors of rollups with Optimistic and CK. And on the slide here, we're showcasing some CK EVM solutions, looking to do scaling. And at Ola, we're looking to do scaling, but we're also looking to do privacy. So we think that privacy is a fundamental need for us to have a future decentralized infrastructure where we can actually have mainstream adoption. So these are one of the two main things. So privacy and scaling is the mission we're on, and bringing that to the Web3 space. So some of the problems that we're looking to tackle can be seen on screen here. So one of the big things is bringing back data ownership to the end user. Today, data can be scavenged across the pseudonymous chains, and that can settle most needs, but we want to truly make transactions private. But we don't want to tamper with the compliancy perspective. So we're looking to build out this tech stack, which is private, but still very compliant. We don't want to end up in a situation where you have agencies like the OFAC come knocking on the door and say, hey, what are you guys doing? We're going to shut you down. So we're building this highly private, but also compliant tech stack. Now, the premise of the entire solution is to bring public dApps and private dApps together. So we want to have one ecosystem where they can all live together, and we want to be able to give the users and the developers a choice, whether or not to deploy and interact with private or public dApps, or both. So essentially what this is a hybrid roll-up solution that we're looking to build out. See if this thing works. Okay, it stopped working. Can you go back? There we go. No? Oh, no, it's jumping. I think there's some delay in this thing, so I clicked a bunch of times and now they all came at once. Right. So essentially, this is the bread and butter of our solution. This is the core of Ola. And we are looking to build a highly efficient zkVM. So the spectrum of CK in terms of the Web3 ecosystem, it's really a spectrum of trade-offs. I'm sure you guys have seen different articles on different CK EVMs, and how they are EVM equivalent on the scale of 1 to 10 and vice versa, and Vitalik had a post with type 1 to type 4, etc. We are not a CK EVM. We are compatible with Ethereum through our compiler.
So you can have your high-level language and you can deploy on OLA and we connect with a smart contract to Ethereum layer 1. But it's highlighting that this could be any other chain. We could deploy on Celestia or Aptos or whatever that may be. We could even, if we wanted to, deploy on zkSync Era, which would make us an L3 then if we're using buzzwords here. But essentially what we're building is this encrypted execution environment. We're looking to bundle transactions and send them somewhere. And we want to do this as fast as possible and as succinct as possible. So this will inevitably be quite technical, but we have within our language then some features that we refer to as profit. And if we have any developers in here, this is very similar to what's known as hints in Starkware. It's essentially about taking computation, which is not very zk friendly, and we take that out of the trace, out of the VM. It's still actually handled by the VM, but we can take that out of being proven. We can have it in some script, in some other high-level language, and we can just get the calculation back and prove the calculation was done correctly. And this helps with zk efficiency. Also for developers, if you're familiar with built-ins, this is pre-compiled in Ethereum. So in the core of Ethereum, in the EVM, you have some functions you can call, or in sometimes addresses as well, to these functions because it's more efficient. But we'll be touching more upon this in the technical workshop later today. We also have a RISC architecture, an ISA, instruction set architecture, and all of these are quite technical topics, so I won't touch upon that. But what I can mention is that our proving system is based on Starks. zkSync is an example given, recently also pivoted to using Starks. We have done a lot of research within our team on different zk backends, and today we're using two algorithms known as Starkey and Plonky2. And that's because they are Stark-based, they don't require a trusted setup. They both deploy the Goldilocks speed, which is good for us. And aside of that, we're also doing some things on the hardware side of things. We're improving what's known as NTT. I will not be touching upon this in this talk either. We can talk about that in the workshop later today. But all you can see here with the entire design is making as an efficient VM as possible. So if we go back to the article I mentioned before with Metallic that a lot of people know about from type 1 to type 4, we're a hyper type 4. We're doing everything we can to increase the throughput in the system. Right, so let's talk about privacy. It's kind of become taboo to talk about this, and privacy is kind of frowned upon, but it really shouldn't be. I mean, privacy can and is compliance friendly. And this is actually a big differentiator between us and some other teams in the space in terms of the actual design and schemes here. So most of the teams that I know about in the space have many different trees, Merkle trees, where data is stored. And they have multiple trees so they can decouple the transactions with storage. So we don't want to be able to trace the transactions. So example given in maybe ACID or Aleo, you cannot trace transactions at all. Whereas we're going down a slightly different route. We want to keep the actual computation hidden to protect user privacy, but we enable the tracking, the backtracking of different users. So we're using UTXOs under the hood, and you're able to then per block backtrack to see where these funds came from. And why this may be important from a regulatory view is that what if North Korea comes onto your platform and uses OLA? Well, then we can see from the origin that some payment took place that went private, but we can follow those UTXOs to see what actually happened, which adds another layer of compliancy. And here we can see the two trees we have in our design. So we have one public root and we have one private. And what we're seeing below here is just some composability with function types. So these are function types in OLA-lang, which is our language. It's a Rust-like, Solidity-like language, but I have another slide for OLA-lang. This will also be more in-depth in the workshop we have later today. So touching upon compliance once again, if you think about your traditional chains, maybe Ethereum would be a good example. In Ethereum, We have what's known as EOAs, externally owned accounts, and basically you have a seed phrase which derives a private key and derives a public key. And in OLA, you have many more keys here. And this allows for greater functionality. So example given here, the viewing key. If everything is private in the system, nobody can see my data, but maybe I want to share my data with a third party. And I can do that by sharing the viewing key. So I can go to some regulator, or for tax purposes, I can showcase my entire history. Or maybe empowering the user. So you have teams like Shin Analysis out there, and their entire business model is around scavenging free on-chain data. But if they can't access that anymore, maybe I can approach them and say, hey, I'll share you my viewing key for $5 a month. So we're bringing data ownership back to the end users of the platform. And then we have OLAN. So as I mentioned, OLA and OLAN, it's a Rust-like, Solidity-like language. Our zkVM is Turing complete, so you can deploy any arbitrary logic in OLAN. And we have our constraints and gates on the actual virtual machine itself. And we take care of all the circuit writing. So that's the beauty. We want to abstract away all the complexities. It's like you're walking into a room and you want to turn the lights on, you just flip the switch. You don't need to think about how the copper wiring is wired behind the wall and how electricity is funneled down from the street. We take care of that. Developers just come in and build dApps, which is what they're good at, and we do all the zk stuff. And yeah, the roadmap. So we launched the POC this year in February. So you can actually already today, locally on the machine, go to our GitHub repositories, download the prerequisites, and you're good to go. You can generate your own proof locally. The next steps for us now is having an internal testnet where we whitelist people to onboard and try it out. And then end of year, Q4, we're looking to have a public testnet open to everybody. Also in the top here, I'm not sure if you can scan from that far away, but it's a link to our Twitter, by the looks of it, and Discord, where you can follow the tech progress and see what we're doing. And I want to highlight once again, if this has been interesting so far, I will be later today diving into the cryptographic primitives and the data structures and more into the trees we were looking at to go through the design more in depth at a technical level. And I'll stop there. I think we're almost on time. Do we have time for questions or? Okay, so if we have one question, we can take that. Otherwise, we'll wrap it up. No, everybody understands OLA completely and fully. That's great. Yeah, that's it. Thank you. Yeah.
You said you were building a compliant tech stack. What is it compliant to? Can you speak louder, please? What is it compliant to? You said you're building a compliant tech stack.
Right. So when I say compliant, so we had a scenario with Tornado Cash earlier, where you essentially have untraceable assets. And regulators across the globe, in the US, Europe, and APAC regions, they aren't really loving the concept that everything is private. So there's not one particular framework I'm referencing here, but I want to highlight that we are providing a very compliance-friendly infrastructure. We allow for the tracing of transactions through the system, and you also have extended functionality to share your data with third parties, meaning that we're not going to have a situation where assets are untraceable and you're trying to hide things. You know, compliance, privacy, it's kind of frowned upon, and it doesn't have to be that way. We just want to protect our data, and I think that's a fundamental need for mainstream adoption, but highlighting that we can do this in a very compliant way and work with regulators. All right, thanks so much.
Round of applause for Philip. All right. Next up, it's our third panel of the day, but I think Philip is still up. All right. Our third panel of the day is Betty from Lambda class, Nicholas from Elusive, Philip from OLAVM, John from Aztec, and Kenny from Manta Network. Let's give them a round of applause, please.
Hi guys, thanks for letting me moderate this panel. I'm Fede from Lambda Class. You can follow my craziness on Twitter, Fede_intern, until I get banned again, and I have to change my handle. I would like you guys to introduce you, to explain the core ideas of the blockchain you're building. On how do you see yourself in the space? Who wants to start?
Hey, I'm John, head of growth at Aztec. We are a privacy-first zk rollup on Ethereum. We think of ourselves as a privacy-first zk rollup, so privacy is at our core, but we also have a public execution plan.
Yeah, I was just on stage. Philip is my name, COO at Ola, and we're building, similar to Aztec, a privacy-centric scaling solution, an encrypted execution environment.
Hey guys, my name is Nico, and I'm one of the co-founders of Elusive. We're not building an own L1 or L2, but rather we provide privacy infrastructure for existing L1s, with which developers and end users can easily add privacy to apps they already use.
Hi everyone, I'm Kenny. I'm one of the co-founders of Manta Network, and we are specifically using zero-knowledge proofs for on-chain privacy. We have our L1, Manta Atlantic, which is focused on-chain identity and compliant private payments. And then also we have just launched testnet for our optimistic L2 that uses Celestia for data availability to lower transaction costs, with a focus specifically on developing and deploying zk applications.
Yeah, we should use both. So the next question I have is like, do you have any particular use case where using privacy is very important? Like obviously transfers is like the obvious answer, but is there any other type of application that you feel that your product will enable that cannot be done without zk?
Sure, I'll go first on this one. So yeah, the question about anything else besides sort of on-chain payments. I think one other thing that is kind of, or not kind of, but very popular right now is on-chain identity. Thinking about every single data point, every single piece of information that you put on chain, mostly in the form of transactions, interactions with smart contracts. This is all fully public for the most part, right? There are certain chains in existence or being built, such as the ones that we're building up here, that enable these sort of private forms of identity. And I think that that's definitely a huge use case moving forward, especially if we actually want to scale out to use cases that actually have real world functionality.
Yeah, definitely agree with that one. But another one I think is huge as well is DeFi. Like for me personally, whenever I talk to someone who's not in crypto or not in tech, and I tell them what I'm working on, most people just assume that anything related to finance is already private by default, which isn't the case in blockchain technology. And of course, if you consider wanting to port over traditional finance, big investment firms or banking or anything like that over to the blockchain, you can't have it in a situation where everything is fully public, just because some trading algorithms, you don't want your competitor to be able to trace it at every step, or knowing what your current financial status is also not information that many people will even share with their closest family, let alone with everyone on chain.
Yeah, I think we touched upon the biggest two, which would be DeFi and identities. However, I spoke with a very interesting project, which I forgot the name of yesterday, where they wanted privacy on chain because they had a function where they're looking to have an AI bot where it can predict the price outcome for ETH, the asset, or any other asset for that matter, for the next 5 or 15 or 24 hours or minutes. And how that worked is that they had people do analytics, and they can predict their outcome, and they stake some kind of token by doing that. And then this algorithm will take their stake, depending on how big it is, and evaluate that with people who are against and for ETH moving up in price over that time point. And this is an example where the algorithm over time, hopefully together with these analysts, would predict a good outcome. And then the problem is if that is fully public on chain, meaning the analyst predictions, then you can just check the mempool and see what they think and not purchase that data. So the key premise of this app is to just sell a token containing the prediction and how likely it thinks it is from a scale of 1 to 10. And this is a perfect scenario where if that's already public, the predictions of these analysts, then why even purchase the data from the beginning if you have scalp the mempool for the predictions instead? So I think this is an actual example of where privacy could be useful, but if it's not there from the get-go, then these kind of applications couldn't be built.
I'll go in a different direction and say we've been working the last couple of months with Aragon on private voting architecture for Nouns DAO. And I actually think privacy is like an attack on socially centralizing forces. So we know that public voting is one of those things where, we know governance is functionally run in Telegram groups where people, DM each other and they're like, I can see the way you're voting. You better vote this way. Please do it on chain so that we can all see. Private voting allows you to credibly vote your heart's will, rather than the social will that's kind of communicated through Telegram. And we've enabled that through Ethereum storage proofs. And there's a bunch of governance problems that we think can be resolved through private voting, including 11th hour voting issues, where if you can see all the votes being tallied on chain, it behooves you to wait until the last minute, kind of whip up your votes through Telegram and then publish them all on chain at the last minute and win. And so it really changes the game theory of DAOs and we think makes them significantly more credible when it comes to decentralization.
Cool. Next question is, well, I will say something before the question. I wrote a paper related to Tornado Cash to de-anonymize transactions with some people from Stanford 1.5 years ago. And because of that paper, I got a difficult call at some moment, only for writing an analysis of machine learning on the transactions to correlate the transactions. It's called Tutela. After that, my lawyer recommended me not to work on privacy-related blockchains. I'm a big fan of privacy. I think it's very important. But to be fair, I got a little bit scared. How do you see the regulation coming? Do you think it will improve? How do you see the landscape?
I have a hard time speaking to the regulatory landscape, and I like to remind people that OFAC was not really a regulatory action, right? It was a national security action. And so
that's even worse.
Right, could be worse depending on how you look at it, right? Because it's totally unimpeachable. It's not an elected body that's making that decision. My belief has always been like they could have censored Ethereum, but they didn't. Ethereum by definition captures all of that activity that happened on Tornado Cash. So why did they not do that? Well, there's like some balance of harms happening, right? They're kind of weighing, okay, what's the benefit of Ethereum versus the harm of Ethereum? And they're like, okay, I got to just hyper target this one thing and like cut it out of the system. That's why we think privacy by default is so important. If accounts were, by default anonymized and everyone was just doing their thing, I don't think we would see privacy as a problem. It's a problem when a very, very small number of people elect into privacy and they happen to be users who want to do a very specific thing. And so I think when we normalize privacy through some of these use cases that we talk about and make them everyday and boring, I think regulators see that and they say, okay, well, that captures the entirety of blockchain. It's not like a specific group of people using this technology.
Yeah, so like encryption, like what happened with encryption, like it's massive.
Exactly.
Yeah, I think that those are very good points, and our teams are very similar values here. And I think encryption is really a good example. And this was almost before I was born. I think the U.S. government tried to ban encryption, and they had this massive battle trying to ban it. And eventually, they realized that they couldn't ban encryption. And I think it's kind of inevitably going to happen with decentralized tech stacks as well, that there will be privacy. And it's more of a matter of communicating and working with regulators. I think there needs to be a lot of guidance here and collaboration between the teams working on this and regulators. I also think, if I'm not mistaken, that you guys at Aztec even submitted your tech as a proposal to the Bank of England to their CBDC. which showcases that you can actually utilize this tech for more centralized forms of blockchains. And I mentioned previously in my keynote here that I used to be a CBDC architect, and we did live implementations where our goal in this technical pilot was to mimic the properties of cash. And cash is not trackable. It's the most anonymized form of payment that we have out there today. You cannot track physical coins or dollar bills. And one of the things we did was looking at, can we mimic this entirely? And what we did then is that we looked at the option of having fully anonymous CBDC wallets, where it's kind of like a top-up card. So you're fully anonymous, but you can only top up to a certain limit. And that's just showcasing that governments also care about their citizens and how we can mimic those properties. So I think it's just a matter about talking with these regulators and guiding them as well of what we're doing at the commercial side of things and the decentralized side of things and how we can guide them.
Yeah, totally agree with both the points made so far. And yeah, I think the encryption comparison in the like 20, 30 years ago, something like that, it lines up pretty well with how zk privacy is today. Because I think most governments aren't opposed to privacy in general, or they don't want anyone to have privacy and want to oversee everyone. Maybe I'm a bit optimistic, but that's my view of it. I think it's rather just that back in the day with encryption, they really had the view that, this is only some arcane technology that's used by bad actors. And unfortunately, I think that's what many regulators, that's their view of zk for privacy today, especially when they looked at the example of Trado Cash, which unfortunately had a couple of bad actors using it. So yeah, I do think it's a combination of, on one hand, communicating to regulators that privacy is something normal and is something that's necessary for many applications to find mainstream adoption. And on the other hand, building technologies that are a little bit more resilient than some in the past to misuse.
Yeah, so Fede, I completely understand about your lawyer coming to you and saying you probably shouldn't be working on privacy stuff. I've heard that a lot from a lot of lawyers, so totally resonate. Also, all the points currently being made, I think it's all sort of alluding to the fact that this is it's not as simple. It's not black and white about whether governments care. It's more about how they should care, right? Because at the end of the day, what ends up happening is that if you have a scenario, right, like scenario A is blockchain and crypto is completely wiped off the face of the planet, in which case everything that we're doing here, regardless of its privacy or DeFi or saving the world, is useless, right? Because it's all gone. That's scenario A. Scenario B is you have a middle ground where things kind of plateau and they stay like this, and we're all just kind of in our own little Web3 circle and we do our little Web3 things, but it never really expands. And then scenario C, which is, I think, what a lot of us in this room are hoping for, and believe in, is this massive expansion of decentralization, self-sovereignty, the ability to kind of balance that control of your own data versus the applications that you're interacting with. In scenario C, I think privacy is critical, it's necessary, and I think that governments should think that way as well, because when you're leaking this type of data as an individual, you're the individual of a particular country, you're a citizen of that country. And that's no longer just a problem of your own country monitoring you, but all other countries also monitoring you. And this kind of alludes to CBDCs as well, right? Like, why is it that no one cared about CBDCs, but then all of a sudden China says, I care about CBDCs, and then everyone's like, well, we care about CBDCs too, right? No one's trying to be like, oh, I want to be like China. I mean, yeah, China, no, okay, I'm Chinese. But I'm not saying people don't want to be like China. I'm just saying that there's no reason for people to just say, I want to imitate another country. The reason people want to also start researching CBDCs is because CBDCs are a great economic infiltration into other countries to attack other countries' economies and take control from the inside, right? And so you don't have any sort of controls or defenses against this. Next thing you know, all of your citizens are going to be using CBDCs from another country, and now all of a sudden you have no economic control anymore, right? And so it's almost like a zero-sum game. And I think just as much as people care about the preservation of the value of their own currency, or when I say people, I mean governments. Governments care about the value of the preservation of their own currency. governments, I think, also care about the preservation of the safety of their citizens. And so at that same, vein, they do care about, other government monitoring, in which case they should care about on-chain privacy in scenario C.
There's a very good video. I don't remember the name of the channel, but there's a frog on it. It's about what you just said. It's whenever there's a hack, there's a web page where you can see the hacks.
How about that?
Which one? Yeah, right. There's a very good video of Rect speaking actually about what you just said, like about how CBDCs are going to be used with like other countries and how Ethereum, Bitcoin, and other assets on blockchains will be more interesting because they don't depend on one nation state. So I completely agree with you. Moving into more technical things, do you guys have any programming language on your particular blockchain? Are you using Solidity? How was that decision to come in the case of Noir? How did you decide to create a new language? Always creating a new language implies getting a lot of attention on creating a lot of tooling. It's like a very big investment. So how was the decision of using a new language, keeping the old one? How do you see that?
We developed an open source language called Noir, and I think it really started with addressing developer pain points. So we're kind of in this phase where we're looking at developers and we're like, we will do everything in our power to make it possible for you to develop in zk easily. That means you have an unlimited amount of our time and our resources and improvements to the Noir language. And our developer relations team does an excellent job of improving adoption there. Our goal really is to try to disconnect. If there's one takeaway I want you as an audience to take away from Aztec today, is that Noir is not Aztec specific. Is that our goal with Noir is to make it a universally versatile language for zk development. And our hope and our go-to-market is if we build this open source public good and it's useful for everyone, then eventually someone will incorporate Aztec smart contract syntax and come over to us. But even if that doesn't happen, we're happy to have created this universally well-liked public good. And so that's really our mission with Noir and why we developed an entirely new language.
We also have our own language in Ola. It's called Olalang or Olang. And why we have that is also to make it more convenient for developers, but also that if we're looking at Ethereum, Ethereum is not compatible with privacy. We're using UTXOs under the hood, and as you may know, Solidity is not compatible with UTXOs. So that is one of the reasons. And with Olalang, we're also trying to make it as accessible and easy to use as possible. So one of the additions we're making is, first of all, it's Turing complete. So you can deploy any arbitrary logic on top of Olang. And we're also looking to abstract away all the complexities that is there with zk. And this is slightly different to some of the other teams. We have circuit writing into the language, making it a DSL. So we're trying to abstract that away. It's kind of like, and I had this metaphor before in my speech, but if you walk into a room and you want to turn the lights on, you just flip the switch and it works. And that's the level of abstraction we're looking to have in Ola. So we have constraints on the VM for zk purposes, and then you can deploy as any arbitrary code. And you don't just think and worry about the zk writing and zk circuits. It's just taken care of. And that's also why we have Ola.
Yeah, so for us, we took a bit of a different approach, also because I think Aztec and Ola are a bit lower down in the stack as being a L1/L2, whereas we operate directly on the chain. And so for that reason, for us, we took the approach to rather just provide an SDK that works with the existing language of said chain. And the thought process behind that was a bit more so in the direction of saying, for a developer to learn new language, oftentimes is, even if the language is easy to learn, it's still a big decision to take because there's 100 different languages or 1,000 languages even these days, and there's so many trade-offs if you decide to learn one more. You could have learned Go or some other cool new language instead of the elusive language if we had one. So that's why we decided to go with existing languages, because the idea then is you have to learn how to use the elusive SDK, okay? But then if you decide, oh, elusive doesn't work for me, or I want to continue working on something different that doesn't have anything to do with privacy, at least you didn't invest as much time learning a fully new stack for it, but rather the skill you learned learning the language, for example, Solidity that you're using with the elusive SDK, you can still apply that to a different project. So in that, we think it lowers the pain a little bit for new developers to onboard onto privacy in that sense.
Yeah, so for us, I guess it's a little bit of both. Both we have some sort of adaptability in terms of languages, and no, depends on which environment that you're building in. On the L1 on Manta Atlantic side, there is no new language. It's not a Turing complete chain. It is UTXO based, and so for the exact reasons that OLAP VM is doing it that way, right? And so Manta Atlantic is specifically focused on deploying various aspects of on-chain identity. Manta Pacific on the L2 side, we are also kind of taking that abstraction approach on the SDK side. What our whole premise is, or what the thesis is here, is that instead of having to focus on the complexity of building these types of circuits for the average Solidity developer, which everyone here kind of, we're all saying the same thing, right? We want to abstract it and make it a lot easier. That's exactly what we're doing as well. We're just kind of compiling these into smart contracts that can either be called directly through the interface or also through SDKs. And that I guess like the key difference here is that ours is specifically focused on Solidity developers rather than the language that's adapted to the VM.
Yeah, I will enter a little bit more the technical discussion. Which pooling system and why did you choose it, and how do you see that mixed with the hardware acceleration? Like, do you think it's going to be very important? Do you think it's close to be ready? I have my own opinions. That's why I wanted to know how you see it. Like, for example, Struct based, like Ola. You're Struct, right? Struct based, or
We are Struct.
Yeah. So, for example, I understand from my point of view how hardware acceleration is not that important, but I wanted to see like how each of you see the proving side on the hardware acceleration side of things.
Oh, sure. So I guess proving system, we're a family of Groth 16, and we have proven this with our trusted setup, I guess. And I guess on the hardware acceleration side, so we haven't really been focused on gearing towards particular hardware, just because I think that with on-chain privacy, with zk, it has to really be hardware agnostic. This is because, for the end user, the person that's actually touching the applications, you don't know what device they're using, right? It could be a modern laptop, it could be a modern computer, could be a cell phone, right? Whatever it may be. And so it's more about, focusing on the optimizations rather than having to depend on any particular hardware. So I guess we haven't really, focused that much on the hardware acceleration side.
Yeah, for Lucid, I can basically echo what Kenny just said. We're using Groth 16 as well. And yeah, same idea. Like, I don't believe that hardware acceleration, specifically Lucid, what's used for most at the moment is DeFi. And in those cases, most of the time the user that's visiting it, it's just visiting it from his computer, which doesn't have any special chip. And my thesis is that probably not that near time in the future either. It will have a special chip that is very good at doing particular zero-knowledge operations. Yeah, we're just more focused on optimizing it on the software side rather than hardware side at the moment.
So at Ola, we're doing both. We've actually changed our zk backend many times. We started actually looking into cutting FFT and using MSM. Yeah, you shouldn't, right? And then, as new research comes along, and there's many articles being released all the time, and we kind of figured, well, okay, we see that this is better now, and that's how we ended up using Stark. So our zk backend is composed of Plonky 2 and Starky, and then we've also looked into adding F-Plonk, which is a snark Plonkish final step to succinctly have that to whatever layer we deploy upon. So many different steps here. And we are also open to, following the research. I think, things change, evolve, and adapt over time. And what we have today, which seems to be the best tech stack, might change in the future, in the coming month or months. So we're always actively on the lookout to study this. And we recently did a lot of studying on the sum check schemes and also of incrementally verifiable computation with the building schemes of Nova, Supernova, and Hypernova, and so on, which could also, in theory, be applied to our solution, and our engineering team is actively looking at this. And we have done a lot of research, extensive research on the hardware side of things as well. I think we spoke about end user devices here, and I think we all kind of share the same pain points here, that probably a phone, depending on the workload, would not be able to calculate many proofs. So most likely we'll be looking at more computationally heavy proofs being done. So a laptop on client side would probably be required. We are at the moment doing a lot of research on GPU, specifically acceleration with NTTs. I'll be touching upon that, I think, briefly in my workshop later on today. And I think in the future, we would probably be seeing maybe FPGAs or ASICs be developed for this purpose as well. The problem with ASICs is that they have a write-once logic, whereas FPGAs and DPUs are reflashable. And that means that if you develop some logic on your ASIC that's catered to this very niche and specific use case, and then if anything changes on the software side of things, you're going to have to start from scratch. So I don't think it's feasible today with the rapid advancements we have in zk Tech, but I think we might see ASICs in the future, kind of like how we saw ASICs come for the Bitcoin network.
Our crypto backend for Edinburgh is Plonk-based and includes a couple leaps forward from our cryptography team, including a move to Honk, which is our next generation proving system. I think Aztec is still a bit away from mainnet, so our team is still researching how to speed up proving. But I will say, as a shill for, again, Noir being an open source and completely backend agnostic language, what we want to do is, let us figure out what's optimized for Aztec. But as a developer, as a zk dev, you should be marrying a language that allows you to be totally future-proof. And so Noir compiles to an intermediate representation and allows you to plug in any crypto proving backend, allows you to be totally future-proof. So right now we have our Brandenburg backend, we have Draw 16. I think yesterday Halo 2 just shipped. And so these are APIs and backends that you want a better UX, a better front-end UX to interact with some of these proving systems, but still want some of those capabilities. Noir is the place where you should land.
Cool. On the NTT, we have a repo called LambdaWorks. It's an open source thing. We have been doing quite some work on making the entities very fast, and you can run them on web GPU, CUDA, Metal. There's amazing work being done by the CUDA team in NVIDIA. They just released a library that's not very well known in the crypto space called QFFDDX, so that you can run changes on the FFT on each kernel. So there's a big advances coming on all the fronts. So I have one last question. I don't know how much time we have left, because I was checking my phone, and since the time changed, I don't know very well. The last question I have is like, how do you? I think privacy should be the default. Privacy should be for common people. But do you have any clue on how we can avoid or catch bad actors using our networks? Is there any way or any potential tool, or is there any way of having privacy but also being able to have some way of catching hackers when they have some protocol or when they want to get out of the network? What's your take on that? I don't know enough about it, so probably you guys saw way more than me on that.
Yeah, our founder and CEO, Zach Williamson, has been working with Vitalik on this notion of cleanliness providers, which is positive attestations by third parties, still decentralized third parties, about the cleanliness of kind of like your transaction history. And this is kind of this notion of a social consensus layer for good actors, right? I think what we don't want, in my opinion, is a backdoor, right? That you don't want a privacy backdoor where someone can open the door and be like, okay, this, and this person should go to jail. And so this might not be a perfect solution, but the idea of cleanliness providers is positive attestation of good behavior. And so if you can get everyone to default to positive attestation, say, hey, I'm going to provide a cleanliness proof that's been validated by this set of third-party testers that I haven't touched any bad funds, and everyone does that, then there's an implication that if you haven't done that, you've done something wrong. Not a perfect solution, but I think we're in the early stages of balancing these two things. How do you provide trustless privacy without opening a backdoor?
Yeah, it's a very good question, and I think it's a nut to crack here that we really haven't fully cracked. But what we're doing at OLA is that we're trying to design a, as much as possible, compliance with friendly scheme. So what we're doing is we want to maintain end user privacy. We want to maintain the computations and calculations to be private, meaning the transactions that the users are doing in the system. But we have a system where we allow for tracing of what we call commitments, which is basically just encrypted plain text data of that said transaction. So a quick example would be if Alice pays Bob, which is a different person, we could see that from publicly the first transaction that Alice is the sender, but we can't see the recipient. And then if Bob maybe goes ahead and pays Kenny over here, we can see that some transaction took place between Bob and Kenny, but we don't know who these two entities are. So maybe an example given, if you have some hackers then doing bad things, and you can identify that the initial funds were actually from malicious actors, then you can go and pinpoint through the system to where that funds has gone. And if you ever want to exit the OLA ecosystem, they would have to go back to that last public viewpoint, and we can see that. So we're doing these steps to counter and tackle these issues, but still at the core of the protocol, we want to maintain that fundamental need for user privacy.
Yeah, so we have a bit different approach to that as well, considering that we live, like in general, the way Elusive works is that we live on an existing L1 that's public by default, and we add our smart contracts, add privacy to that public layer. And in applications similar to ours, frequently the way you approach compliance is one of two ways, which in my opinion are both flawed. The first way is basically viewing keys or something equivalent like that, or checking that you're not on the OFAC list when you enter certain privacy smart contracts. This is flawed because viewing keys on one hand frequently has the problem that, if you're good at it, you can prove that, which is nice. But of course, if you're trying to keep a bad actor out, no bad actor will ever generate a viewing key, obviously. And wanting to isolate him will require everyone inside the pool to generate a viewing key, which doesn't scale beyond a certain size. And checking that the bad actor isn't that the person depositing isn't inside of some blacklist or some something like that at deposit or withdraw time has the flaw that the bad actor can just send it across 1,000 addresses before entering your system. So you kind of, and of course the knee-jerk alternative to that is to KYC everyone, but I don't think they need to explain why that's not a good solution. So we at Elusive came up with something we call Elusive Zeus, which is what we're kind of developing right now. Where the main idea is basically that frequently in past systems, you have the case that someone hacks a smart contract on chain, for example, and everyone can see, oh, this address is the one that hacked the smart contract on chain. And most participants in the privacy protocol or on chain in general would probably have consensus that that specific bad actor should be protected, or at least not in the same way that good actors aren't. And so using MPC, we derived a way which my co-founder actually gave a talk about how exactly the tech behind this works earlier today. We can capture this on-chain consensus and transform that into revealing certain transactions retroactively within a certain time frame. So we think this is quite powerful because this gives a good trade-off between the worst case scenario where you have one central point of failure that is basically a backdoor that controls everything, and the other case where it's fully decentralized and there's no way to recover from a bad actor. So, yeah.
Yeah, I think there's been a lot of great examples of this sort of balance. And the question itself, when Fede first asked it, was he was kind of struggling to find the right answer to it. And I think we all struggle to find the exact right answer to it because there is no right answer to it. And so, I think one of these challenges is that, just as we are all building on the infrastructure side to enable these types of features and functionalities on the application side, I think it's also a responsibility on the application side to decide, what side of the line they stand on, or how far they want to go, right? And so I think with these types of infrastructure level technologies, then we enable all sorts of different versions of the same type of use case
with a spectrum of various different levels of compliance, regulatory adherence. And you know, like that's something that I think will naturally kind of form. And yeah, I don't think it's up to us to necessarily have a say in what's right and what's wrong. I think it's just part of the markets, you know, like it is, as long as there's some type of value to be derived, there's always going to be a way to derive it, and there's going to be a good way to do it, and there's going to be a bad way to do it. Yeah.
Do we have time for last question? Well, I will ask it. Today, Sama.
Sorry, is that a thumbs up or a thumbs down? Just looks like
I'm not
a blurry
seeing.
hand.
Yeah, okay. Thank you. Sorry, I missed you having the clock over there. So I had a last question related to something a little bit different, but it's related to privacy. I'm not a cryptographer. I come from engineering. Only 1 or 2 years ago, I learned about fully homomorphic encryption because I was checking a company, French company called Sama. There was also one really interesting called, I think, Sunscreen from the US, if I'm not wrong. I have been following the development on today, I think, or yesterday, they launched an EVM that uses fully homomorphic encryption. How do you see the interaction between zk and fully homomorphic encryption? It's something you're looking, it's something that you believe is too slow, that it's not important. In my case, I believe zk is more important. Having FAG without zk, I think it's complicated because you cannot verify what happened on FAG. But what's your take on it? Do you have any opinion? Maybe it's a too open question, but I would like to know how you see things.
Sure. So I'm kind of speaking on behalf of another project now that actually does combine zk and fully homomorphic encryption, specifically for the purpose of designing on-chain poker. And so I don't know how many of you guys are familiar with the idea of mental poker, but it's this conundrum where, like, you know, if you and I, one of us, were playing chess together, it's very easy to play chess in our minds because we know, exactly where the pieces are. Everything's fully transparent, right? The only untransparent thing is our strategy, right? So I can say knight to d7, and we can both agree that knight is now on d7, unless it's an illegal move. But it's not the same with poker, right? Like we can't agree on which cards should be where in the deck without revealing the cards, right? And so we can't really mentally play a game of poker with each other. And that very much translates into how we build poker on the blockchain, or trying to solve for mental poker by building poker on the blockchain to peer-to-peer players. And so this group is specifically using the homomorphic encryption for the shuffling, and using zk for the proof of that shuffle. So I mean, like, definitely, I think there's ways that you can kind of do like a 1 + 1 = 3, and I think this is definitely one of those scenarios, because fully fair, trustless poker is definitely a challenge to build. Yeah.
What's the name of the project?
Oh, it's called zk Hold'em. Yeah, they're actually right next to us in the the main venue.
Yeah, so to be completely honest, with Elusive, we don't really use FAG for anything. So I don't think I'm too qualified to exactly comment on it right now. So
me neither. So.
Yeah.
Yeah, I'd say the same thing, that I'm not educated enough on the matter to give a good opinion. But it's been interesting to follow. I think even Google was looking into this way back with their search engine, where you give it some prompt and it should know about what it's performing calculations on and spit out the result back to you. And I think they had like a massive engineering team working on this for quite a while, and then they realized, oh shit, our main source of revenue is from targeted ads. And they were like, they shut down the entire operation because they realized, well, we're killing our own business model here. But I actually think this was like 13, 14 somewhere, where they had a big team working specifically on this.
Yeah, they have a good compiler.
Yeah.
Myself too, I believe.
But yeah, I guess that's the only input I can give to this discussion.
Yeah, I can only represent the opinion of our team, which is FAG kind of seems like a holy grail, being able to do compute over encrypted data. The way that Aztec works is you kind of have to download an encrypted note, open it up, do some compute on it, put it back in, submit a proof with the encrypted note to say, hey, look, the compute that I did locally is legitimate and follows the rules of the blockchain. And so that's kind of the subtle difference. With FHE, you kind of just send your encrypted data to a server and then they can do it fully homomorphically. That feels like a holy grail. I think our team feels that it's quite far away, but we're looking into FHE techniques to potentially reduce, for instance, the amount of encrypted data you need to download to your own machine. Currently, the way we do it is trial decryption, which is we're just going to open all the nodes sequentially until we're going to sort through all the nodes until I have the one that belongs to me, and then I'm going to open it up and do my compute on it. Whereas with an FHE technique, there could be something called oblivious message retrieval, where you essentially ask the node for your encrypted note. They provide the encrypted note, but neither party kind of reveals any information leakage. We're still very, very early in research, but we're a zk project, but really we're a privacy project first. So we're looking into any technology that can help us make privacy unimpeachable.
It's really interesting how zk, in particular, on the economic incentives of the blockchain, are pushing all these new cryptography-related projects. Because FHE, like for me 2 years ago, was like science fiction. But now, for me, it also seems like a little bit far away. But it's coming closer. And zk has done an amazing job, and also the incentives for that. So thanks everybody. Please give a big applause to Nicolas, Philip, John, and Tom.
We still have a few minutes to ask questions from the audience. So if anyone has, you can ask. Okay. Then the next presentation is by Manta Network and Kenny.
We're about 15 minutes behind. Hi, Ray. Can you hear me? This is Scott. Oh, hi, Ray. Sorry, you're in the wrong position. I need you to get back to the laptop because so I sent you access to the Google Drive file. I think it should be like Manta Pacific zkDay or Manta Pacific intro, not workshop. That's too technical. Yeah, okay, great, awesome. So I'm going to try to rush through this really quickly because the more exciting part is the fireside chat that we'll have with Celestia in a second. But Manta Pacific, so I kind of already talked about this earlier and just kind of want to get a little bit more into detail about exactly how this works and why this is kind of so passionate for us. And so, this is a car, right? Specifically, does anyone not know the model of this car? Does anyone? It's a Lamborghini. It's a Lamborghini van or minivan. I don't know. It's a Lamborghini. It's very fancy, and this is a Toyota Prius. And does anyone know Autoliv? Anyone? Raise your hand if you know Autoliv. You know Autoliv? Okay. Wow. Good for you. Okay. So Autoliv is a seatbelt manufacturer. And, whether you're driving this fancy Lamborghini or this, economical Toyota, at the end of the day, you're using the same seatbelt from the same manufacturer, Autoliv. And you can Google this and you'll see lots of recalls. So I don't know about the quality control, but the point being here is that not everything needs to be built from scratch.
right? Imagine if Lamborghini actually built every single seatbelt custom made from scratch, right? Like that would severely halt their scalability. Same with Toyota Prius, which probably needs much more scalability in terms of sales. And so, the same thing applies to a lot of practices everywhere, right? This is why we have software as a service. You don't go and, write your accounting from scratch on notebook paper and then do your own taxes and calculate them in your head every single year, right? Like you use something like QuickBooks, you use something like TurboTax. I mean, these are all American-centric examples, so sorry if you don't get it, but there's accounting software, everywhere. System integrators, right? This is why you hire people or businesses hire other businesses to build specific software or hardware to do things, and those system integrators don't build it from scratch. They just buy parts from everywhere else. Even airline seats are very similar to cars, seatbelts. Airline seats, you don't manufacture them yourself. Airbus doesn't build their own airline seats. They just buy the airline seats and decide where to place them. And so, Manta Pacific, we're offering this same concept, but for zero knowledge, right? And so we talked about the complexity of zero knowledge proofs, building circuits, et cetera, and how do we abstract that away? By offering it as a circuit, right? Or a service, sorry. So no more need to actually build circuits from scratch, no more need to decide between these types of different proving systems, no need to learn additional languages, just hit the ground running and build. And so what we're trying to offer is that perfect environment for Solidity developers, so that Solidity developers can still build the applications that they need to build without having to focus a lot of time, a lot of effort, a lot of energy or resources on applying any sort of cryptography. And so how do we offer it, right? We offer it through Celestia data availability for lower transaction fees that are reflected back to the user. And this is great because everyone knows that, or not everyone knows, but zero knowledge proof generation on chain and verification is fairly computationally expensive, which results in heavy gas fees. And so anything that you can do to lower that in terms of deploying as an L2, deploying with data availability through Celestia, for example, right, like is a great win for the user economically. And then that also leads to high scalability with modified OP stack through Caldera. And the modified OP stack is kind of a proven, well, I guess quote unquote proven system that has already been deployed in various different environments. And then what we have, which is the universal circuits, and that's kind of the bread and butter of how we abstract everything for the developer. So what are the universal circuits? These are generalized circuits that we have essentially deployed on Manta Pacific as contracts, and these contracts can be accessed through interfaces or through SDKs. And just to kind of get back some time so we can get into really exciting stuff, I'm going to go past the details. But if you don't want to interact with contract interfaces, you also have the SDK, which allows people to build. And so I had talked about zk Shuffle or zk Hold'em in the previous conversation. zk Hold'em is actually a project that uses zk Shuffle contracts. And so zk Shuffle allows you to actually do that fully on-chain, private, decentralized shuffling. And so building a high and low game, right? This is an example here where you can play a game, or I play a game with you on chain, and this on-chain game should be, we have a set of cards. I shuffle the cards, and then you choose one card and I choose one card. And then without looking at the cards, I place a bet, and you place a bet. And then we both reveal our cards. And then whoever has a higher card wins. I know that's not how the real high and low game plays, but just for the simplicity's sake of this example, that's how we're playing it. If you're trying to build this from scratch, right, on EVM, using Solidity, building this or compiling the circuits and everything, then you're probably looking at a total of like 1,000 lines of code across all the different contracts. And also it requires CIRCOM and all this other stuff that you really have to think about. Building with Manta Universal Circuits, you can get this done in about 150 lines of code, and we have this all on GitHub, and I can share that with you guys afterwards. And then furthermore, if you want to just really simplify things and use the SDK, you can build the same exact thing in 30 lines of code or less. And yeah, that includes the one-line brackets. And so that really kind of simplifies a lot of the development process, because we're not just eliminating the lines of code, we're eliminating the mental friction, because now the developer, the Solidity developer, no longer has to worry about compiling in CIRCOM or moving it over to a smart contract or otherwise, right? Like even thinking about Rust. So yeah, that's kind of the beauty of the SDKs. And we actually just launched our testnet today. We've got a lot of different applications that you can actually try out. And so if you want to check out the docs to build some stuff yourself, feel free to, and you can get started on the testnet and more info here. Yeah, I really wanted to run through that because I know we're a little behind, and we've got our awesome guest, Nick, here. And so we'd love to just jump right into the fireside chat.
Sorry to rush your talk.
No, it's okay. It's okay. This is like the 6th time I've given this talk in 2 days, so.
I could tell it was when you were well rehearsed.
Yeah, right, exactly.
I like the seatbelt analogy. I might steal that and use it.
Oh yeah, totally. It's open source. Yeah, MIT license. Yeah. So thanks for being here today. I know you've probably got a busy week. How's your HTC been?
It's been good. I came in from Hawaii, so I was a little jet lagged the first couple of days. 12-hour time difference, but hanging in there. And we have Modular Summit coming up Friday, Saturday. So all you guys should go there. We have a whole zk track, a zk ML track. Henning will be there, and lots of other roll-ups and modular, all things modular.
So do people, after they come back from Hawaii, they're just like more handsome, or are you just like that handsome? Like I was like shocked. Like, no offense, like your Twitter profile picture looks very professional, but like good for you.
Thanks.
Anyway, so getting to the topic, right? Like, I mean, today I really want to just talk a little bit about Celestia and learning more about what you guys are actually doing on the modularity side and what this looks like 3 to 5 years from now in the blockchain space, and try to kind of understand a little bit more from our perspective on the man-specific side, the role that we play as well for zk applications. So maybe, just to start off for the audience, everyone who doesn't know, maybe you can do a quick introduction and talk a little bit about Celestia.
Sure. So I assume people here are all more in the zk space, so you might not be familiar with Celestia and modular blockchain, so I'll give like a quick overview. Celestia is a project that was conceived in 2019, and our founder, Mustafa Al-Bassam, coined this term, modular blockchains, which, like, the underlying idea is that ever since Bitcoin, the primary way that people have been designing and building blockchains is in an implicitly monolithic way, where you couple all the functions of a blockchain into one protocol. So every node in the protocol has to do all this work, and it's kind of like redundant. And it causes lots of constraints on the kinds of things you can build. But if you go back to first principles, you realize you can decouple these functions and then kind of make them modular, and you can have separate protocols sort of specializing in different components. And when you do that, you get all these benefits. So one of the big benefits is you can actually scale the network without compromising in decentralization. So you can increase the block size without increasing the node requirements. So that's a really big advantage. And you also get the advantage that you're not locked into one kind of execution environment. So with a typical blockchain like Ethereum, it comes with one execution environment, the EVM, and what you're building is not possible within the EVM, or it's very slow and expensive. And so by decoupling execution, the developer can go in and actually define their own execution environment. So that gives a lot of superpowers to developers. And one way to think about this is another analogy is that modular blockchains are sort of like cloud computing for Web3, in that you have this, what Celestia is like this raw, very scalable resource for block space, kind of like in AWS that provides raw compute. and then you can tap into it and deploy virtual blockchains on top of it as in the form of rollups. It's the same way that like in cloud computing you deploy a virtual machine, a virtual server. So we think this is like the paradigm that's going to be most useful and powerful for Web3 developers.
Got it. And you had alluded to, superpowers with these modified execution environments. Can you kind of dive in a little bit deeper? Like, what are people thinking about building, or like, what have you seen already?
That's a very good question. Well, I mean, obviously, I think Manta is a perfect example. So as you mentioned in your talk, so they're using Celestia as their consensus and data availability layer in the modular stack that they're building. And then they're leveraging OP stack for execution, but they're working with a particular rollup as a service company called Caldera that allows you to add custom precompiles to the EVM. And so they're adding these precompiles that make it very cheap and efficient to verify various zk proofs. And so, that's a perfect example of where if you just took the vanilla EVM, it would be really gas and efficient to verify these proofs. But now they can just they can be mostly EVM compatible, but add the features that they want. So that's one example. I could definitely give more, but
no worries. I mean, going back to also your idea about, or what you mentioned about like first principles, right? And actually decoupling all these different components and going back to the seatbelt analogy even. I guess why do you think that when Ethereum was built, they built it in this quote unquote monolithic manner?
I think it's because people, it kind of, in some ways, is the simpler way of thinking about how blockchains work. In that we had to kind of have the insight that you can modularize these pieces. We had to first kind of realize what was going on under the hood. And even this concept of data availability wasn't something that people actively thought of because, the way that monolithic blockchains solve the quote data availability problem is that every node just downloads all the data. And you don't run into that problem until you try to scale a blockchain. And so it was only like through the research into scaling that people realized, oh, this is its own separate function that the blockchain has to fulfill. And so I think basically what I would say is that we were still working out the right mental models for how blockchains worked, if that makes sense. And like people were just kind of following the design paradigm that had started with Bitcoin. So it just took time before people really got deep enough to realize what was going on under the hood.
Got it. Okay, so moving forward 3 to 5 years from now, like what does this blockchain ecosystem look like? This whole world look like, and what is Celestia's role in it?
That's a good question. Well, I think there's going to be an explosion of different modules essentially. So like obviously Celestia is one of the data availability layers, but Ethereum is working on EIP 4844 and dank charting. We also have there's another project Avail that's also building a data availability layer. Then you have the execution layer, you have a settlement layer, you have all these auxiliary services like shared sequencing. And so like basically from my perspective in the last 2 years since things have really gotten going with modular blockchain stack, we keep refining these ideas and people come up with new sort of like modules or new ways of slicing the stack. And so I think that'll continue to evolve. But that's on the protocol level. On the application level, I think we're going to see a lot more people starting to shift towards launching their own L2s, their own rollups, because I think people are starting to realize the benefits you get in building in this modular stack fashion. I think you guys are early adopters, and I give you guys a lot of credit for that. So we're going to see more and more people kind of like migrating. I mean, this recent announcement with Cello is another good example of how I think it's like the beginning of the wave. There's like a crescendo, and it'll be interesting. I think there's open questions still around how we're going to solve interoperability. There's going to be user experience questions, but we have teams like Anoma who are building Intense Suave as well. So I think a lot of these problems are like slowly getting solved, and then the last piece is making sure all these pieces fit together and actually function. because the one downside I would say about the modular stack is that you have to deal with a little bit more complexity because of the plurality in some ways. So you have all this choice, but then the different pieces have to be compatible with each other. And that's something that takes a lot of work. It's like, okay, we make the integration, we make these interfaces, but then sometimes things change and you have to make sure that those changes don't cause issues in those integrations, if that makes sense.
Yeah, it definitely does. And so, kind of circling back on, the and-specific. So yes, we are specifically using Celestia for data availability, like I mentioned before, to lower the gas fees, ultimately to deliver more value to the end user on the zk side. It's very computationally intensive. But in my mind here, right, I almost feel like Manta Pacific in this case is very much so an application-specific environment roll-up, right? Are you seeing that trend as well for other projects and other sort of people kind of building with data, the DA layer on Celestia, or do you think it's more generalized right now?
The way that I see it, at least from where I'm sitting, is that I think right now the first wave of L2 is the idea of app chains hadn't really penetrated, and people were more focused on just let's scale Ethereum, let's build a zk EVM, let's build a EVM compatible optimistic rollup, so that Arbitrum, Optimism, zk Sync, Polygon, all these projects were doing that, and I think the whole climate has drastically shifted more towards application specific use cases, because I think there's just going to be more demand for that in the long term because of the advantages that it has. But I do think there's going to be room for all of the above. But I would say, so the way that I think about if I were a developer building an application today, I might start out actually as a smart contract on a general execution chain, either L1 or a rollup like Arbitrum. And then once I've sort of worked out the kinks, figured out maybe I've gotten enough adoption, or tested out my product to the point where I know the optimizations I want to make, then I might shift to deploying my own rollup. But I don't necessarily think people need to. So for that reason, I think there will still be these general purpose execution chains, and people will maybe, it's sort of their application might graduate to an app-specific rollup when it's more mature at a different stage. That's the way that I think about it.
Got it. Okay. So talking about app-specific, I'd like to understand just your personal experience, because we were actually just talking about on-chain privacy here, and you were here to kind of also listen to the conversation. And so that's kind of very much near and dear to a lot of what we're doing over here in Manta Pacific. And so just wanted to hear your general thoughts on, on-chain privacy, any personal experience with it. Yeah.
I would say that privacy is actually probably one of the most important problems to solve after scalability, and these are just the general user experience, because without privacy, I don't know how much people will really want to adopt blockchains. It wouldn't feel right if all of your activity, we already feel bad that our browsing history might be something that sophisticated people can look into or whatever. But imagine if literally all your financial activity, almost everything you do on chain, that is the state of things right now. It's very easy to de-anonymize everything you do, and that just is not going to fly, I think, at scale and for mass adoption. So I personally not really experienced that. I don't think about it too much because I'm not doing anything sketchy on chain or something that I'd be embarrassed about. But I think that would change over time as blockchains get more and more integrated into the real world in our daily lives. I don't really care that much if people would see a DeFi transaction I do, or that I'm staking or something. But I don't know. I think that will change. Yeah.
But I want to challenge you on that, right? Because I think it's a common sort of misconception that people think, oh, I'm not going to do anything sketchy, so I don't need the privacy. But I wonder, on your MetaMask wallet, how many addresses do you have?
That's a good question. I probably have 4 or 5, maybe.
Okay.
I'm not sure.
So why do you have 4 or 5?
Well, some of them are, cold versus hot. Like some of them have different like permissions or whatever that I granted to smart contracts. Other than that, I don't know. Yeah, there are some times where I've tried to isolate certain things.
Right.
Yeah, that's true. Yeah, although it's hard. I mean, like basically what I've done is like I would, if I want to do something that is not linked, I would deposit or deposit funds into a centralized exchange and then like withdraw them. That's the best thing I can think of in terms of, I don't use like Tornado Cash or any kind of like.
Right. I don't know if we can use Tornado Cash.
That's true. Plus it costs a lot.
Yes, very expensive. Going back to the gas fees and the data availability and why that's so valuable. Yeah, so I think like, yeah, it's, people tend to think that on-chain privacy matters, but it doesn't matter to them. But then we see ourselves kind of doing a lot of proxies in order to achieve that privacy as well, right? Like, and you're right, like multiple wallet addresses doesn't really solve the problem, because when you end up having multiple wallet addresses, you have USDT on some, USDC on others, and then you can't move any of it because you don't have ETH on anything. And then unless you send your ETH through a centralized exchange, then you're just going to link your wallet addresses again just to pay gas fees. And so it's this conundrum that currently exists. And I also agree, like it doesn't scale. When we're looking at Ethereum with 300,000 daily active users, or daily active users, right? Really wallet addresses. How many of those are users and how many of those are bots? We don't know. But like it's peanuts in comparison to like 10 million daily active users on something like a Duolingo, right? And so like if we really want to get to those 10 million daily active users, and those 10 million daily active users are all making 10 data points on the blockchain every single day throughout their entire day, right? It's a massive surveillance tool. And so when you solve the on-chain privacy problem, and these 10 million people now make those 10 data points every single day, yeah, sure, that's great, but also it gets back to the scalability issue, right, and the cost. And so I think like this all kind of goes hand in hand on the scalability, the modularity, and also the on-chain privacy. And so like having these kind of combined in our minds, and this is kind of why we wanted to start Banter Pacific, is like that perfect solution that exists today that allows people to actually enable these sort of zk applications, zk use cases, and start protecting privacy in a much more scalable manner. Yeah, so that's kind of the Manta Pacific thesis. But when it comes to privacy, right? Like, and this question was also asked in the previous panel. So it's always a touchy subject of regulation, right? And so I know with Celestia, you guys don't have to deal too much. Or I assume you don't have to deal as much as a privacy project does with things like money laundering, traceability, and all that stuff. But like right now, regulation is definitely a very heavy topic in the Web3 space, especially around securities. And so just kind of want to understand your thoughts, because there's such a discrepancy in how things are being handled between like the East and the West right now. And so where do you think things will kind of shake out here in the next 3 to 5 years?
Well, I don't want to like speak too much on the subject, just because like I have fear about saying the wrong thing. But what I would say is that the last couple of weeks have been a huge win for the industry in terms of the Ripple ruling. And it's funny because we all thought that with Gary Gensler coming into the SEC as the chair, that he would be very crypto friendly because he taught that course, and turned out to not be the case. And so it went from like an already bad situation to like the worst than we could have ever imagined in terms of regulatory clarity. But these recent rulings are kind of like clearing the path there. But that's from a security standpoint. In terms of privacy, that's something that I don't think about much, and I think we're very fortunate that, like, as a data availability layer, we basically do nothing on chain except provide data availability, and people can pay fees for that. So we don't have much other regulatory surface area, which is a big benefit, I think, of the modular stack. And so we'll let people like you guys deal with that part of the problem. Nice. But actually, well, one thing that I will say about this is another superpower of the modular stack, is that it allows you to launch your own blockchain without actually having to issue your own token. And yes, issuing your token can be like a way to like have a business model, although I think that's very short-sighted for teams. But also issuing a token is very risky. It's a huge amount of work. But like if you're building the Cosmos stack right now, you have no choice. In order to launch your product, you want to launch a Cosmos zone, you have to issue a new proof of stake token. And so I think that's actually dramatically limited the number of people who have actually been able to launch a chain. And so, Celestia is a like consensus network out of the box that you can basically rent. And so you don't have to go through that overhead. We've done it for you so that you don't have to. It's one of the metaphors I really like, and this comes from, I think, Dan at Cosmology, is that, no one asked Jimi Hendrix to build his own guitar, to write his albums. Like he doesn't need, well, that's kind of what we're asking of current blockchain developers. It's like, oh, well, if you want to build your own chain, you should literally know the whole stack and be able to build your own guitar, to write and sing your songs. And that's just not something that scales very well. Kind of like your seatbelt analogy. So I think that even carries through in this regulatory vein of like not having people have to worry about issuing a token.
Got it. Yeah, I think one sort of common theme I'm kind of pulling from this is, between us, it seems like this idea of providing as a service, something that people don't have to actually build from scratch, is probably like this next sort of trend in order to build these next generation applications for focus on user adoption.
Yeah, exactly. That is kind of the core of the modular thesis. Is like, why are we all duplicating the same effort when we could just pool our resources together and reuse other people's components that they built? So I could not agree more.
Yeah, and also fun fact, I was actually Gary Gensler's TA.
Are you kidding me?
No, yeah.
Oh my God, that is crazy.
Yeah, so it was interesting. It was interesting, and honestly, when he became chairman, I think everyone was very bullish, and I wasn't. Yeah, I was a little bit more conservative about it. Yeah. But anyway, enough about the sort of regulatory side. So I mean, Modular Day is coming up, right? And you guys have been hosting this for a while. Do you know how many modular summits have been already hosted on?
We did the first modular summit last year in Amsterdam at DevConnect, and this is our second one. And the first year was 1 day and 1.5 stages, and this year is going to be 2 days and 3 stages. So there's it's crazy to see how much the modular ecosystem has grown in the last year. And at first we were thinking, oh, we'll just do 1 day and 2 stages, but then as we looked around and started tallying up all the people that we thought should speak, we realized that there was just not enough space. So we had to extend it to 2 days and 3 stages. So
Tell me about it.
It's going to be awesome. I encourage people to apply for a ticket. Unfortunately, it's kind of capacity constrained apparently because there's riots, or they're very concerned about the safety. So we have a strict capacity limit, but there's also going to be a live stream online that people can tune into.
Nice, yeah. Congratulations on all that success on Modular Summit. You guys put a lot of work into it. I know Vitalik's speaking there this year as well, right?
Yeah, Vitalik is speaking on day 2 at 2 p.m. I think.
Yeah, I think Kenny's speaking on day 2 as well.
Kenny's also speaking on day 2. I think in the morning, right? I think you're in the morning.
Check my calendar.
Yeah, I think you're in the morning. I'm pretty sure I slotted you in. Yeah.
Thanks. Awesome. Yeah. So I mean, from my perspective, it sounds like there's a lot of, I hate to use the word synergy, but there's a lot of commonality on what we're doing, right? And I think it echoes a much broader theme, a much broader trend that's emerging in the space where people are no longer focusing on, hey, let's build cooler, shinier technology. I mean, yeah, there's still a focus and it's very much a need, but I think people are starting to really think about, okay, I only have 24 hours in the day, right? What do I spend my time on? What do I want to focus on? If I want to build something, do I really have to worry about everything else that kind of comes in and building that from scratch? Or are we able to apply it in some modular manner? And also, to be continued on Modular Summit, because we've just run out of time.
Sounds good. Thank you, Kenny.
Thanks, Nick. Really appreciate the time. This is a really fun conversation. Thanks for being so open about some of these questions.
Wow, what a great chat from these two. We forgot about time.
Nice to meet you.
All right, so next up is going to be a keynote from Neil Foundation. Let's give a round of applause for Neil.
All right, let's go forward. I guess everybody here pretty much aware about who we are. So this is going to be just a little bit of. So this is going to be just a little bit of update of what happened with us, like for the last half a year, what we have achieved, what funny things we have done, and what we're about to do, I guess. Let's go. So what we are is we are kind of zk infrastructure for zk applications, trying to be like computations marketplace for zk applications for Ethereum. For the sake of this, we have a combination of circuit compiler plus book market, and I guess everybody here knows about it already because that's the specifics of this audience. So yeah, for the last half a year, it turned out that luckily the community has realized that the proofs can and they are commodities. So we kind of put this idea into people's mind, and now everybody's building proof markets. Like all the damn goals have their own proof markets. So that's a separate thing for us to be proud of. Yeah, well, very schematic explanation of what it was this. Yeah, so what are these points like about, right? It's like, it might seem like a couple of those are just marketing bullshit. The first one, it's a more interesting one because for some time on our side, it wasn't possible for Ethereum applications to order computations they need directly from EVM. We have, like, about a week ago, we have released the EVM endpoint on test Ethereum cluster. I was like, what? So basically now EVM applications, if they need some kind of computation, I know for zk bridging, for proof of storage, for zkML stuff, or I don't know, anything else, they can just come by to some particular like address on Ethereum, order that in there, something like, hey, I need proof of this particular computation of this particular statement. And it's like all automatically, you don't need to go like get it or anything. So the Ethereum endpoint is there. Yeah, that's like just a typical picture we've had in front of our eyes for the last like half a year, right? So there were like it's like more circuits are coming and circuits are going because some of them are shit, we're moving them, and some of them are good, we're letting them stay. But anyway, people are actually, like trying to buy and sell computations, like proofs of necessary computations. People are trying to actually speculate with that for some reason. Anyway, so yeah, so what is the well, yeah, it kind of says it all because it just says because it kind of just highlights the fact that this is a product with open data. So that's what it is. Just a little bit of a stats of what has happened with the proof market for the last, like, half a year or something. Some beta version of it was launched in the beginning of like 2023. During that time, we processed about 60,000 proofs, orders, and for different applications, like some Mina stuff, some various circuits for other applications, for Oracle, storage booths, accessing Ethereum historical data, for example, or I don't know, like ZKML proofs, even ZK gaming proofs. It's like 3G ZK gaming game. And what's the EVM endpoint? That's basically what I've highlighted already. It's like we deployed it about a week ago, and now I would say that the liquid gates to proof markets are open because all of the stats we saw previously were from a test version of it. I mean, it wasn't like a production version or something, it's just a test version deployed, and no matter that, people still are trying to do something on top of it. So now the Ethereum endpoint is in there, and it's much easier. It's embeddable. Now it's like embeddable and composable with Ethereum applications. That's what it is. For the sake of people to be able to write circuits, not just to define the computations they need circuits, right? And to build circuits, you gotta either do them in a custom way, like build up a payload to or something, or you can just do something more high level and compile that into circuits. So zkLVM was one of the first circuit compilers as well, and now we obviously have competitors and different circuit compilers, and I'm really glad they're here. And so I have no idea that it's anything, but anyway, so that's like all of the reasons we have created zkLVM for. It's circuit compiler. All right, everybody knows that. So now we can confidently say with Ethereum endpoint, we can confidently say that we are, like Ethereum computations marketplace, like provable computations marketplace, with it's like we are coming towards release of Rust frontend. So that means we're also going to be able to handle Rust and like besides TDP, and we're also coming towards ONNX frontend. So we'll be able to handle zkML applications as well with the custom frontend. Still no zkVM on our side. No matter, we're thinking that it would be fun to compile one without a compiler, just for fun. Because I mean, like, come on. Even Vitalik was complaining about this, about the fact that everybody just spoke to circuits and now nobody knows what the hell is inside. So that would have been fun to compile the virtual machine. And yes, the zkLVM compiler, it's seamlessly integrated to proof market. So in case you accidentally compile something large, you can prove locally. I mean, obviously you can, but it's going to take you a week. So if you want not to spend a week on proving something, there's a proof market for that. What the hell? Is it like? Is it okay? Guys, this thing died. Okay, it didn't. So recently we also got for the sake of fighting the performance issues, we got together with fellas which helped us with hardware acceleration. I mean, very particular fellas. Take a look at those, right? Sorry, guys. And that means that us matching the ISA of zkLVM compiler along with the fellas hardware ISA, we'll be able to get the hardware acceleration for whatever written with zkLVM out of the box. It's kind of a huge advantage for us because I mean, quite a lot of cryptography, quite a lot of ML applications, quite a lot of I don't know, just games, whatever. Imagine you try to compile some 3D game, right? It's going to take you weeks to prove it. Well, we hope not anymore. So this is another thing. Use cases which we got during this like last half of the year, all right? That was like quite a lot of bridges, all right? Quite a lot of ZK bridges that we have. Like obviously near folks, obviously our own Solana ZK bridge, obviously Ethereum consensus proof. Recently we got the layer 0 ZK Oracle deployed, along with all of these consensus proofs available to this Oracle. So that means there's their layer 0 applications are going to be able to use everything which is listed on the proof market for the sake of securing computations and securing their data transfers. So that means, we hope it will work out. which use cases we got ZK oracles. We kind of secured Lido. So now Lido is secure. Just be sure about this. In particular, what happened? We've secured the stats and data which is necessary to guarantee the correct issuance of staked Ethereum. So one of those circuits is basically just listed in there, and we don't have like a big threads on Lido's forum about this, and they're testing it out. So that's what it is. Like, I mean, why to go after small projects when you can just secure the largest one in the industry, right? Then rollups. We have listed. It's not the direct integrations. Don't consider it that way. We have listed circuits of Scroll and Starkware for the sake of their validators to be able to purchase them from the proof market. Using the proof market's capabilities, basically. It's just, guys, not a direct integration, okay? We've just listed their circuits. This might be misunderstood. Don't misunderstand that. Fun use cases, and you're welcome, like a Doom guy. So those use cases I've already mentioned. OiDNX frontend, enabling zkML applications through zkLVM, which makes the proof market like something like a marketplace for proven ML stuff to Ethereum. I mean, I don't like this hyped up thing. It's very easy to overhype this thing, right? So I'm trying to be careful. Another use case coming, I think, well, we hope by the end of August. I don't know if you guys are around, I can see you guys around, but they will definitely were around in the event. Those which are doing this kind of thing. It's we have kind of provable Doom to Ethereum demo upcoming. For those who wondered to play Doom on Ethereum, can you run Doom on Ethereum? Yes, you can. It's like, remember that old 90s flex stuff. So that's what it is. Yes, you can. My personal record for the first chapter is about 19 minutes. Beat me. It's like provable speedrun. zkML stuff. Well, yeah, it's just a schematic implementation of what's going on. Like, I don't even know that makes sense to describe what's going on. It's just a schematic. It's just a schematic description of what's going on. ZK gaming, yeah, pretty much the same. You just prove it. You upload the data to some storage. You upload the circuit to Ethereum. You verify it in there through this data, and you're good. You can prove your speedrun, for example, your Doom speedrun. Really, that's it? Okay, well, that's it.
Thank you, Misha. I think we still got another thing to speak, right? All right.
I do.
All right. So we're gonna have our last panel of the day. So let's welcome Queenie from OSG, John from Verdice, Misha from Nil, which he just spoke. Okay. And then Tian Sheng from Polyhedra, and Carter from QED Protocol. Let's give them a round of applause, please.
Hello everyone, I'm Queenie. I'm partner at IOSG Ventures, and IOSG Ventures is our early stage crypto native fund since 2017, and we have really good exposure in zk space. Before we kick off the panel, maybe I'd love to invite every one of you to give us a brief intro about yourself and what you're building.
Hello everyone, I'm Tian Chen from Polyhedra Network, and I'm CTO and co-founder of it. And currently we are building a universal interoperability solution between blockchains and using zero-knowledge proof technology. And we are announcing our new thing. It's called the proving full node Ethereum, where we are going to prove like 30,000 signatures in our zk prover at once within 10 seconds. And it will be a very exciting announcement.
Hi, I'm John. I'm the CTO and a co-founder at Verdice.
So Veradice is a blockchain security company. So basically what we do is, we perform audits for all aspects of the blockchain, and importantly for this conference, we have audited zk circuits, but more importantly, we're also building tools for finding bugs in these zk circuits automatically. And so we've built tools that will perform static analysis over a variety of languages like CircOn and automatically identify potential vulnerabilities, as well as formal verifiers that are capable of reasoning about these circuits themselves in order to formally verify and find bugs in these circuits, because we found many, many bugs in the circuits when inspecting them.
I'm Carter Feldman. I'm a reformed hacker and former member of Xbox Underground. So I'm the CEO and founder of QED. We're zk layer 2. We're horizontally scalable. We have a new and quite interesting state call that we'd love for you guys to check out in our panel at 7 tonight. You can write zero-knowledge smart contracts in JavaScript and Python. It's very easy. So yeah.
Like for real, I just gave a big ass talk, so I don't need to introduce myself, I guess.
Yeah, right.
Yeah. So as the topic suggests, that every one of you here are building the zk infra for the next generation of Web3. So my first question is, how would you actually define or envision the next generation of Web3? What will be different? And what role will your project play in that?
Hello. We will say it's, from our perspective, everything is connected via our protocol, and our role is obviously the standard of transmission and the communication protocols between different Web3 blockchains and also between Web2 and Web3. So we are aiming to become the TCP/IP protocol of Web3, make everyone connected.
Yeah, so one thing that we've seen is, as I'm sure everyone would agree in this room, a lot of people have been interested in integrating zk or privacy features into their applications, and that's just because they don't want everyone to be aware of the transactions that they're making or to be DOSed. And so for that reason, the future of Web3 is likely going to have privacy features integrated into it. But the problem with privacy features is, given the history of Web3 so far, when there's a hack, it's hard to tell that, with a privacy feature, it would be hard to tell that a hack even happened. And so for that reason, for Web3 to progress, you need security assurances. And for that, at least at Veradice, we believe that it's very important to have security tools to, provide developers the means in order to ensure the protocol that they're developing is as safe as possible. And so I think the future of Web3 is likely going to involve privacy features, but also it needs to consider security.
Cool. Yeah, I think the future of Web3 infrastructure is just going to look totally different than it does now. I think zk is going to just gradually eat the rest of the ecosystem. So right now we see infrastructure that's basically dominated around full nodes. A lot of infrastructure for blockchain just consists of platforms like Infura, where basically you just have full nodes, and then dApp developers just write the front end from their app, and then write the smart contract, and then deploy. One of the great things about zk is that you can split up work and have let's say we want to process 10,000 transactions, we can prove 10,000 transactions with one node, 10,000 another, and so on and so forth, and generate succinct proofs that show that the work done by others is correct. And this ability to split up work should fundamentally be reflected in our infrastructure. And I don't think it will look anything like what we see now. Probably also some divergence, maybe specific, I guess, data availability providers, maybe a little bit more of specialization in that area for both privacy and application specific databases. I think proving markets are also definitely going to be especially if they're generic and they can be competitive. So you can have multiple proving markets, and it's almost like an exchange where or like DeFi, where I'm just trying to route through like the most efficient solution. Like this makes a lot of sense, right? So yeah,
it's like oh, come on, you brought me into this, right? So it's like you started this, it wasn't me. So first, it's like proof based DeFi or something. It's well, let the proof of markets emerge first. Let them emerge first a little bit, right? Because I see that there might make sense. I don't know, like proof arbitrage or something. I mean, there are already cases of that, and it's like we have already like requests of that. So that's one thing. Another thing is like proof-based DeFi or something. No, maybe, but let them emerge first. But like in general, in general speaking, yeah, proving costs will be taken into account in whatever kind of applications there will be, because I mean that's the first thing. Second thing is it's like all the verification costs are going to be taken into account as well, and not everywhere they will be better than just native EVM execution or something. That's the ones, and well, I guess that's what it is. It's just going to be like more, it's like even weirder price action behavior in terms of like price action. We're not talking about price action, but like costs of services, whatever it is, like exchange, anything. That's what it is, I guess.
Awesome, thank you. We have like a perspective from we have opinions from different perspectives. So to summarize, like next generation connectivity, privacy and security, and scalability, and the trustlessness, I guess. Yeah. Okay, so I'm curious, Carter, because you're building the scaling solution, because there are already a lot of zk-empowered scaling solutions, and some of them like mentioned or introduced the layer 3 concept or something like that, using recursion that we might be moving towards next chapter of hyperscaling. So how would QED differentiate from those solutions?
Yeah, sure. So like a lot of the other sort of hyper scaling solutions don't have global state, so you can't build like interconnected applications. So we have global state and we're scalable. We also have local proving. So there's a lot of reasons why QED makes sense for many applications, but I would say like you can build applications that kind of feel like Ethereum applications, and you get like a lot of the same data availability that you would see on an Ethereum application, but with horizontal scalability and guarantees that within a block, like race conditions, like you have very hard guarantees about race conditions. You can be certain that two transactions within a given block like won't affect each other's execution. So yeah, it's because of this state model that we have. It opens up local proving. It opens up submitting unlimited transactions for a fixed gas fee. It opens up just a lot of great stuff, and yeah, I think QED will definitely grow to dominate certain segments of the decentralized compute of the future.
Interesting, and it's super developer friendly as well, right?
Oh, sorry.
It's also very developer friendly.
Oh yeah, because you can write your smart contracts in JavaScript and Python. So yeah, there's a lot of JavaScript and Python developers. We believe in like democracy and trying to make blockchain technology as accessible to as many people as possible. I know Neil is also doing like a lot of great stuff in that respect with bringing C++ and Rust developers into the blockchain ecosystem. Like there is only 5,000 monthly active Solidity developers. How many monthly active JavaScript developers are there? Like if we're serious about mass adoption, so to speak, like it definitely makes sense to onboard mass developers first, and then let them build all of their great applications in a trustless manner, because users aren't able, they don't have the power to demand trustless applications from developers. Developers have to build on trustless platforms. Yeah.
Awesome. Nisha and Tiancheng, because you're building bridge solutions, so there have been trade-offs in security, decentralization, and scalability in bridging solutions for quite some time. So how would zk better solve the problems here?
Yeah, so there are three aspects, like scalability, security, and the decentralization. So if zk comes, the first one we are going to solve is the decentralization problem. the zero knowledge proof provide the validity of your execution, then nobody can actually be malicious. So decentralization is all about protecting the integrity of the proof of the execution. Then zk comes, it becomes a replacement. So you only need a few hundreds of machines scattered all over the world. That's the maximum decentralization requirement for zero-knowledge proofs. This is to ensure that at least one of the nodes is actually working. So as long as there is one node working, then your protocol is live and the security is guaranteed by the zero-knowledge proof. So decentralization can be solved. And the two things remaining is the scalability and security. And let's focus on the scalability part, because security is all about the bugs and code that cannot be avoided by anyone. And the scalability we are providing the state-of-the-art zk protocols. And I personally invented a lot of different zk protocols. And also zk Bridge was my previous paper on CSS. So scalability can be solved by our new protocols, such as our new protocol in the Virgo. It's a paper in 2019, and now we are going to industrialize it. This protocol can even prove more than 30,000 of signature circuits at once in one machine, actually. So this is a huge leap from whatever other protocols to our Virgo protocol. It's more than 10 times faster than them. So scalability can be solved by our protocol. And I think this protocol will be much, much more popular in the future. And we can scale up all kinds of blockchains. Thanks.
Misha, do you have anything to add?
Well, it's like, let's say this way. It's like, let's say this way. First of all, regarding the scalability and just two different things, and it's hard to There is a lot of argument going on about this, and there are folks which are trying to say, it's pretty much the same. In fact, if we're talking about roll-ups or something, that's the nuance. So can it be solved? Well, yeah, but in each particular case, it had to be crafted manually. It had to be very carefully crafted, and it's it takes time. I mean, take a look at zk Bridges, for example. Back in 2021, we had no idea that this is going to become a thing. And now people writing papers, building zk Bridges, and dozens of them. And the point is that, it just takes time. It just takes time. It has to be carefully crafted. That's the nuance.
Thank you. So we've already seen a lot of hacks on bridges. So John, from your point of view, how can zk Bridges mitigate some of the attack vectors?
Yeah, so there's a couple of things that zk Bridges can do better. And so in terms of hacks that are on bridges, there are some things that you can't defend against. So you've got something like Nomad where due to a developer error, something bad really happened. zk is not really going to help with that, because if someone upgrades their contracts and those contracts are still buggy, bad stuff will still happen. But on the other hand, there are a couple of good things that you can get from zk. So one of them is the verifiable compute. So right now, at least the way most bridges work is you've got essentially two other kinds of bridges. I'll simplify it a little bit. So you've got the centralized version where it's essentially a single entity who's doing the bridging for everyone. And then you've got this decentralized method where similar to a blockchain, you've had validators who are going and validating, yes, this transaction did happen on this chain and it should be bridged over, right? And so the way that this helps is, at least for with zk, you can now prove that a particular transaction happened on another location. And that means that now you can have basically direct communication from one particular blockchain to another without relying on this extra source of information, which would be validators. So that means that there have been some cases where the validator pool has been too small, and as a result, invalid transactions have been able to be submitted to another chain, and that caused loss of funds. So this is something that zkDay mitigates, because with zkDay, you can prove that the transaction happened, and as a result, you can have a reactive blockchain on the other end of the bridge. The other thing that it can help out with that we don't really see as much, but is censorship. Censorship. Resistance. And so, for example, with like a centralized, or even in some cases a decentralized bridge, you have to worry about someone refusing to, let's say, bridge a particular user's funds. And with the zkDay bridge, as long as the transaction happened on one end, a user can prove that that transaction happened and submit it to the validator or the verifier code on the other end of the bridge. And so it kind of helps with those two aspects, one of which has directly caused hacks. The other one, it's arguable whether or not that has actually happened or not, but yeah.
Thank you. I hope we can get next generation security. Okay, cool. So I believe most of you would agree that we're still at very early stage of zk adoption. So as we can see, all the zk algorithms are still evolving. So how would this evolving algorithms affect the system or the product you're building?
I think this. So we ourselves is inventing new algorithms. I think it is very good for us because we are using new algorithms and we are embracing new algorithms. So and after this, our Virgo algorithm we will implement my next paper. It's called Oreo, and I think it will be much faster than previous one. So we are actually the inventors of algorithms in this case.
Yeah, so this has kept our life very interesting, because as people are introducing new code, then that causes things to become more difficult. So at least here, what I'm talking about is basically proving systems. People keep adding new proving systems, and that is great because it can bring proving times and stuff like that. However, a lot of these proving systems are being developed by individuals or people who aren't, who are very smart, but, even if you're very smart, you can make mistakes. So let's take a look at, Nova recently. And so with Nova, for example, you had some very smart people who were implementing a proving system, but they deviated slightly from the paper. They implemented, I believe it was an optimization that they thought shouldn't affect the correctness of the protocol, but it did. And so the problem is when people end up creating these algorithms, a lot of times they aren't, or people using them aren't considering the security implications of those proving systems or algorithms themselves. And so at least for someone in my position, that makes our job a little bit difficult because no one wants us to audit their proving system, let's say. And so for that reason, it basically just is increasing the trusted computing base, and that is dangerous, as a very recent example shows.
I'm very curious who didn't want you to audit their proving system, because you should be public with it so that everyone knows not to use the proving system. But anyways, yeah, for QED, I don't know, but yeah, that's very sketchy. But yeah, for QED, I think, and everyone in general, proving systems are, we do not have a concrete, best in class proving system right now. And I think, during this period of maybe several years, who knows how long it will take before everyone kind of converges on a solution, if they ever converge. We will hope, obviously, to see that in proving system A, I can recursively verify a proof for proving system B, so that we have some kind of compatibility or some kind of type of composability between proof systems, just so hey, this is faster, and we have proven that it has the same security, and we still want to be able to interact with legacy code that's perhaps immutably and already deployed to the blockchain. If we have recursive composability that should solve some of those interoperability issues. Perhaps code bases that like rely on certain operations, like native operations, mods and prime, where like the prime has now changed. Obviously, the logic of your application will need to now change. But yeah, no, I think I don't think the addition of new proving systems will like affect QED very much in particular. Like we have like a very light, I guess, code base that actually interfaces with our proving system. We have a lot of abstraction on top of that. And I think like most projects in the industry have some kind of a abstraction layer on top of the proving system, just so that you can switch in and out as is necessary. But yeah, very optimistic about how things will be good going forward. There's been such great, like very fast progress. Obviously, what you've told us today has been very impressive. But yeah, lots of great papers coming out.
Security is not only about the proof systems themselves. In most cases, it's about what you do with it, what you prove with it. I mean, it's like even I know like that's an old flex psychedelic. A lot of folks have just assembled a lot of very complicated circuits, and now nobody knows what the hell is inside. Nobody's even coming to proof system security in that case because nobody knows what's being proven, and it's like it's just a big, large black box. So the security issues are not about in most cases they're not going to be about like proof systems. It's going to be about circuits. Somebody's going to screw up the circuits really bad, and this will end up with all of us like losing a lot of money because of that. So that's going to be like an interesting. That's going to be an interesting situation. I'm looking forward to. I mean, we from our side are trying to prevent that, like as we can, but like I bet there will be such a situation. Please don't let that happen, right?
Yeah, please know zk. We like zk native. Let one circuit fail, not all of them. I think
it's not about that.
Really?
Yeah.
Okay.
Thank you. So as far as I know, like most of the zk systems or products, they're still operated in a centralized way. So I'm curious, what parts of the tech stack of your systems need to be decentralized? Do you have any plans for it? Any challenges or bottlenecks need to be addressed? I guess it's more relevant to Tiancheng, Misha, and Carter.
Oh, so as the zk bridge paper already stated, the vulnerability of zk bridge is the security requirement of zk bridge is you require at least one honest prover. I mean, one prover, not honest. Honest can be automatically from zk. So the labor of decentralization only rely on only need to satisfy this requirement. At least one people that is running. So I think we should have like somewhere between 10 or 100 of nodes should be enough, more than enough to secure this thing. And it should be globally distributed, so it will not be affected when somewhere gets something really bad, right? And so that's pretty much our decentralization requirement. Yeah.
Then that's about decentralizing the prover.
Yes.
Yeah, got it.
Awesome. Yeah. So for us, like we allow anyone to participate in our decentralized proving network. Like I guess maybe I could just talk a little bit about some of the design goals behind that. So like we want to make sure that like the barrier of entry for people to participate in decentralized proving is as low as possible. Like we don't require that. Like we have a very clear separation between like nodes that are incentivized to do data availability and like solve data availability challenges, where basically they're like providing a Merkle proof of some random index in the global state tree to show that they have it all available at once. Yeah, for us, like decentralization is just all about making sure that everyone can participate in proving, and for our data availability network, that like everyone can participate in data availability mining, and essentially like the people who are determining who gets rewarded with like mining credits or our token eventually once we launch a token will be the people that are actually doing the proving. So they will select like the data availability nodes that have the best I guess the best speed and the best availability in terms of like the amount of like historical data that they have of the network. So yeah, it's all about incentives and making sure that the incentives point in a direction so that like instead of the network converging on like a few big players, it actually is incentivized to kind of grow out. But yeah.
It's not only about incentives, but I do agree. For example, in our case, the proof market also needs to be a little bit more decentralized than it is now. Not only because of incentives, but because you need to make sure that incentives just whatever you can pay, whatever you want, it doesn't matter. It's all about making sure that proofs are valid, which are being provided by the proof market are valid, and they can be trusted by the application. And it's like that. There is no way this proof was done by some fault body. And is the decentralization about trying to avoid the clusterization of proving power on like one big server or something? It's not a big deal. I mean, it's no competition. It's whoever gets the best hardware, whoever gets the best performance wins. So it's obviously no problem with that. I mean, people will come up with faster hardware, people will come up with faster stuff. So it's no worries. The clusterization and cartelization of this thing is not a big issue. And once the cartel falls, new players come back. It's a free market, so there's no need in decentralization about that. But yeah, the protocol which powers this kind of proving markets, it needs to be decentralized because provers are free to generate whatever shit they want, just upload it in there. And if it's not verified fast, cheap enough, if it's not stored all of it in there, then well, we're having problems that a lot of applications and like whole industries just relying on faulty proofs. So that's what it is. These kind of protocols need to be decentralized. We're going towards that. It's like we started talking about that recently. It's not like we're something public yet, but we started talking about that recently. We gotta go, and we are going towards the decentralization of the market. Yes.
Just if we have a second, like so the way to deal with faulty proofs is you just check them, right? Like I don't care if Osama bin Laden is making my proofs as long as like the proof is valid, right?
Yeah.
So
we welcome Osama.
Right, exactly.
We love Osama.
Yeah, so let me add some point. So as I previously mentioned that the minimum requirement for our decentralization is like 10 to 100. We are still a permissionless network and we embrace everyone as a prover. We welcome people to join our network. So we believe that our final network size will be way more than 100. So yeah.
Awesome. Actually, I'm curious, Misha. So the proof market that you're building is actually very flexible to fit in like different protocols, decentralized prover, right? Okay, got it.
I mean, it all depends on the particular application. See, it's like for some applications, it's critical for this thing to be secure and decentralized before they use it. For example, we have cases folks were trying to build L3s or L2s, and they needed to prove the entire. There's like each state transition of theirs needed to be proven, and that was quite a huge one because I mean, some custom VM or something, things like this. And in the end, this all resulted into them being in need of uploading all the data of theirs, of the commit log of theirs, to the proof market for the sake of it to be able to be proven. And that means that they are aligned with their liveness on the proof market. So that means, I mean, it's one of those things. It's one of those cases for which we need to get it decentralized and secure it first before we would be able to process that. So, but yeah, I mean, like in general, that would allow the composability, the protocol level composability of the proof market, because I mean, once it is fully decentralized, folks will be able to do like a proper composability. Some partial composability on ours, I mean, like Ethan's point I was talking about. Yeah, partial composability. You can like use it on E. Is it like, like the end game? No, not really. It's just the first step. So yeah, yes, that's what it is.
Got it. And I'm also curious about decentralized sequencers. So I believe it's a topic related to shared sequencer as well. So I'm curious, like, are there any overlaps between the shared sequencer and the zk bridges?
I see. So shared sequencers is about making different layer 2s as a unified entity. So it will simplify our workload because we know that we are talking to a shared sequencer, so we don't need to deploy our stuff across a lot of different L2s. For example, if a shared sequencer protocol has 10 L2s, then we only need to talk to one of them. Yeah, so it will benefit us a lot.
Oh yeah, okay, I finally got the question. It's I was thinking what the hell. All right, I finally got the question. It's like similarities in terms of both of them need to accumulate transactions and push them somewhere, and that's what it is. All right, well, let's say this way. We need like a great similarities. Well, yeah, both of them need to accumulate transactions and push them somewhere, but just for different reasons. And like zk bridging, you don't need to check the executability of it. You don't need like a specific protocol which does this. You don't need like a high frequency application for this to be like transparent and decentralized enough, things like this. You just gotta like put one blob of data like from one protocol to another protocol. I mean, with there. So it's I mean, obviously like requirements for accumulating transactions for sequencing or shared sequencers, no matter if it's like a just single sequencer, like shared one, whatever. Accumulating transactions for them much harder and requires much more work than just accumulating transactions for bridging. I mean, it's a step-by-step process. I mean, it's like you can get from one thing to another one.
Do you mind if I just comment? Like, isn't a decentralized sequencer kind of an oxymoron? Like, if we have an established like someone needs to decide on what an ordering is going to be if there's an authoritative ordering, unless you want to have it like generated like algorithmically, right? So like, why do we need to sequence network transactions? I guess that's kind of QED's like thesis is that okay, let's like separate state of each user and allow other users to read from the rest of the network state so that I can submit like a recursive chain of transactions without having to worry about like my personal submission being sequenced, like the order of updating my user in this like global state tree doesn't matter. So I don't know that like sequencing is always necessary for some applications it is, but not.
Sorry. So I think that's the point of decentralized sequencer because that's the point of shared sequencer. That's you talk about your application don't need to be sequenced, right?
But yeah, but like, why do you want what is a decentralized sequencer? A shared sequencer, sure. So it's not a decentralized sequencer.
So it's about solving your question. So if you have a application specific chain that you don't want to be sequenced a lot, you can rely on a shared sequencer.
But shared sequencer does not mean decentralized sequencer, right?
It's different.
Okay.
So shared sequencer is about, so for example, if you're only sequencing one chain, then the parallelization opportunity can be limited. But if you are sequencing 10 chains, it means that most of the data are data independent. It means that you can parallelize it in your CPU and make most of your CPU computing power from it. So that's my point of shared sequencer.
Yeah. Okay.
Thanks for clarifying. Okay, so I'm curious, like if in a hypothetical future that zk infra will capture most of the attraction values in our space, then what had to have happened there to get to this end state from like your point of view? Like, because it's still not happened yet, so there might be a lot to achieve.
Can you repeat your question?
Yeah, so I mean, for example, right now we can see the only adoption of zk infra probably will be zk rollups, right? But now it's still like OP rollups dominated the whole space with more than 80% market shares. So it's still very early stage for zk infra.
maybe I can comment on this.
Yeah.
I don't know about like the rest of the panel, but I think ZK probably needs like another 6 to 8 months, and then we're gonna see like a lot of projects launching mainnets. So yeah, like I think OP is sort of having its last hurrah. Yeah, I don't think it will take much time at all because people are just still building stuff, right?
So basically, when the service is live, and then traction will just be there.
Well, people are building all this stuff, right? So like, hopefully people will use it.
It's like the only thing you need to make it, the only thing you need to make it like more widespread is imagination and demand for this. So it's not about like being early or not early. It's about if there's a demand for that or not. If there are cases which can be solved by this or not. So basically, taking this as a compression or another privacy mechanism or something. That's like just two big use cases of this whole industry. It's all about compression and privacy. If you have something which can be solved with compression or privacy, yeah, you're welcome. So it's not about like timing to what it takes to get there, but it's about like use cases and it's about like demand. It's about what can be solved with this. So it's
Yeah, I think before we talk about use cases, it's like more about tooling, because we need more developer-friendly tools to be developed. So I think ZK is still like, compared to AI, we are still pre-Torch era, where we haven't had any PyTorch-like tool that can help developers to develop their tools, develop their applications.
Wait, but do we not think that there is demand for ZK applications? Like, we agree that there is demand for OP, right? If we could just have OP, but with much, much better security guarantees, I think there is demand for this now. Like, I think that's why OP exists. We have, like, if you look at Arbitrum, if you read their README, it is scary. It's very frightening how centralized these things are. Like, in the case of a fraud proof being submitted, there is a shutdown for a 24-hour period so they can update the contract. You know who has permission to update the contract? Arbitrum. So it's like, and who runs the sequencer that's submitting these proofs, which apparently have had a fraud detected? Arbitrum. So I believe that people put transactions on chain because they want security, they want trustlessness, and they want global state availability, right? Otherwise, they wouldn't put it on chain. It's just a slow AWS then, right? So like there is demand for this secure computation. And I think that if ZK, these protocols launch, then people will want better security with lower transaction fees than Optimism, because there's so many transactions on Optimism right now. Like, I really do believe the demand is here, but perhaps we disagree.
Awesome.
Yeah.
I really hope to see that ZK future soon. Yeah. So, Carter, you just mentioned some ZK applications. I'm just curious, like, have you guys seen any like interesting ZK use cases, maybe on your platform, or like you just have some interesting ideas to share with us? It's a quick one, like anyone.
I've just listed a bunch of very weird stuff being done with first. It's like beginning with the games, like proving 3D games or something, and ended up with proving, I know, some weird ML stuff or like weird storage proofs. I think like surprisingly, by the way, like storage proofs are being, it's like surprisingly storage proofs are having, I don't know, so much use cases that we haven't even thought about. We were like, well, okay, fine. It's like there are also attempts to get the FHE over ZK market running for the sake of being able to prove private data, and that's like a separate level of autism, I would say, because it takes you forever without like specific hardware to do that. But anyway, that's very special kind of autism, but without it, several like cases are not possible. With, for example, you need to prove something like you don't want to share with provers, and it's like some fellas, I don't know, like you can find it around this place, having proposed the idea that there is a prover extractable value, from the data which have leaked to provers, and they're like, just can use it without using it for generating proofs or anything. Just got the data, like, okay, well, let's go speculate the data somewhere. So that's, quite a lot of weird stuff is happening, to be honest. I don't know, like,
I like your weird ideas. Anyone?
Of course, zk Bridge, right? we are the company building zk Bridge, but still we use proof technology to other places. Like we generate your pictures from, and then you can verify it. But I think we still need some work to do to find some very interesting applications.
I guess one thing that hasn't been mentioned, so I'll go ahead and do it, is zk identity. And so people trying to have ways of proving their identity on chain, whether that's tied to their real life identity or whether it's some sort of virtual identity. And so, I mean, these are some of the projects that we've been talking to recently. I mean, other than that, there are zk bridges, currencies are also, or private currencies is another one which we haven't really touched on, but that's kind of an obvious application.
Yeah, I mean, gaming is pretty cool if you can do dynamic NFTs where, like, there's a lot of use cases where in dynamic NFTs, like, the metadata of the NFT affects its value. And of course, in those use cases, you want to, like, store that NFT metadata on chain. Like, you can imagine you have, like, a sword that's level 1, and as it upgrades over time, it becomes worth more and more money. You want to make sure that, like, if I'm buying this NFT later on, that it is of the level that it claims to be. So like we've on QED, we're working with like a lot of game companies just on building out really cool dynamic NFT solutions where basically you can write like a state machine for your NFT. And yeah, combined with local proving, it's like you can have these nice dynamic NFTs and part of your actual game logic for fun games, not just like Ponzi schemes with, I guess, a good looking front end, but like actual games. You can have part of that logic on chain and have it not affect UX to the point where the game is unplayable. So working hard there.
Thank you. It seems we're a little bit over time. Any questions from the audience? If not, maybe I'll just invite John to give us some tips to the developers who want to build in the zk space.
Yeah, okay, so tips for developers building in the zk space. All right, so one thing that we've seen, at least in the regular DeFi space, is some people will, develop their protocol, spend a lot of time testing it, and then because, they're low on money or other reasons, they'll decide to go ahead and launch it on mainnet without receiving an audit or anything like that. And that's completely up to the developers. One thing that I would like to caution about, though, is in zk, that's just not going to work, particularly if you're writing the constraints yourself. So the reason is because if you're writing the constraints yourself, an under-constrained circuit is going to appear to work just like your regular circuits. And so that's because any output that is consistent with your logic, if it's under constraint, will be accepted, but you're not considering other things that will be accepted. And so that's one of the problems that we have here in zk. And so at least at Paradise, we're developing some tools to detect these things in a way that's automated, but do not just write circuits, test them, and then launch them, because you will miss something. We have found a number of under-constrained circuits and a number of the audits that we've performed, and some of them could have very disastrous effects. I mean, I guess I'll keep it short and just leave it at that warning.
Thank you, John. I guess that's all about today's panel. Thank you, guys. Thanks for sharing your wonderful ideas. Thank you.
All right, please give these guys a round of applause. All right, next up is going to be our keynote number 6 of the day. Let's welcome Wei from 1KX. Round of applause, please.
So,
All right, promise you for those of you that's staying, you're going to learn something within the next 20 minutes. Hopefully that's going to be educational. So my name is zkDay. I'm a research partner at 1KX, and today I'm going to be talking about a really important topic in Web3, but I'm not going to reveal what it is just yet. Instead, I'm going to open with a question. Why hasn't blockchain technology reached 1 billion users? It's kind of the holy grail question that everybody in the space has been asking. And I'm sure today you've learned a couple of different aspects to why, but we have not. Okay, the slides can. One moment. Okay, there we go. All right, so to cite Vitalik in his recent article, he says that as Ethereum transactions matures into as Ethereum transactions matures into a tech stack capable of bringing open, global, permissionless experience to average users, there are 3 major technical transitions that will happen, right? Scalability, or the move to L2s, rollups, UX, or the move to smart contract wallets, or key management solutions, and privacy preserving primitives. So let's look at each of those in a little bit more detail. For scalability, we now know of really good paradigms to solve it, right? Just move to rollups. In particular, we're separating data availability and execution, and with more and more research into better consistent mechanisms and ways to decouple different aspects of a blockchain, such as PBS or builder-proposer separation, and data availability and zk execution, we can get better scalability. For UX, we have 2 main mechanisms for key management. First, we have MPC wallets, and second, we have smart contract wallets. And connecting those to different dApps are kind of connection infrastructure, such as Wallet Connects, that allows users to interact with any dApp with any key management solutions that they have. So we have really good paradigms for scalability and UX. And what I want to argue in this talk is that we do not have a good paradigm for privacy just yet. We have been exploring different technologies, such as zero knowledge, which are great for some aspects of privacy, but not for the entire thing. And so if you look at what has happened in the past, let's say, decades, or half a decade really, we have payment solutions, which is a very, very particular application. And we have anonymous contract calls that have recently been built. And more recently, we have this whole ecosystem of protocols that try to use zero knowledge, homomorphic encryption, multi-party computation, or trusted execution environments to support programmable privacy. And if you look at what each of the code projects do, they differ by a lot in the exact guarantee. And there's no systematic way of categorizing these solutions. And today in my talk, I'm going to hopefully bring some order to what programmable privacy actually means. So my talk will be on privacy and Web3. And you'll be on 3 parts. First, we'll discuss why do we not have privacy? Well, why is it hard to have privacy on blockchains? And why we actually need privacy for blockchain technology to reach our users. And second, we will dive deeper into what privacy actually is, which is actually a very hard question to answer. And finally, I'm going to be listing some concrete actions that we as users, builders, investors could help the ecosystem build better privacy solutions. So let's start by talking about why. In particular, why we have not, why it is really hard for blockchains to have privacy. So in Web 2, we have very centralized services. In Web 3, we have very decentralized services where nodes are permissionless, meaning anybody is able to run Ethereum nodes and provide data availability for rollups. And that data is publicly transparent. Anybody can read that data from Etherscan. So therefore, it's really almost like impossible to not have to have privacy, right? If data is publicly available on Etherscan. And whereas in Web 2, data is settled into different services. In Web 3, there are just publicly available and permanently recorded on a blockchain. So this is why privacy has traditionally been very hard. And if you can apply the advances in privacy laws, privacy regulation to Web3, effectively what will happen is this diagram. Okay, so suppose you go to Uniswap or OpenSea or any of your favorite D app, and we click on Connect to Wallet. This pop-up shows up and asks you, before accessing the service, do you consent to allowing people to extract value from my transactions? Like here I'm referring to MEV. Do you consent to having your transaction history be publicly available forever? And finally, do you consent to having that transaction history be tied to your ETH handle or email or any type of personal identifiable information, right? So show of hands, how many people would say yes to any of those boxes? I see one hand. That's good. So I would say if you ask people, the average user that have not used Web3, the answer will be no. These are information that will be very sensitive, right? It could be your salary that you take, right? It could be all your purchase histories, right? Imagine all the Web2 projects move to Web2, and when you pay them, it's publicly transparent that you have subscribed to a service for a number of years, for example. And so my argument is that it's clear that if we actually try to be transparent about the privacy guarantees about Web3 technologies, users will actually not opt into this. Like no one will click. Well, I think majority of users would not click a consent, right? So it's clearly a problem. And feel free to disagree with me, offline, and we can debate. But let's now talk about the what. So what is actually privacy? And I want just to take a moment for everyone to kind of think about this question for a second. Think about ways that you do not want information to be public, and think about ways that sometimes information needs to be communicated to certain people. Okay? And now think about a way that you define what privacy actually is. And I found this really hard when I went through this exercise, which is why I'm going to be citing against a definition from literature. In her book, Privacy as the Contextual Integrity, Professor Helen Nissenbaum defines privacy to be this notion that it demands information gathering and dissemination to be appropriate to different contexts. Okay, let's unpack this a little bit. So first, privacy is not an absolute notion. It is not that either all my information is private or all my information is public. It is a flow of information. You have the information that's created right when you create a transaction. You have the information that flows to different places. So for example, when you go to Etherscan, when you do a transaction, that's information flow, where that information gets permanently reported, right? But you can have different flows. And what is in the example context? So different contexts demands different information flows. So for example, in a poker game, the rule says every single player's cards, when you have the card dealt to your hand, should be private to you, right? The two cards that you have at the beginning of a poker game should be known to you only. And the community cards are hidden to everyone, and turn by turn, they will be revealed, right? That's a rule governing information flow. Another example is, for example, in an auction where everyone places bids, and bids could, let's say this is actually a sealed bid auction where the bids are hidden. And effectively, for the functionality of the auction, only the winning bid should be revealed, right? If you have lost auction, you technically don't have to have the information be available to anyone. Finally, this is probably a more controversial example, is that in certain jurisdictions, financial transactions involving people from that jurisdiction often have requirements on information flow. And this is, required by law in certain places for certain parties involved to record such information. And let me back up and say one more sentence here. So privacy is really controlling the information flow, right? You have rules that can say information should flow very freely, or you can say you have rules that control the information very tightly. Depending on the context, depending on the rules around this information flow, you can have better privacy guarantees, less privacy guarantees. But as technologists, we should build technologies that support different information flows. Okay, so that's the takeaway for this slide. And let's go a bit more into the details here. I'm going to define two types of information flow. Okay, the first I'm going to define as sovereign privacy. What does that mean? It means that individuals, right, who owns the data should have full control over how the information flows. Okay. This means that if you don't want to reveal information, no one can force you. But however, if you want to, you can reveal information to anybody that you want. And on the other hand, I'm going to define this notion called rule-based privacy. What does that mean? It means that there's a set of rules that governs how information should flow. The data owner does not have a say, and the rules by themselves says how information should flow. Okay. And on one hand, for sovereign privacy, I think it's really important for the base layers to perhaps provide this notion to have neutrality, because rules are by default subjective. And on the other hand, for sovereign privacy or rule-based privacy, it is important in certain application and social contexts, because there are rules in poker, there are rules in different games, there are rules in many different contexts, and it is beneficial to enforce the information flow in those contexts. Okay. And finally, it turns out sovereign privacy is really easy, well, it's easier to build with technology that we have. Because by default, you have a full privacy guarantee and you have control of the information flow. It turns out that's the easiest first target to build with technology that we have. However, rule-based privacy is very, very complex to build, because you can retroactively say that a piece of information should be opened. And allowing that functionality is actually very hard, harder to do with our technology. Okay, so to sum up very briefly, sovereign privacy, you have complete control over how your information flows, but they're private otherwise, right? Rule-based privacy, the set of rules governs how the information should flow. Okay. And now let's look at rule-based privacy a little bit more in detail and look at what the rules can be applied to. Okay, this is the last definition slide, and we'll go through examples. First, you have the identity of the people involved in a transaction, right? Who are the senders, who are the receivers, who are the poker players, so on and so forth. And second, you have the contents of such transactions. How much money was paid, right? What was the message that was sent? And then thirdly, you have this time-based metric, right? You have the time of the transaction and the time that at which the information might need to be revealed. Okay. So, for example, let's say that suppose this scenario, transactions are set private to parties involved by default, but a DAO can retroactively de-anonymize and decrypt transactions based on some value thresholds or a blacklist of addresses. Okay, so in this description of the rule, you have identity, you have the notion of content, like the thresholds, and you have the notion of time, retroactively. Okay, so this is just a hypothetical scenario, which is very bad, right? You have a DAO basically do anything that they want if their members choose to do so. And let's look at another example. Suppose in an auction, the bids from bidders remain private to each bidder. And at the conclusion of the auction, only the winning bidder can claim the item and finalize the auction, but otherwise, every other bid remains private. Okay, so which of you think this is self-sovereign privacy? No hands. Rule-based privacy. Okay, so this is actually, in my definition, self-sovereign privacy. So the reason is the winner doesn't have to even claim the item, right? Like the information does not flow unless someone chooses to. And if you have a losing bid, the information is not even lost, right? So in this case, actually, there's no information flow at all unless the winner like goes and claims the item. Okay. So perhaps we can come up with better examples. Let's look at another one. Let's say transactions between a sender and receiver are private only to those two parties. However, at any later time, the sender can reveal who he paid and how much. Raise your hand if you think this is self-sovereign privacy. Okay, raise your hand if you think this is rule-based privacy. Great. We see hands for both. Because it's actually, I didn't give you the entirety of the condition, okay? It depends on whether the receiver can opt in, right? So on Ethereum, where the receiver cannot reject transactions, the receiver didn't even opt in to say, I received a transaction, and the sender can say, hey, look, I paid this person this much money. So it is actually not really a black and white. It's almost like a spectrum, right? How much control do you have over your information flow? In this case, I would argue that if the receiver can reject transactions, then this is sovereign privacy. However, if the receivers cannot reject transactions and the sender can just like send transactions to receivers, as on Ethereum, then this is more like rule-based privacy, where sender can actually make this actual point, right? The rule is, right, if you can send transactions to anyone, you can claim that you have done so. Okay, this might be a very solid example, and let's modify this example a little bit. Let's say that it's your transaction involving two parties, but we change it to neither the sender nor the receiver can unilaterally disclose the identity of the two parties or the content of the transaction. Right. If that's the case, then clearly this will be self-sovereign privacy because it's now the sender cannot say anything about what he paid unless the receiver agrees to it. And on the other hand, if we change it to, for example, that a DAO can view the overall aggregate net transaction flow for all such transactions, then that is kind of a rule governing how the information should flow, right? Whenever you do a transaction, you know that that piece of information will be aggregated. So that'll be rule-based privacy. So let me stop here and kind of summarize a little bit. So we just defined two separate notions. Self-sovereign privacy, where individuals get control of their information flow, and rule-based privacy, where there are rules governing the information flow. And the rules can be arbitrarily complex or sometimes minor. So lastly, let me try to explain what I think we should do to get better privacy solutions in this space outside of tech. So the first proposal is that we, as a community, privacy projects, and policymakers, or anyone associated with Web3, need to start differentiating between these different privacy guarantees. Okay, not all privacy projects, not all privacy solutions are made equal, and we should be differentiating between these. So let me give an example. If I can move the slide. So a bad example here will be if you a privacy project and you say our protocol is fully private. Okay, what does that mean? it's very vague, right? It's not, it doesn't give you information for the user to understand. It's like, what is private, what is not. A better example would be to explain, for example, that our protocol offers sovereign privacy for all on-chain transactions by default. Okay, then it gives a better sense of what type of privacy guarantee the project is giving. And the second example, for example, a project would say we offer self-sovereign privacy where the rules are governed by a permissionless DAO consisting of token holders who together can retroactively decrypt past transactions. Okay, so that's a rule that was explicitly stated in the protocol description and presented to the users. Okay? That's the first proposal. Second proposal is that once we do that, we should let users opt into these protocols with informed consent. Okay, once the project says exactly what is the privacy guarantee and the information flow, the users should be presented with concise, essentially privacy notices and opt into these. So the bad example will be, if your DApp just says connect wallet and you can transact directly. And the good example should be there should be essentially a privacy notice that informs the user what the side effects of the actions are. And finally, this is probably the only tech slides that I have in this talk, is that we should build tools and protocols with conscious awareness of this different types of privacy goals. Because it turns out self-sovereign privacy is really, really nice problem for zk to solve, okay? But rule-based privacy is actually a lot harder. It requires structured encryption, sometimes homomorphic encryption, and or usage of multi-party computation. Okay, and that is the end of my talk. Do I have time to take questions? Yeah, so let me sum up briefly. We have seen that blockchains do not offer privacy currently. Most of them don't, and it's really important for blockchains to offer privacy. And privacy, in my talk, has been defined as the appropriate flow of information, and we will have looked at two separate categories: self-sovereign privacy and rule-based privacy. And the proposal to go forward is for projects to explicitly state what type of privacy guarantee that they offer, and let users opt in. And we should have more research, into the different categories, with perhaps a better focus on rule-based privacy. Okay, so that's the end of my talk, and I will take questions. Yeah.
What kind of user focus more on the rule-based privacy compared with the self-sovereign privacy?
So you can imagine if you're building a game, like for example, a casino where there's a hidden information, like all card games, you want these rules to be built in whenever people join a game, right? Like a game of poker, or this could apply to other type of on-chain games where there's hidden information, right? That's kind of an example. Also, financial, outside of financial transaction, we just have people that pays each other. There's, I would say, a lot of different contexts where different sub-communities will want rules to be enforced without explicit consent from one of the participants, right? Maybe there are bad actors that you want to hold liable, right? Yeah.
So I want to go back to the first question you raised in the very beginning. So what do you think, why is the reason that blockchain now in which
Yeah, so I think it's a combination of all those three things. If you look at, if we solve two but not the third one, in all three cases, right? If you don't have privacy, if you don't have scalability, if you don't have good key management and UX, but with the other two, like I don't think we will reach billion users, right? We'll have to solve all three, and it's clearly we are moving towards that direction where we have scalability solutions that's being built. A lot of projects building better key management solutions and ways for you to connect to the apps more easily, and privacy. And you know, a lot of people are building around privacy, but I think there's just need to be a better paradigm, let's say, of understanding like what type of different privacy they are. We need all three, and we don't have all three before. Thank you.
Please give a round of applause again for our Professor Wei, please. All right, next up is gonna be our last panel of the day. It's gonna be the topic of zkVM, and then let's welcome the speaker from Alio, RISC-0, Seismic, Mina, and Cointelegraph. Please come up to the stage.
Clap, 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 clap.
Should we sit that way? I just went under my name, but I don't know if everybody else is. We'll make an intro round. I think it's fine.
Hello, hello. Oh yeah. So hello everybody. The steadfast few who stick with us to the very end. That's very welcome. Thank you so much. I think we have a stellar panel here to make it worth your while. And I want to keep this entertaining and spicy as much as we can. Bring the fire. Have the hard discussions. So maybe all of you could just intro yourself and your project in like 1 or 2 sentences. And also answer our first question, what you're most excited about by zkVMs. Is it the privacy aspect, or is it efficiency? And then like, what's your take about like interoperability between different zkVMs?
Okay, I guess I'll start. Hey everyone, thanks again for sticking around. Really excited to be here in Paris. It's always great to come here. So yeah, I'm Anthony DiPrinzio. I lead ecosystem growth at Alio. If you're not familiar, Alio is building a new layer 1 blockchain that's built from the ground up, and it's designed to allow developers to build private and programmable web applications using zero knowledge. So to answer your question, I guess, in terms of zkVMs, we built our own. It's called Snark VM. And I would say, yeah, the privacy aspect of zkVMs is probably the most interesting for me, although there's definitely a lot of other interesting aspects to that as well. I mean, if you know the history of zk, it was originally designed for privacy, and so that's sort of our main focus. Interoperability, I also think that's really important. I think there's a lot of interesting use cases where maybe you can like bridge, assets between different ecosystems. Maybe you have a public asset in one that could be wrapped into a private asset in another. For example, maybe like a USD-backed private stablecoin. So definitely, yeah, super important for the industry as well.
So yeah, thank you. My name is Florian. I work for O1 Labs. We incubated Mina protocol, the first sort of like zk blockchain. We are also working on something called zkDay, which isn't quite a zkVM, but it's even better. It's like I say, TypeScript toolkit for writing recursive zero-knowledge proofs. And I think we are all very excited for client-side app-specific privacy and also scalability, which allows you to do like all sorts of fancy app chains, application-specific, I guess, rollups with like client-side execution privacy in mind. So that is very fancy. And additionally, interoperability is also a very big thing with our recursion layer called Pickles, which allows you to sort of like combine all sorts of arbitrary proofs, recurse them, and then you have like a very, I guess, powerful recursive interoperability ecosystem.
Hey everyone, I'm Steven. I work at RISC-0,
at RISC0, we're building a zk VM that runs RISC-V. And what this means is developers interface directly with Rust, such that any existing program, any existing function, library on Rust can be directly ported onto our zk VM, and you can generate zk proofs of this. Something really exciting that I think this enables is programmability. zk traditionally is locked behind very advanced cryptography and math. The zk VM layer of abstraction effectively makes it so any developer anywhere can build zk programs using the existing skill set of Rust, C++, the traditional languages that they already have. And with regards to interoperability, I think we're on the precipice of having a lot of proof systems verifying each other, a lot of proof systems proving other systems. And I think we're a little far away, but within the next year or two, that will be possible, and this sort of composability is really exciting.
Hello, hi everyone. My name is Neil Fan. I'm at SciSig. So SciSig is building a hardware accelerator for ZKP, to make the proof generation for ZKP faster. So we care about more about the efficiency of the proof generation. The ZK hardware we're building is a programmable hardware, so it can support different ZK schemes using our hardware. And we are right now using FPGA to do the thing. Later this year, we are going to do a chip tape out for ZKP.
Thanks so much. That's super exciting. So my main takeaways were privacy and efficiency are actually not in competition to each other, but happen simultaneously. So that's super exciting. And interoperability is around the corner, and I think that's huge because it means that the tide will float all the boats, and this space will profit from each other. But for me as a dumb user, why should I even care about zkVMs? What does it do for me?
Yeah, I guess we got one mic. Maybe we can, the one you have, we just pass between left and right. Yeah. So yeah, why should an end user care about a zkVM? Well, I guess the ultimate goal is that in the future, all this stuff will kind of be running in the background. Maybe you don't necessarily need to know exactly what's happening. So in that sense, maybe you wouldn't need to care about it. But I guess at a higher level, the reason that you might care about it is because I think zkVMs enable a lot of different use cases that other layer ones might not support. The founders of Aleo, the reason that they decided to build an entire stack from the ground up that's designed for privacy is because they were Solidity developers that came from the Ethereum ecosystem, and they realized, hey, the EVM is great, it's amazing for certain use cases, but there were others that were just not possible, especially when you're settling on the EVM, right? It doesn't have certain opcodes that would support the types of privacy they were looking for. And so I think just from that perspective, it's really interesting to look at these different kinds of use cases. One thing I would say is, people always talk about, we mentioned privacy. Another way to look at how these zkVMs can be powerful is through security, right? So, the way our zkVM is designed, we have a private by default platform. So essentially, when you write and deploy a program on Aleo, you can decide as an application developer what information I want public, what information I want private, and that's all enabled by our architecture. And I think that's really great for trying to follow compliance or regulations that might come out in the future, which we don't know exactly what those are going to look like, but you have the option to actually evolve with those regulations and actually design programs that can be compliant. So I think maybe as an application developer, that's why we care, but maybe as an end user, there might just be some more interesting use cases that hopefully will be enabled.
Yeah, so I would just say that as a user, you shouldn't care at all. If you execute a Java application, you also don't care that you're running a JVM, I guess. You also don't care what is happening deep inside your computer, what operating system. Well, I guess you may care about your operating system, but whatever is down there, you shouldn't care as long as it works. However, for the developer, I think you should care a lot, and not necessarily about, I guess, generalized zkVMs, but maybe something like what we are building with Snap.js, a highly sort of a TypeScript SDK that allows you to write very specialized circuits that allow you to do very specialized privacy-preserving applications, not only on the sort of zkVM infrastructure level, but also on the application level. And by doing so, you can build very powerful privacy applications that run directly in the user's browser. And then again, the user shouldn't care what's happening. They should just like care that things are happening and that they are like, doing the thing that they are promising you to do. And yeah, ideally it's seamlessly for the user. They shouldn't care at all. And yeah.
I think if a user has a choice between non-zk and a zk application, what you need to consider is that zk helps minimize trust. I think the most prevalent use of this right now is zk bridging, but this can kind of be applied across a huge spectrum of applications. zkVM is specifically targeting porting every application, whether it's privacy or the applications you use outside of crypto. Your social media, your browser data. On our team, we've talked to governments, we've talked to energy companies, telecommunication companies, and all of this is to secure their programs. So at the end of the day, from a user, if you're choosing between non-zk and zk, most of these non-zk companies and projects are kind of secured by multi-sigs, just generally like structures that are kind of antiquated these days, while these new zk systems will enable more verifiable computations, which add an extra layer of security above what's existing.
Okay, yeah. So like from my perspective, there are like two bottlenecks in the zk community. The first one is of course the efficiency, like which like our hardware can solve part of that. And the second part is like the zk is just so hard for the programmer to learn to program it. And zkVM provide a very good way to interact with the programmer, which simplify their life, make their life much easier to program in zkVM. Yeah, so that's nice.
That's super interesting. So like, as a user, let's say there's this USD stablecoin T-bill backed on a zkVM. I would have more trust in this stablecoin on the zkVM than compared to one on an EVM, just because like I can be sure that all the computations actually happen the way it's supposed to be, or doesn't it make a difference in that scenario?
I'm not that clear about the stablecoin use case, but it's trust minimized. So you need to trust less parties. For bridges, right now you need to trust the multi-sig to relay your transaction to another chain. In this case, you no longer need to trust that organization, that multi-sig, because now there's some sort of zk verifiability in that sort of transaction. So you're minimizing trust, trusting less parties.
Awesome. Okay, that I think is great for me as a user. So we briefly touched upon that in the intros, and like, what's the main differences between your VMs and why is it better than the competition?
Yes, so we are better than the competition. That's very important. So what again, just to repeat what we are doing, we are building a TypeScript toolkit which allows you to write circuits in just TypeScript. That has a couple of benefits, but just to start with the very beginning, and also the previous panels have mentioned that there are just many more developers using JavaScript and TypeScript like any, I guess, like normal Web2 language than Solidity, or even learning any of these like highly specialized zk languages. So you get to use TypeScript, which is your favorite language. You can tap into the entire sort of like JavaScript, TypeScript ecosystem, the tooling, IDE support, package managers, whatever. And yeah, so what you can do with it is like you can write highly specialized circuits that do one thing very good, very efficiently. And then you can also, and then you're like not stopped by that. You can also do sort of like infinite recursion and composability with other highly specialized circuits. And you could even write a zkVM in the things that we are doing, right? So it's like you're not, I guess, sort of like left out. In fact, we have recently put up a proposal for the OP stack to sort of like, I guess, zkify the optimistic stack, and that is also running a zkVM MIPS, and it's all very easy to integrate, and you can do both, I guess, infrastructure zk for rollups, app chains, and all that, but you can also very easily inside your browser build privacy preserving applications on the app level?
Yeah, so I guess from Elio's perspective, I think one of the cool things about our architecture is that we have an entire mechanism through our virtual machine to bootstrap a network, and that's through our proving architecture. So basically, the high level of how it works is you're an application developer, you write and deploy a program on Alio. In this case, a program you could equate to a smart contract. It gets added to an on-chain program registry, which anybody can view via a block explorer. And then we basically have an incentive mechanism where provers actually run those programs by using their hardware. So we incentivize provers to compete against each other to solve a Coinbase puzzle at a set difficulty target. And by doing that, they have to generate what's called a polynomial commitment scheme. This polynomial commitment scheme isn't used in any applications deployed on Alio, but it is there just as an incentive mechanism. And it's actually something called proof of succinct work. It takes certain elements of traditional proof of work and a theoretical paper called proof of necessary work. And so I think that's, really cool, just being able to bootstrap this network of provers that can then create demand for generating zero knowledge proofs. And essentially, eventually there will be an aspect where you can outsource proof generation to a prover. So we call that like proofs as a service. So you can start to see an entire market forming around the generation of these proofs. You can almost think about it like, with Amazon AWS, right? You have AWS credits, maybe I need a server for something I'm trying to build. Same idea here, you have Alio credits, which is our token. You could use that to pay a prover to outsource this computation that you want generated. So that's one really cool thing. And then I guess the other thing is, so we have a zk DSL compiler called Leo. It's very similar to TypeScript or Rust, something a web developer would be familiar with. And although it is our own language that we've developed, it's directly connected to our layer one. So that basically means like, as an application developer, all programs are encrypted in records, so you have more fine grain control over those records. You can also get like on-chain data information and like information about ownership of those records as well natively. So I think there's a lot more fine-tuned controls that you can have as a developer if you're building on our stack. So I would say those are some of the reasons that it's really interesting to build on Alio, plus the fact that it's general purpose, so you can really just explore any sort of use case that you want. You don't need to be worried about fully understanding cryptography or writing your own circuits and that sort of complexity.
So just very briefly before I give you the microphone, Mina also has a decentralized sort of like prover market. It's called the Snarketplace. Very snarky, but also running in production. Just wanted to mention that. Sorry.
So I think the main benefits of building on the RISC-0 zkVM is obviously Rust, but there's also TypeScript with all these other protocols. The main benefits of Rust being it's probably a little bit more of a functional language. A lot of the libraries and crates can be molded around topics such as ML, data science, and things like that. But some of the most exciting stuff that we're doing at RISC-0 is our concept called continuations, which enables parallel proving, which I think is pretty unique to RISC-0. Effectively, this allows us to achieve about 2.5 million instructions a second on our zk proving network called Bonsai. I think this is industry leading by multiple magnitudes. And by the end of the year, our goal is to emulate the performance of a Raspberry Pi. That gives you some idea of what sort of zkVM performance you can achieve these days. And moving forwards, RISC-V is pretty interesting because there's a lot of similarities between RISC-V and WASM and MIPS. And we want to also emulate those sort of instruction set architectures, which enables us to also compile C++, Go, and a whole wide variety of languages. So we're ultimately just trying to build a product for developers that's really performance that developers can interact with, use all the existing libraries, and just fork all that Web 2 code and programs that they've already built onto zk.
Yeah, so actually I don't have any more thing to add. Like we are more on the hardware side to improve the efficiency of the ZKP. Yeah.
Excellent. I think we see like the delineation between the different products here. Maybe you can add a little bit, like, I think so. Developers are like all of you mentioned developers as like a target audience, but like what kind of developers are you looking for? Like, is it just app builders? Is it more like the enterprise market? Like maybe you can say a word or two about like who do you think your best target audience is or what you're aiming for there?
Yeah, from our company's perspective, it's really anyone. Just from our side, in terms of our partnerships, we work a lot with existing rollups, such as like layer 2 rollups, as well as app builders, application builders, DeFi, NFTs, identity, but also a lot on the commercial side of things. We're talking about governments, privacy institutions, KYC providers, other sorts of identity. So the focus here is really any developer. Any developer that has existing coding skills can leverage zk technology.
Yeah, so we certainly don't, I guess, lock out any type of developer as well. We obviously try to, I guess, leverage everyone that knows TypeScript, and that is, I guess, a big set of developers. And ideally, the idea is that to abstract zk and Bay to a certain degree, so people can simply like pull in the library, use the library, and that's it, and then they can like execute their program, and they get I guess, like a nice zk proof attached to it, which is very convenient. So again, yeah, we don't, I guess, lock out anyone, but we certainly do focus in Web3 developers who want to enhance their application with privacy, or maybe build application-specific rollups, app chains, or even maybe Web2 developers who want to use the benefit of privacy, client-side execution, stuff like that.
Yeah, I think like the other panelists mentioned, Aleo is also just generally targeting any developers that are interested in leveraging zk to build private applications. So if you go to our website, which is actually going to be updated in August, but if you go to our current website, there's actually no mention of crypto, blockchain, or like Web3 anywhere on the website. That was originally intentional because the founders of Aleo understand that zk as a technology is much greater than just Web3, and you can even, like everything that we build, you could use in a Web2 context if you so choose. It just so happens that a lot of the hype in zk is in Web3 because of layer 2 scaling solutions and all this sort of thing. And so, yeah, general purpose web developers is what we're after. Again, our DSL is similar to TypeScript or Rust, like languages web developers would be familiar with, so that's definitely the target audience. And yeah, I think one specific area is like game developers, right? We've actually got a lot of inbound from folks on that side. Main reason is because people are, most games are considered like imperfect information games where one user knows certain state about the game that the other user doesn't, and vice versa. Okay, well, if you want to decentralize a game, which we can get into a debate about, it's a different topic, but assuming you do, you need some way to maintain privacy, right? You have a few different options. There's fully homomorphic encryption, there's commit and reveal schemes, there's trusted execution environments, there's zk. They all have trade-offs. You can kind of decide what you want to work with. We think zk is one of the best options, and so essentially what we want to do is go to people and say like, hey, you want to build with zk? Here's the stack that you can use to do that, and you don't need to be a cryptography expert, you don't need to go through all these extra hoops to start building. And so, yeah, that's basically what we're targeting.
Okay, so then I think the two big camps that I've seen in my research on the topic is that basically allowing languages like either Rust or Solidity to kind of cross-compile to VM code versus specific languages. Maybe you can tell me a bit, like, I think we have TypeScript here, we have Rust here, and we have Leo there. Maybe you can tell me why you're after your specific solution, and like, how's that going so far?
Yeah, so like I mentioned earlier, so we have our own zkDSL compiler called Leo. Again, I think I kind of mentioned some of the benefits of using our language. The fact that it's directly tied to its own L1 is really important, again, for like bootstrapping our network, again, like allowing developers to have more of these fine-tuned access controls, especially in the beginning. We have talked about enabling other programming languages to target our virtual machine. That is something that has been discussed and could be possible in the future. But I think just to start, at least for us, it made the most sense to create the most optimized language possible so that people can, like maximize our platform, and then over time we can think about like, yeah, having these other programming languages target our virtual machine. I guess how that's going right now, like definitely telling people they have to learn another programming language is usually a negative, right? Because people already know other languages and they don't necessarily want to learn. But whenever we demonstrate people like different products and applications that have been built on the network and sort of these different like business models that they can, take advantage of, people then become more interested in using our language. And I mean, there's plenty of other projects that are building zk DSLs, and there's a lot of people experimenting with them. There's definitely interest there. Yeah, it can be a harder sell, but I think if you can share the opportunity in the right way, people are always open to learning.
Yeah, so I guess I probably see two big points here. The first one obviously being the onboarding experience from someone who's like working Web 2, just like build a website, maybe even for free, whatever. They could very easily tap into TypeScript, right? The thing is, TypeScript-like and Rust-like and Java-like languages are just like languages. They aren't the actual thing. And that sort of like brings me to the second point, which is integration into existing stacks from the, I guess, outside Web 2 world, as well as the Web 3 world, right? If you have TypeScript, you can easily tap into VS Code ID. It's just working. You have all your IntelliSense comments, whatever, right? You have integration into your package managers. You don't need to build a custom package manager just for your zk DSL specific language. You can use existing testing tooling and stuff like that. So yeah, like we are heavily focusing on TypeScript because we think, again, it's like very easy to onboard and also very easy to integrate into existing stacks.
So I think a benefit of Rust as a pretty functional programming language is you have existing crates that do ML, that do data science, as I mentioned. But something fun is you can run interpreters on top of Rust. You can directly go from EVM to Rust to our RISC-V zk VM. By doing this, what you've effectively built is a zk EVM of some sort, where you can run any existing Solidity code in our EVM and get a response out with a zk proof to verify it. In this process, you do lose a magnitude of performance, but we've been able to prove Ethereum blocks at about $30 to $50 of GPU costs, which comes out to a few cents of GPU time per transaction. But there's a lot of flexibility to this. There's also WASM, there's also MoveVM. So a wide variety of languages, of virtual machines, of execution layers can actually port from them onto Rust, onto zkVM. And similarly, similar to O1 Labs, we're looking at the OPRFP and moving Optimism, taking their execution layer, taking the OP stack and putting it onto the zkVM through Rust, using kind of a ref backend.
Yeah, so based on our hardware, we also have some kind of like ISA, so instruction set architecture. So like we basically define like several instructions like which can directly talk to our hardware and then can call like different part of the hardware to do the computation. Basically, like I did a talk this morning about how can we use the zk ISA to perform zk proof for zk EVM in about 400 seconds. So it's using Hello 2 as backend. So like we are also like accelerating other part of the proof generation to make the proof time shorter than that. Yeah.
And I think now we're a little bit deeper in the tech end. I wanted to ask you, like, what are the main challenges facing zkVM from a technical perspective? Like looking out in the future, like what is it that you find challenging from a technical perspective in like the next year or maybe the next 5 years?
Wow, okay. What's challenging? I think there's a lot of things. Just in general, I mean, zk is not necessarily the easiest thing to work with right now. I would say one of the challenges is making the hardware for like generating zero knowledge proofs in these architectures more efficient, which I think our other panelists have talked about. again, we're trying to directly address that problem through our incentive mechanism for the provers that I talked about earlier, which has yielded some like really interesting results. Another thing that we've done in partnership with a number of other projects in the space is the Z-Prize initiative, which is basically a bunch of projects coming together and putting out a number of different rewards for optimizing different operations, such as like multi-scalar multiplication, NTT, fast Fourier transforms as well. Yeah, and just various other aspects of hardware for generating zero-knowledge proofs. And our main goal is way down the line to have like every device, every computer with like hardware that can actually support proof generation like natively. That's something that's farther down the horizon, but we're slowly working to try and get that going. So I think that's definitely one challenge, especially when you're deploying applications, and sometimes they're a bit slower than maybe you would expect. But with time, I think that'll improve. And then I think also more broadly speaking is just like we need more robust like tooling and infrastructure for people to be building in these architectures. I work with a lot of developer teams all the time, and this seems to be the one area where we're constantly coming up with new things that we want to have to support these developers. I know it sounds very basic, but honestly, that is one of the biggest things. So yeah, I would say if we can solve those two things, I mean, I think we'll be getting much farther along. There's many other challenges as well, but at least two that I would think of right off the bat would be those.
Yeah, I have to totally agree with you. Zero knowledge is still a very foreign primitive to developers. From so many, I guess, perspectives, how to develop zk applications, how zk actually works. And then at some point, developers also need to figure out how they can leverage zk in their application, maybe be it like on the application level,